Jeffrey, you are in mute. Yes, you're back online.
Well, welcome to the Azure Community Conference 2021, India's largest Azure conference, and in fact, across the world, because here I am, Jeffrey Palermo, just outside of Austin, Texas. And thank you so much to the sponsors of the show, as well as to the partners. The conference wouldn't be anything without them. And also want to recognize the communities around who have joined with the conference organizers. So today, we are going to dive into Azure DevOps for .NET. And my goal for you is to fall into the pit of success. And that is, even if you make a mistake, we're falling forward, we're going in the right direction. And I'm going to give you some rules of thumb for using not just the Azure DevOps product, but how to think about a DevOps environment for your development team when using the .NET ecosystem. And I'm so glad that you're here. And if you're tuning in for this particular talk, that means that you probably want to get more done. You want to move faster. You want to produce higher quality software so that you can deliver for your team, your company, and your customers. And I know from experience that if you map out your software delivery process and then automate it, you will deliver more, and you'll absolutely love the result, love programming and delivering software. And by way of introduction, my role is Chief Architect at ClearMeasure. I've been a Microsoft MVP since 2006. Won't dwell a lot on that, but a little bit about ClearMeasure here in Texas. We're a Texas-based software architecture company that empowers software delivery, enabling in-house .NET teams to be self-sufficient, able to move fast, deliver quality, and run their systems with confidence. And of course, if you're in Texas and love to work with me, just go to clearmeasure.com/careers. A little bit about myself. My lifelong hobby is dirt bike racing, and my son and my daughters race off-road dirt bikes as well. And I live just outside of Austin, Texas, and we have some longhorn cows grazing the small ranch that we live on, as well as some donkeys and chickens, and so love taking care of those animals. All right, let's get into our agenda. There's three things that we're going to go into as we lay out the path forward for using Azure DevOps for .NET and setting up a DevOps environment. We're going to talk about the challenge of DevOps. Then we're going to go through each part of the pipeline structure, and then talk a little bit about how you can get started. And before I go, my latest book is pictured here. It's .NET DevOps for Azure, and some of you probably read it. You can get it anywhere books are sold. However, just for coming to this conference, if you send me an email, then I'll send you a free electronic copy of the book. And so you take a screenshot. Of course, I'll show my emails, but just send me an email. I'll be happy to send you a copy of my book. And also, if you're not aware, I'm the host of the Azure DevOps podcast. Anywhere you can find podcasts, just look for it. And we're about 3 years in. And I interviewed lots of industry luminaries on that podcast, and also have a video show, Architect Tips. Now let's get into the 7 elements of a DevOps environment. We'll go through each one. First, you have the pre-code design process. These are the things that you do even before fingers go on the keyboard. Then, version control structure. These are some of the rules of thumb that you need to have in place, you need to follow, so that your version control system works for you instead of working against you. Then we'll talk about the structure of your build processes, which there are multiple. And then we'll go through full system testing and how that works into a DevOps environment. Then we'll talk about user experience testing, some things for your actual production release process, and then telemetry observation, which is all about monitoring and supportability and intelligence for your software running in a production environment. So let's talk about the kind of the analogy or the imagery that pipeline conjures up. The DevOps pipeline can be thought of as a water pipeline. You want smooth flow. You want to filter out impurities. And there's 2 things that you can measure. You can measure water pressure, and you can measure water quality. Now, this is a really good analogy for DevOps, because if you have no water running through the pipeline, then there's a problem. Also, if you have inconsistent water pressure, where sometimes it's dripping and sometimes there's water gushing out, well, that doesn't work either. Same thing in a software pipeline. If there's no changes, no progress being made, that's a problem. And if you have constant stop-start with a mountain of software is being released all at once, well, that's tumultuous as well. Also, for quality, you want the water in your pipes everywhere in your house or building to be clean. It's not a good situation to have the water in the pipes be dirty and then expect to have some super water filter right at the faucet to be able to filter out all of the problems in the water, somehow giving you clean water when you turn on the faucet to take a drink. And so you want throughput, you want quality. Same thing with software. If we leave all of the bugs and the problems in the software until right before production release, no process in the world is going to magically fix all those bugs right before we want to release it to our customers and to our users. We want the bugs to be fixed very, very close to where they are found in the process, and we want them to be found very, very quickly. So a pipeline is a really good analogy because we want those things for water pressure as well. Now, this is actually the top third of a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps services, and also uses Octopus Deploy for continuous integration builds, and it has a 3-tier deployment pipeline. It also uses Redgate tools for SQL Server deployments. If any of you would like to have this, just send me an email and I'd be happy to send you the high resolution version of the poster. You'll be able to get these slides, but if you want the high resolution version of the poster, which is here, I know you can't see all the text, I'd be happy to send that to you. And it's meant to be sent to a print shop, and you can print it on a 2-foot by 3-foot, but pretty large poster board. But the important parts are moving from your version control system through some triggered automated builds to release candidate packaging, and then to a sequence of deployment activities. And you can see that we have 3 environments depicted, and you'll never have fewer than 3 environments, even in the simplest of applications. And the reason you'll never have fewer than 3 environments in a DevOps pipeline is because there are 3 distinct types of environments, and you need at least one of each. You can have more than one, but you need at least one of each. Obviously, everyone knows about the production environment. You need at least one. Now, some software has multiple production environments. That happens from time to time, but you need at least one. Backing up from that, we need an environment where we can do manual testing. We need at least one where we can manually test the software. And many teams have more than one environments where someone manually tests the software. That's normal. Backing up from that is the automated testing environment. We need at least one of those. Common names for that is the acceptance test environment or the full system testing environment. For acronyms, I like to use the name the TDD environment because it invokes the spirit of test-driven development. And this is the environment where all of our full system acceptance tests are going to run. And if you're doing a web application, these are going to be Selenium tests driven, opening up a browser and clicking around. But this environment is not for people. No humans are allowed in this environment. It is just for our test automation suites and the tests that have to run on a fully deployed instance of the software that can't just be run on a build server. And so these are the 3 distinct types of environments in a DevOps pipeline. You need at least one of each. And of course, you can have as many as you want. And you can parallelize duplicates, or you can run them in series. That's totally up to you. Okay, now let's back up to the pre-code process, and you can see that the process here has been kind of strung out in a sequence. I want to focus on the top row here, where the top row we have some design decisions to make about a particular change or feature in the software, and the second row is coding activities. The developer, writes some code, does some interaction with your Git repository. We do some builds, and ultimately we have a build that becomes a release candidate that we can start deploying. And then, of course, the bottom row is all about deploying on our way to production and making sure that it's working properly in environments. Now, the first row, I want to go through each of these, but I actually want to go through each of these as it's mapped on a Kanban style board. Now, whether it's Azure boards or GitHub projects or any other project management tool that supports any kind of work tracking board, you're going to be able to have columns that have status and you can lay them out. This is pretty much the minimum for a software project. Now, notice that there's 9 columns. By default, some of the tools have 3 columns, and it's just not started, in progress, and then done. And you only have 3 columns like that. Your productivity is going to be questionable, and when the team is slow, you're not going to have any insight into why. So let me illustrate. Let's take the first 4 columns of this, which are design decisions. The first 4 columns of work that have to be done on a particular feature or software change have nothing to do with coding, nothing to do with writing code. So let's take the first one. And by the way, I don't care what you call these things. These are my names. First one is conceptual definition. Now, you might call that the first part of requirements, where you're answering the question, why is this even important? What's the business goal? That's the conceptual definition of why a particular feature or change is important. And of course, we need to be able to understand why that is so that the rest of the design decisions can come into place. The second design decision is user experience design. Now, if the feature has a visual element or a screen, then of course you're going to draw a wireframe and you're going to figure out how the screen is laid out. But even if the feature has no visual element, maybe it's just a change to move data from one system to the next, there is still a user experience, and there's still decisions to be made about that experience. For example, it's a very different user experience if the data needs to be from point A to point B in real time versus every 5 seconds versus every minute, or maybe in a batch process where the data actually doesn't need to get there until tomorrow and 24-hour turnaround time is fine. But either way, that decision needs to be made and to put into the design notes in however you're tracking the card. The next design decision is around the technical aspects, architecture, software patterns. So I'm calling that technical design. And that's where your lead engineer or your architect would make some determination about how we are going to implement this particular change. And it's also where a particular feature may be broken up into independently implementable cards, whether you be using the nomenclature of a feature to a user story or user story to a task. I'm not worried about what you call those, but that's typically when we break it up and say, okay, here's independently implementable chunks that all are part of this change. And if there's a new library or a new NuGet package or a new component that needs to be brought into the software, a new dependency that needs to be brought into the software, this is where that decision would be made. And then after that's made, the lead or the architect would think, is our current architecture of the system sufficient to make this change or implement this new feature, or do we need some new architectural elements? Are the design patterns that we've implemented in the architecture, are those sufficient, or is this a new type of feature and we need a new pattern? All right, the next and the final design decision is all about test design. And if your team is using some elements of Scrum, this is where your acceptance criteria would go, or your definition of done. But in the test design column, you're asking yourself, do we understand, once this feature is completely implemented, do we understand all of the test scenarios that we're going to run through in order to verify that this feature actually is complete and it works the way it was intended? And we want to enumerate all of those out there. Okay. And then we get into the development column. All right. So all of these things have to be decided before someone puts their hands on a keyboard. If we dispatch this to a developer, then the different personalities of the developer are going to vary what we actually get out the other end, because the developer is going to realize, wait a minute, there was a user experience design decision that isn't clear. I need to stop coding and go backfill a decision. Or, oh, we might need a new library or dependency or design pattern. I need to stop coding and go fill a hole in technical design. Or you may be going through and realizing it's not clear if I'm done, or if this also needs to support some additional scenarios, because I'm not clear how many test scenarios need to be here. So it's really important that all 4 of these design decisions be done so that the developers can go as fast as they can. Developers are really, really good at programming, but developers can't program unless we're actually fed with the decisions to keep us moving. And then the rest of the board kind of tracks with functional validation at the team level, user experience validation, manually testing it in one of those manual test environments, and then release validation, which is making sure that help desk systems are in place and monitoring is configured properly before we actually go to production. All right, let's dive into what you need to think about for your version control system. Okay, these are the rules of thumb for your version control system. And I'm going to hit the big one. Everyone is going to have a significant software system that's probably going to be segmented into multiple applications. So you're not going to have the entire software system in a single version control system. You're going to split it up. But here's what you need to keep in mind. A Git repository needs to have exactly one versioned software application in it. And the versioned software application needs to reside in no more than one and no fewer than one Git repositories. Now, a versioned software application in the .NET world, it is a Visual Studio solution, and it has a number of projects, and it all compiles together, and you unit test and integration test it together, and then you deploy it. And a software system can be made up of many applications, each of which is in a different Visual Studio solution and is a different Git repository. The reason for this is because your version control system, your Git repository, is the headwaters of your DevOps pipeline. Think of all that water flowing through the DevOps pipeline. Your version control system, that Git repository, is the headwaters, and everything flows down that DevOps pipeline from the Git repository. And every tool on the market is designed and built to operate on all of the code that is in the Git repository that it's pointed to. They're not designed and tested to go and combine code from multiple Git repositories, or to connect to a massive Git repository, but only pay attention to a small amount of it. Now, technically, have some people forced it to work that way? Yes, but you're constantly going to be fighting the tooling. All of the build tools on the market and all of the products that work well in an automated DevOps environment have kind of this assumption that first of all, we're working with all of the code in a Git repository, and that's going to be your most optimal path. So, I mean, if you have a very rare and specific reason where you need to break that rule, then just know that you're going to be fighting against other products that are available to you, Azure pipelines as well. And your path is going to be a lot easier if you have your software in a single Visual Studio solution, which is in a single Git repository. All right, let's jump into the structure of our builds. Now, I put a private build and a continuous integration build together on this activity diagram because there's a lot of similarities here, and I'll go through them. A lot of you are familiar with test-driven development, and an automated test is compiled of 3 basic chunks of steps. The first one is our setup, the second one is our execution, and our third is our verifications or assert. Some people say arrange and then act and then assert, okay? Or setup, execute, teardown. Now, in a build is just a large test. And of course, it contains a lot of individual tests, but the private build and the continuous integration build are different. And let me stop for a minute. And I know this is maybe ancient history, but way back in 2006, there was a book that literally is called Continuous Integration, and it came out from Addison Wesley Publishers. And in 1999, that's 22 years ago, Extreme Programming came up with the process or popularized the process of test-driven development and automated builds. And then about 7 years later, a lot of discussion had taken place about Agile and the Agile Manifesto, and Scrum had come out, and extreme programming had got even more popular. And there was a book written about continuous integration that did a good job in defining what continuous integration was and is. Still to this day, it stands. And there are three key stages to continuous integration. The first one is the commit stage that completely happens on a individual developer's workstation. The second is the integration build stage, and the third is the first deployment. We'll talk about first deployment later, but the commit stage is all about the private build. We want a private build script that runs on a local computer that answers the question, am I ready to commit my changes and share these changes with my team, or have I broken something? Okay. And the integration build, also called the continuous integration build, also called the CI build, that build runs on a Teams shared server. For most of you, runs in Azure Pipelines, and it answers the question for us, do all of these changes from multiple feature branches of multiple developers, when combined together, does the software still work, or has the combination of these changes broken something? Okay, and of course, the bill is green. It gives us the confidence to declare that the result of the build is a viable release candidate and is available for deploying down the line. And so the private build and the integration build share a lot of the same steps. And migrating the database or creating our environment is one of the arrange steps. Obviously, compiling our C# is another one. Running our unit tests is another one. Running our component level integration tests is definitely part of the asserts. And when I say component level integration tests, these are tests that, because of their environment dependencies, they can run on the build server. They don't actually require the entire software application to be deployed to a downstream environment. They can just run from the libraries sitting on disk. And then once that happens, the private build is done. But if it's running in the integration build, then we're going to continue on with static code analysis and publish our test results and then package things up. All right. Speaking of packaging, this is really important. Now, Azure Artifacts is going to be the resource of choice for storing your packages. And let's consider the architecture that you see in front of you. A Visual Studio solution with an ASP.NET web application of any flavor, doesn't really matter, whether it be MVC, whether it be Blazor, doesn't matter, some form of ASP.NET. And then some offline job, maybe a batch job or something that runs headless, and then a SQL Server database schema. And then we also have our acceptance tests, our full system acceptance test library. Each of those, when they're built and packaged, would end up being put into an independent NuGet package. So I'd end up with 4, because there's 4 things that would need to be deployed during a deployment, and we package the software in a manner that is easy for our deployment, and we put them in Azure Artifacts. And so this would yield a release candidate that has 4 NuGet packages, all that have the same version number, and the only difference in the name typically is the deployable component that they represent. All right. Now, let's go into the packaging and deployment integration for this. Okay, we're keeping going. Now, we talked about continuous integration. We talked about the build and the question that it answers for us. We got a lot of changes from a developer, from multiple developers, and we put them all together. We know, we have confidence that the software still works and we didn't accidentally destabilize something. So now we have a viable release candidate that we are going to deploy. Now, the third stage of continuous integration is our first deployment. Okay. I see so many teams, development environments, and their team infrastructure, and a lot of people say that they've implemented continuous integration, but they haven't implemented all the pieces of continuous integration. Some are actually missing the commit stage and they have no private build, but a lot of them are missing the automatic first deployment. And the important parts of this are twofold. One, that it automatically triggers immediately after the success of an integration build. And two, that it deploys to a representative environment and then runs a test suite of automated tests that validate that the software deploys properly to that environment, starts up properly on that environment, and does all of its main features and functions on that environment. And so let me talk about the first piece, deploying automatically on that environment. Every time, whether it's on a feature branch or the master branch, every time we have a successful build, we want to automatically deploy that to our TDD environment or our test automation environment so that we can know for ourselves if we still have a stable code base. Because we all know that all of our unit tests and all of our integration tests can pass, but if we've accidentally messed something up with a config file or the database connection string or something in the user interface HTML or CSS code or some JavaScript that we've put in there, there can be all kinds of things that are wrong with the software that are going to quickly be caught when we push it over to our manual test environment. But we want to find those earlier. And so whether it be with using Selenium tests that open up a browser and click around, or whether it be using other test frameworks for other types of software like headless software or WPF or WinForms or mobile apps, whatever, there's frameworks for automated testing through everything. And so we want full system tests. Okay. Now, the test cases here don't go through all the different permutations that unit tests and integration tests go through, but they make sure that every single layer is properly connected to the layer below it. Because if we accidentally mess something up around the connection string to a database, well, guess what? A website might deploy, and maybe the first screen of a web application might actually load if it doesn't make any database calls. But once we start trying to use it, nothing's going to work. And I'd rather find that out sooner rather than later. All right. The other rule of thumb that you want to make sure that you abide by so that you don't fight against all of the tooling available to you in the DevOps ecosystem is the build once, deploy many rule. If you've ever heard someone say, "Oh, we need to build to UAT," or "We need to build to production," that is a mistake. You do not want to go back to your source code and actually recompile it in the process of deploying it to a subsequent environment. You want to, once the TDD environment passes and that test suite passes, you want to kick off the UAT or the next environment deployment by having the process go straight back to Azure Artifacts, get the exact same release candidate, which is a set of NuGet packages, and deploying that same release candidate to the next environment. And then when we deploy to production, we again want to go back to Azure Artifacts, grab the exact same release candidate and deploy to production. And in that way, by the time we deploy to production, we know that exactly what we deployed has been tested and everything works all along the way. Okay, now in Azure Pipelines itself, this is the minimum configuration that you'll see. The minimum of 3 environments, the TDD environment, the UAT environment, the production environment. And notice on our TDD environment, we see that little beaker that says 100%. That means that the tests completed 100%, and you want to see that because there's tests running. You don't have to run tests in every environment, but in the TDD environment, you definitely want to run all of your tests. And it's very popular as well to have an approval gate before going to production. So that's pretty common. I'm also going to show you the visual designer just so you can see the chunking. I know the YAML configuration has gotten really, really popular lately, but I want to show you the designer view just so that you can see the pattern that emerges when you're putting together these deployments in Azure pipelines. And you'll see a pattern for each deployable component. The first thing we want to do is we want to tell application insights, which is what we're using if we're in Azure for monitoring and telemetry. We want to actually tell it and record that, hey, we are deploying version such and such to a particular environment. And that puts it, that annotates it in the application insights database. This is happening so that anytime we're looking at metrics based on a timeline, we can also see when we deployed. So if any of the metrics in our telemetry change over time, we'll know comparatively. So the next thing is obtaining the database package. Now, we typically do the database first, or foundational dependency. So the database is one component in our simple application architecture. So we get the package. That's the first step. The next step or steps is to configure the environment. So creating the test database and capturing database variables, and then creating the database schema using Roundhouse or DBUp or whatever your migrations tool is. That is the actual step that deploys the database schema. So we have step 1, get the package. Step 2, prepare the environment. Step 3, execute the deployment, which in a lot of cases is file copies or creating a schema. Now, that's the pattern. Then we move on to the UI package, which is our ASP.NET web application, and we do the same thing. Step 1, get the package. And we're getting it from Azure Artifacts. Get the package. Step 2, configure the environment. So this is Azure Web Applications, which create test website. And then 3 is do the active deployment. And in this case, it's UI deploy, and then starting up the website. Okay, it's the same pattern. And then once we've done this, we typically like to execute a self-health check, where we actually call over to the application and ask it, hey, did you start up appropriately? Are you healthy? And the application itself is the best one to answer that question, because if the web application can't get to the database, well, no, the application's not healthy. Now let's move over to the tests, which the test suite is a deployable component. So we do the same thing. Step 1, get the package. Step 2, do some preparation of the environment, like update the value for the connection string and the app URL. Step 3, run the tests with our VS test task, and then our pattern completes. For our TDD environment, it doesn't cost us hardly anything in Azure, because you see this last step, we're deleting the entire resource group. So we actually don't persist this TDD environment between builds. We just create it, use it, throw it away. So it costs us very, very little to do this rigorous full system testing. All right. So let's pull all this together and look at the quality lens of this. Notice in the top right of this activity diagram, there is the inspection. Okay. In order to implement formal inspections, you need a few things. One is you need really good 4-step design process. Those 4 design decisions that I talked about, we need to document in the story cards or the issues or whatever you like to call your particular work items. Document the design decisions that have been made, especially the test scenarios, because that defines all the different paths that the software needs to support, all the different scenarios. And so couple that with feature branches, where a developer would branch for that particular item and then do a git, commit, and push. The integration build would also run on every feature branch. We would do a deployment to the TDD environment from the result of what's on my feature branch. The automated acceptance tests run against the build that was created from my feature branch. And now I have high confidence that what I did on my feature branch didn't break something else in the software, and I can create my pull request. Then another member on the team can do an inspection. They can look at that pull request, and armed with the test scenarios and all the design decisions that were made, and one more thing, a team pull request checklist. As a team, if you get together and decide what is the criteria by which we are going to approve a pull request, You ask that question and just write down all the bullet points of everything you're going to check. And one of my favorite items is making sure that no new library or NuGet package was added to the software unless the actual technical design of that particular change required a new NuGet package to come in. Capers-Jones has a lot of research published around software quality, and one of the most popular, or one of the most common reasons of defects being introduced into software is reusing code or packages from a third-party source that wasn't vetted or analyzed by the team. It was just done by an individual developer. Also, his research shows that there are 3 quality control techniques that, when put together, reliably propel a team up to 99% defect preventing defects from going to production. And they are testing, which in our process we have 4 different levels of testing: unit testing, integration testing, full system testing, and then of course manual testing. That's the first one, testing. And then the second one is static code analysis, which should be in your integration test build, SonarQube or Independ, and definitely the Roslyn analyzers. And then the third is formal inspections. And if you branch this way, if you specify test scenarios, if you have all this level of testing and you have a team checklist, then you've elevated your pull request process to the level where it is actually a formal inspection. So I highly encourage you to do that, because research has shown that it does a lot to reduce defects. All right, let's jump into deployments. Now, again, we have our minimal DevOps environment, TDD, UAT, and production. And in the TDD environment, we are going to do a lot more than we would in the UAT environment and the production environment. And of course, we're going to do some things in every environment. Migrate database is one of those. If we need to add a column to a table in the database, of course, when we deploy, we need to do that in every environment. Running the health check is something that we do in every environment. Loading static data. If I have a drop down with the regions of addresses I support, then maybe I would have that static data, or things like prefixes of names, Mr. or Mrs. That would be static data. And then loading of test data. Well, that's not going to happen in production. Recreating environments, that's not going to happen in production. Recreating the database, running acceptance tests, deploying unattended, and destroying the environment. So by the time we get to production, we're doing a lot less. However, every single thing that we do in production, we want to make sure that we have done it multiple times in environments ahead of production. That is the key here. Never do anything in production for the first time. Okay. And all of these things are, of course, automated. We're not doing any kind of manual step. All right. I want to take a zoom lens and kind of zoom in back into our full system testing and talk about how to use not the Azure test plans, but a feature of Azure test plans that actually integrates into Azure pipelines. And that is the record keeping of the test runs, as well as test attachments. Now, full system tests, whether they're web or Windows, you're going to pull up the application visually on the screen, and you're going to control a keyboard, you're going to control a mouse, and you're going to interact with the software. And it's a really good technique in your full system tests to annotate what step of the test you're on. And for every single step, take a screenshot. And then when you make it a test attachment, Azure Pipelines, when it's running those tests, is automatically going to snag those attachments, which essentially are PNG files, image files, and then they're archived in Azure Test Plans, which integrate into the runs of your integration build so that you can see them. Now, if we'll zoom in on the next screen, and you can see on the left that I have 3 PNG files that are attachments to our acceptance tests. And on the right, you can see what looks like a web form, because it is. And this is the screen of this simple application that I used to generate this demo. And of course, it doesn't show the browser Chrome or the browser window. It shows the screen itself. And there's text boxes and there's a button, and the Selenium framework is just typing in the text boxes and pressing the button. And every step of every test takes a screenshot. This saves so much time because at some point, tests help us, because at some point a test is going to fail because I accidentally broke something, and I'm working on my feature branch and I'm going fast, and then I run these things and whoa, it's broken. Well, that saves me time, because if I didn't have this test and it hadn't broken, I would have committed the code to the team. The team might have even merged it into master, not knowing that I introduced a bug, and now the software is broken, the software is destabilized, and we lose a whole lot of time as a team. But when one of these tests breaks, if you have taken a screenshot of every step along the way, then all you have to do is come back and look at these screenshots, and chances are you'll know exactly what happened and you can fix it very, very quickly. If you don't have the screenshots, well, then you have to spend time reproducing it and figuring out what step it went wrong on, and then it just takes more time. All right, let's move into telemetry. And this is how we know how the software is running in production or in any environment. Everybody uses logs, okay? Everybody uses logs, and logs are good. Logs are definitely good, but logs are insufficient. In order to enhance the intelligence that we get from our software running in production, we need logs, but we need to elevate the intelligence of the information that we have up to telemetry. And in order to do that, we need to add metrics and events. Logs are great, we need those, but we need to elevate them with metrics and events. And what this does is it actually gives us a data warehouse of what our users are doing and what the software is doing. A lot of you have probably created data warehouses for the users of your software, or maybe at least have created a star schema, or at a minimum have created some type of fact table or data analytics table where you consistently add records for the purposes of recording some type of history, so that later on they can connect Power BI or Tableau or Excel to that table and start analyzing it and asking questions of it and plotting it on bar graphs and line graphs and things like that. Well, we need to do that for ourselves. If we use that same technique for ourselves, then we will have a data warehouse that we can ask questions of, so that we'll know what our users are doing and what the software is doing. And it's no different from other times when we use the Kimball method of data warehousing. And by the way, if you have never heard of the Kimball method, Kimbell, he kind of was the father of the star schema and data analytics databases and all of the methods used in modern data warehousing. And he has a number of books on the topic. So if you're not familiar with that, then I'd highly encourage you going to that. However, it's the same techniques applied to the information that our software emits out to application insights. So let's look at what the architecture may look like for that. Okay, so we have the logical components in our application. Again, a very simple application for illustration purposes. We have our ASP.NET web application, an offline job, a SQL Server database, and then our acceptance tests. So we have 4 deployed components to our TDD environment. Now, in a UAT environment and in production environment, we don't have the acceptance tests. I just wanted to say that out loud. And so we're gonna run in Azure. All these are, whether or not they were VMs or serverless resources, makes no difference actually, or even if they're running as containers, makes no difference. We want the telemetry emitted from all of those deployed components to go to the same application insights resource in Azure, so that it goes into the same database and can be queried together. We don't want each of these deployed components to go to separate application insights resources, because then we have to do extra work to bring the data together. Furthermore, if you have other information sources that already go to log analytics, then you can connect your application insights to a log analytics workspace in order to even get more, a larger data set. However, if all of your deployed components are .NET and running on serverless resources in Azure, then oftentimes application insights, a single application insights resource, does the job very, very nicely. So let's look at what happens if you just enable application insights for your application. Even without writing any code, you already have a wealth of intelligence just because application insights knows .NET, and it knows a lot of the key libraries in .NET like Entity Framework. So you can see right here, we're actually looking at a query being sent to our SQL Server database, and we didn't write anything to get it, but it's automatically being recorded. And so that's kind of cool just for implementing it. However, that's not where the magic is. This is where the magic is. Now, this graph is actually from a car auction application, and of course, it was taken over the summer. So you see July, some dates in July up until early August, and the drop down on the top right is commands. This particular application uses the CQRS pattern, the command query response segregation pattern, so that every transaction type that the application does gets wrapped up into an object and sent through the application either as a command from the user, click a button, hey, I want to make a bid on a car. Okay, they click the button to make a bid. That user's intention is wrapped up as an object that is a command called the submit new bid command. And then other things might be events that fired and passed around the application. But everything that the application is doing is wrapped up as an object. Then this particular application sends those objects down a singular application bus, and that architecture provides a single pathway that can be observed. One of the observers of all the objects going down that bus is our telemetry emitter, which looks at everything that's happening and takes that object, the properties of that object, the information in that object, the name of that object, creates a custom event from it and sends it over to application insights. And so what we end up having is recorded custom events in application insights for absolutely everything that every user did. So now we can see as a bar chart, the car auction volume went up over the summer, but we can see that we have some seasonality in bidding, where it was kind of lighter during the week and more heavier on the weekends. Also, the green check marks that you see at the top, those are the annotations of deployments. So we can also see when we actually deployed to production. And of course, if there's exceptions happening or some bad things happening and we think that we fixed it in a particular deployment, that's also a way for us to verify that the metrics or the exceptions got better after we see that little green check mark. So that's just a quick highlight of the power of elevating your logging up to the status of telemetry by actually emitting true custom events. And while this is an example of metrics, you use the same method for metrics. You create an actual sampling of a number and periodically send it to application insights, and then application insights trends that number over time. All right, now we talked about the green check mark a little bit. If you hover over that green check mark or click on it, then you see all the information from application insights about the build, the branch, the build number, the environment, everything, including a link back to the build and back to the pipeline that built it and deployed it. So it's all connected. All the products integrate really, really well, and end to end from source control at the beginning to telemetry in Azure Monitor kind of at the end of the process. It all works well together. Now, that was a lot of information to take in, I know that you're probably wanting to review it. We will make the slides available, and with any questions, just send me an email. Whether or not you want a copy of the book, whether or not you want the high resolution version of that DevOps poster, or some of the slides, just send me an email, Jeffrey@clear-measure.com. You can also find me on Twitter at Jeffrey Palermo. And I love answering questions and I love answering emails. So please do that. And thank you very much for coming to AZConf. And this is track number 7. We hope you have a great day number 2 of the conference.
Thanks, Jeffrey. Let's wait for Q&A. So far, we don't have any questions. It's a nice session, a lot of information, and of course, in 1 hour we got a lot of information about DevOps. Definitely, I will send you an email. I'll get a book. I'll get a copy of your book and I'll go through it.
Absolutely. Absolutely.
I think we don't have any questions. Thanks, Jeffrey. Thanks for your time and the fucking nice session.
Awesome. All right. Everybody have a great conference.
Okay, now we have the time for the second session. I welcome Mr. Anuraj Parameswaran. He's a Microsoft MVP, full stack developer, data architect, technical evangelist, and also a product architect. He's going to talk about continuous database deployment with EF Core and Azure DevOps. Yes, Anuraj, uh, stage is yours.
If I am audible,
Yes, you are.
I can start, right?
Yes, Anuraj, you can start.
Okay. Welcome all. Good morning. Uh, Thank you for coming to Azure Community Conference. Today I'll be talking about continuous database deployment with EF Core and Azure DevOps. Let me introduce myself. My name is Anuraj. I work as a product architect at Soxo Solutions Private Limited. We are building brand advocacy, employee advocacy solutions. I have got 15 plus experience in .NET or in Microsoft technologies, and I'm last 6 years I'm an MVP. So let's get into the session. So here is the agenda. What I will be talking. So first, why we need to automate database deployment. Then second is what are the challenges in automated database deployment. Then we'll talk about EF core migration. So how EF core migration feature helps you to address these challenges. Then we will be getting into building a database deployment pipeline in Azure DevOps. And finally, we will be discussing about a preview feature in .NET Core or EF Core. It's called EF Core Migration Bundles. And we will look into how we can create a EF Core Migration Bundle and how you can use it to deploy your database changes. Okay. So why you need to automate database deployment? So let me tell you a story. So in Soxo, the company I'm working, we are a SaaS company, and for each customer, we are following a SaaS database structure. Something like for each customer, we are providing an isolated database. And when I joined, the deployment was like manual. So we had to take take the application down. Then we had to deploy the scripts which each developer give to the release like the one who is releasing. He will getting a lot of SQL scripts, and he need to sit and manually connect to each SQL database and execute it. The major challenges was one, it will take a lot of time because we had to connect to each Azure SQL DB. Like if you have say 10 customers, we have got 10 databases, and it will take some time, and it's not scalable also. Like when you add more tenants or customers, that database is going to increase and it will take more time. So we had to take the application down for a particular window of time, and it is impacting our SLA, all those things. Then that's the first reason. Second, our issues with manual deployment. So since one guy is sitting and he is manually executing the script, there is a high chance he might miss one database. And if he misses one database, the problem is application will get deployed after a database deployment, and we may not be aware. Okay, something wrong with only one particular instance. So that's another issue. And since the developer is like sitting and doing it, he need more focus on doing this. Other than like he will be frustrated if he repeatedly doing the same job again and again. So it impacts the developer productivity also. Instead of he doing a manual deployment like this, he can work on some features or work on some improvements in the application. And last but not least, audit and regulatory requirements. So if you're in SaaS business and if your clients are banks like us, BFSA clients, the problem is they will come up with some vendor uh, audit or regulatory requirements. So if you're saying, okay, we are deploying it manually, there is a high chance of a risk, like we are connecting to production, that's a very high risk, then production database, and we are manually deploying, so that we can like since we are deploying, we need to give access to this person to connect to production database and do manipulation. The chance is that particular user, if he's misusing it, so we don't have audit kind of stuff. So we can enable auditing, but it's a an add-on to the existing infra requirements. So these are the main reasons why you should automate database deployment. So what are the challenges in automating database deployment? First and foremost challenge I was facing was version controlling database and database systems are difficult. So what was the practice we used to do? We used to take the backup of the when we are committing a new change. Before committing a new change, we will take the one database backup and we will put it in the GitHub. And once we are done, we will take a backup and we will commit in the GitHub. The challenge was we could not identify, okay, what's wrong in that, or is there any issue? What was the change? If you look into two backup files, you can't compare directly. If you want to compare what's changed in one database and another, you have to manually go and restore these databases in your machine, and you need some third-party tools to compare and what's the change there. And our process of application and database deployment is different. So databases can be deployed either using manually running scripts, or sometimes via code, and sometimes by restoring the backup. So it's little bit different than a normal application deployment. So if your application is deployment, most of these applications, like if you are building a web app or ASP.NET app or PHP app or Python, you just need to compile, install dependencies, compile, then deploy. But a database can be deployed in different ways. So that's another challenge. So how we can solve these challenges? So in my opinion, if database changes we can keep as part of the application code, then we can be easily version control those. So if I'm building a feature A, and I'm able to identify, okay, these are the changes as part of feature A, I'm able to easily identify, okay, what's changed from feature A to feature B. So it can be easily version control, and since it's part of these code or changes part of application code, it can be deployed along with the application as well. So how we can do that? So in this session, I am talking about AF core migrations. So AF core migrations is introduced in Entity Framework in .NET 3.5. It's a .NET Core version of Entity Framework. It's AF core. AF core migration feature provides a way to incrementally update the database schema in sync with the application data model while preserving the existing data in the database. That means EF core migrations will help you to update the database schema in sync with the application data model, and it will keep the existing data in the database as well. So how to get started with AF core migrations? So before getting into AF core migrations, you need to install .NET Core, and in .NET Core you need to install .NET Core EF Core tools. So you can do it using .NET Core tool install hyphen global .NET EF. So .NET EF is the command we will be using to create migrations. You can do this with PowerShell as well, but in this example, I am using .NET tools. Then after you build your application data model, everything, and associate the data model to the database context class in your application, then once you completed a feature, you can create a migration, and that you can create by .NET EF migrations, then add with a name. So if you are implementing a feature, you can mention that it's part of feature 1 implemented, something like that. And you can apply that database changes using .NET EF database update. So in that time, if that database doesn't exist, the entity framework will create that database and apply these changes to it. And sometimes like all these things, migrations, everything is C# code. And if you want to generate SQL script, you can call .NET EF migration scripts, and idempotent flag will help you to run that migration script into any schema or any database without you don't need to worry about what are the migrations applied on that database. So all those things is handled by idempotent flag. So let's look into a demo. I have created a application, and here is it's a to-do ASP.NET Core Web API project, and this is a controller, and this is the to-do item class. So I have got an ID and name, and this is a database context, nothing fancy, just I created like DB set to-do items. That will be the table, and here I already got a database. I'm deleting it. I already tried migration in that. So now I don't have a database with Azure Community. And in the connection string, I'm creating a database, Azure Conf dev. This is the DB context. And this is a controller. Again, it's simple, straightforward controller. And I added that DB context with the connection string, default connection. And default connection is I'm connecting to my local database. This is the database, and I'm using username and password. So let's first run this, install the .NET tool. So here I'm installing it. Since I already installed, it will show a message like this. You can verify whether you are installed or not using .NET EF command. So it will show entity framework screen. Okay, and okay, there is no migration. So I'm creating first migration .NET EF migrations, add initial migration. So it will compile the project. Since I don't have any existing migrations, it will create a migrations folder in my root, and we can see what's happening in that migration. Once that migration is completed, we can update the database using .NET here, database update. So here, if you look into this folder, this is the newly created folder, and it is auto-generated code. So in this migrations, it is inherited from migration class. This is what the name I gave, and there is two methods, up and down. Up means when we apply a migration, this method will be called. When we are removing a migration, this method will be called. So here we are creating a table to do items, which it is part of this one, and it has two columns, one ID and one name, and there is a primary key ID. So name ID. Okay. Now let's apply this migration. So .NET EF migration. Sorry, database update. So it will create a database, and it will create the tables also. So if I refresh, you'll be able to see this one, and here is the to-do items table. It has two columns, ID and name, and there is a table EF migration history. Entity framework is applying migrations based on this table. So if you look into this, you will be able to see initial migration. This is the applied one. Okay, let's create another migration. So what I'm doing, I added this code and I updated this one. Okay, now consider a scenario. You are like we are working on a project, and you are manually deploying the scripts. So what you will be doing, if the developer is doing the changes, same changes in database also, otherwise it will fail. Here, what I mean, if the developer is forgot to commit or forgot to give you the scripts, it will you won't be able to identify what's happened. But in this case, it will fail in the development stage itself. So if I didn't created migration, or I didn't update the migration, and I changed everything, and if I try to run, it will fail in not in compile time. It will fail in runtime. It is running. Okay. Since it's a web API, it will show a 404 page. So I just put Swagger. And if I try to execute something, I will get an error because invalid column. These three columns are not in the database. So let me update the is completed. So it's I'm creating another migration. Usually, this migration, we won't be modifying anything in this code. Yes, there are situations we might need to do that, but normally we won't be modifying anything. Then I'm updating the database. Now, if I go here, it's building. Like since we already run, you can always give a flag no build so that you can save that time. And if I look into the design, these three columns are also added. And if I run the applic and in the EF migration history, the second feature also, second migration also applied. And if I run the application, it will work properly. And we can also look into the script aspect. So in the migrations, I added three columns in the to do items class, and it is creating three columns. Created on is completed, completed on. Okay, and if I'm running it, it's returning 200. Okay. Now, if I want to generate the scripts, .NET migrations script. If I say script, it will print the generated script in the console. I should start putting that no build flag. Okay, so if you look into this, you will be able to see it is checking whether that migration table exists or not, and if not exists, it will create. And there is a begin transaction, and it is creating a table to do. And in the migration history, it is updating the first migration. Then it is committing the transaction. Again, it is beginning another transaction, and it is doing alter table. And second value also implemented. But the challenge is, if you want to take it out, you can say /o script one.sql. It will create a script in this root location. And let me look. Okay, so if you look into this, as I mentioned earlier, if I try to execute this SQL script in my current database, it will fail because these tables already exist. But if I put that idempotent I flag, it will generate a script which you can apply execute in any database, any state. It will check for the migrations existing. Is there any migration exist, or is the current migration is applied? Then only it will generate the script. So if you look into this, you will be able to see it is checking for this migration exists or not. And if this migration exists, not exists, then only to create the table. And same thing applies here also. It is checking for the migration existence is then only it will adding the altering the table. Okay. Another important thing. So what we will be using? We will be using this script command to generate SQL script and deploy to your database. So that's it related to EF migrations. So to use migrations, your project should have entity framework design, NuGet package, and since I'm using SQL Server, I need to use SQL Server package also. If you are using SQLite or any other database, you need to keep that NuGet package instead of SQL Server. Let me go back to the slides. And yeah, here is the way we are building a database deployment pipeline. So whatever we did it on our development machine, we'll be doing the same thing. So first, we'll be installing the EF core tools on the build agent. Next, we will be generating the SQL script from the migration. And next, this third step, we will be publishing the script as build artifact, and finally execute the script to deploy the changes to database. Okay. Here is a pipeline I just created, and yeah, let's see in Azure. So here is the build pipeline. I started with an empty pipeline. Okay, we can do something like this. I am using Classic Editor. My Azure, this is my GitHub repo. Sorry, not source code repo, and I'm choosing empty job. And then I'm adding. First, I need to install this one. .NET. Since we are working with EF core, first I need to install .NET Core. So .NET Core will be already there. So I need to install entity framework tools. And since here we use global .NET EF, which is because I can use .NET EF anywhere in the machine. But in a case of build agents, we usually we don't do that. We only create for local on that pipeline for that particular build pipeline. So instead of putting it into global, you first you need to if I want to execute a global a .NET Core tool in a folder, first you need to create a manifest, tool manifest. So I'm creating I'm choosing the command as custom. Instead of build, I am choosing custom, and then I am putting new tool manifest. So new, then I am choosing tool manifest. Okay, so it will create a manifest file. So it will be something like this. It will create something like this. Then I'm again adding a EF core tool. Here I am installing .NET EF. So here again I am choosing custom. Here I am choosing tool, and I am passing install .NET. So with these two steps, we have installed .NET EF tools on the build agent. Next, I'll be using the same script, similar script, migration .NET EF migration script, and I'm pointing to a directory, and I'm passing the idempotent flag. Okay. So let's create another. Here also I'm choosing custom and custom command. I'm choosing EF, and this is the arguments. So I'm running migration script, and this is the output directory or file, and I'm passing idempotent. Once it is done, you will be able to see like so far what we did. We installed the build agent and we generated the script from the code. And this is an optional step, publish pipeline artifact. So you can, if usually what happens, you have a build pipeline and there will be a release pipeline also. So if you want to keep it that way, you can create a pipeline artifact and publish this file to as an artifact to this build pipeline, so that you can consume it in the other uh, release pipeline. So here is an example of that. Here is a, pipeline, release pipeline, and it is using the build output of that this project. It's an artifact. Then there is a stage, and here I'm deploying it using SQL deploy task. If you want to keep it two separate, like one build pipeline and one release pipeline, you have to do it like this. And if you don't want to do it, you can always go for Azure SQL task and you can follow the same thing. These are same tasks. One is Azure SQL deployment. So if I add SQL, so this is the task I'm using, and here I need to choose my subscription. Then what is the authentication type? So it can be SQL Server authentication, and if you are connecting to SQL Server using identity and all, you can do that, or you can put connection string as well. So here I am using SQL Server authentication, and all these things is DB name, DB server, user ID, password, everything I kept as variables. Okay, and these are secrets. DB server, password, user ID, all those things are secrets. Okay, and here I need to choose a deploy type. There is inline SQL script, dpack, and SQL script file. So I'm using the SQL script I generated as part of this step in here, and it will be deployed. Okay, so here is the pipeline I ran few hours before. So here it is creating a tool manifest. Sometimes if the build failures in between, sometimes EF core or .NET core will show an error, like it cannot create the tool manifest. Probably you should add a force parameter here. Then it won't cause that problem. I'm not doing that. Then installing .NET EF. So here I'm installing .NET 2 EF. Installing it is got installed on that location. Then I'm generating the migration script. So it will be generated to artifacts directory, which is IA to do script, and I'm putting a flag add important. And this is a published task. It's optional if you want to keep it release pipeline different from your build pipeline. And I'm executing it on this SQL server. Okay, that's it. So now you are able to. So just now we created a build pipeline for deploying the database continuously. So you can enable CA, continuous integration, which is enabled right now. So if we change something, it will be automatically deployed. Okay. Yeah. Next, we go back to demo. And here is the YAML. So it is basically you can do it in GitHub Actions as well. You can follow the same steps. Only difference is that deployment environment variables and all. It's a difference in that. That's all. Yeah. So this was one of the problems I was facing. Like I mentioned earlier, we had to deploy the script into multiple databases. So but if you look into this SQL task, it will execute to only one database. So that is the beginning. So what we did, we created a PowerShell, and we are executing this code. So what this code is doing, it is connecting to master database and getting the names of all the databases except master, MDB, model, and MSDB from the list. And we are uh, like changing the name of master DB, which is this, with the database name, what we are here getting from here, and invoking the script file, like using invoke as SQL CMD, and we are passing the script file and the connection string we build dynamically. So this way, we are able to execute the same script in multiple databases. Yeah. So here, I just disabled it since I don't have multiple databases. So here, what I'm doing, I added a PowerShell script task. So shall this task, and I choose the inline option, and I just copy pasted this code. Okay. Only thing, you need a master connection environment variable. It has to be part of this. Then you will be able to deploy the same thing in multiple databases. Okay. Next. Okay. Uh, there is another scenario, like if sometimes if I want to, I don't want like link queue or directly use entity framework code. I want to use SQL Server, like we got a DBA. He wanted to write a stock procedure, and we wanted to uh, put it in database along with the deployment. So for that, what we can do, you can create an empty migration and write this code in the up method. So let me create an empty migration. So it's again simple .NET TF migrations SP vector tools. So it will create one more migration with the name, and once it is created, we just need to write this code in the up method. So when this is applied, it will be generate. It will generate the SQL statement, and it will deploy. So similar way, down also you had to write code. Okay, and let's try what is the migration thing it is generating. I don't know that is the proper parameter or no. No build or okay, yeah. So if you look into this, you will be able to see maybe since I said no build, it is not build, I guess. Yeah, build succeeded. You'll be able to see that code. Yeah, so it is check for this migration, and if that migration doesn't exist, it will creating a procedure. It is executing a code to create this procedure. Okay, that's the way we need to we can work with store procedures. Yeah, and you can consider a scenario. This is one is I am talking about a simple one-line procedure. If your DB is giving you a bunch of SQL scripts, what you can do, you can put these files are embedded resources, and you can write the similar code using reflection and execute multiple files. You can find it in this link. How we can do that? I think, yeah, one sec. So probably what you can do, you can now all files as embedded resources, and using reflection and all, you'll be able to get all the SQL files from the resources and execute it. Okay, similar. Okay, yeah. So this is good. SQL scripts is fine, but when recently we faced one issue. What happened? We were moving our Azure pipeline to our hosted build agent. So all of a sudden, our builds started failing because we don't have some components which needed for this SQL task. What was happening? We had to install SQL Server, PowerShell module, some other SQL related task and all in our build agent to execute this DB script task. To avoid these kind of scenarios, Frame core team came up with a new way, EF core migration bundle. It is nothing but an executable. We can run that executable and deploy the database changes. It's like a uh, like a .NET Core application which help you to deploy the changes without any SQL Server dependency. You need to follow the same steps, and once you created migration, you can say .NET EF migration bundle, and it will generate a bundle exe and or executable in Linux. You can just execute bundle.exe with the connection string. It will deploy that changes into your target server. So let's see a demo here. This is a similar project, but I don't have a controller and all. It's just I just created a DB context and a model class. So I'm first creating migrations. .NET TF migrations and initial. So it is creating a migration. So I don't have any migrations exist here, and it is creating a migration. Then next. it is created the migration. Then doing .NET migrations bundle. So what it will do, it will create a bundle.exe. Sometimes if you open the solution VS Code, this might not, this will fail, but you just need to close it and run the bundle command again. And I was facing some issues with the latest RTM version. So if you look into this project file, I'm using a preview version of NT Framework Designer and SQL Server. With the RTM version currently I have, it is not like working as expected. It was not generating the bundle.exe. So if you look at this, here it is generating a bundle.exe. What I can do, I can execute it. So here I'm trying to run bundle.exe with the connection string. So it is creating a new database, dev2. I don't have a dev2 database. So I'm just executing it. So here also you will be able to see what it is doing. First it is creating a database. This database doesn't exist. Then it is creating the to-do items table. And it will also create the AF migration history table. So if I go here, you'll be able to see similar stuff here. Migration history and to-do items. Okay. Yeah. And yeah, here is the GitHub action for deploying migration using database continuous database deployment using EF core migration bundles. So same thing, I'm installing .NET tool using .NET tool manifest, .NET TF. I'm putting a specific version of EF core. Then I'm creating bundle. I'm calling .NET TF migration bundle. Then I'm executing it bundle. Since it's Ubuntu and it is generated an executable, I'm just passing the bundle with the connection and the connection string as a secret. Okay, yeah, that's it. Any questions? Rajesh?
Yes, Anuraj, there is no questions.
Okay, we'll wait for a few minutes and
Yes, yes, yeah, we'll wait for 2 minutes.
okay. Like you can always I used to blog in .NET and you can follow me in Twitter, the right handle as.
Thanks, Anuraj. Thanks for your time.
Yeah,
Thanks for
thank
the
you.
nice
Thank
presentation.
you.
Okay, thank you.
Thank you.
Welcome you all. Time for the next session. Now we have Borden to talk about demystifying event-driven architecture with Apache Kafka. Welcome, Borden. Hi, Borden. All yours.
Okay. Hey everyone, and thank you for joining. Good morning, good afternoon, or good evening, depending on where you're watching this session from. I hope that everyone can hear me all right, because I know that if pandemic has taught me something is that if my microphone is muted or simply I'm inaudible, then people will tell me. So feel free to just say something in the chat. Or it's a pity because we don't really see each other. So because usually I see people, hey, stop what you're doing, and because we can't hear you. But I hope, with the hope that everyone can hear me all right. Well, let's just get started. My name is Bogdan Sukaciu. I'm a staff engineer at 8x8. And I'm also a Pluralsight author. So I create various courses, mainly around event-driven architectures and Apache Kafka. And so we have the presentation today. And what I want to start with is that with a myth. So because we always get the idea that event-driven architectures are all about real-time systems, right? Transforming data in real time, manipulating data in real time. But event-driven architectures aren't all about that. Of course, there are some specific use cases for real-time data, such as fraud detection. For example, let's pick the ATM example, right? Someone clones your card and then goes on the other side of the world and then tries to withdraw some money. Let's say it tries to withdraw $1,000. Then you have the system that analyzes all the transactions and it checks if there is a fraud. Of course, the system will try to figure out, hey, has that person teleported to the other side of the world to just withdraw some money? I don't think so. So it's going to stop that transaction. So there are some really specific use cases for real-time systems, but event-driven architectures solves also a different kind of problems, something which is a bit more powerful than you thought it will. And of course, theory is good, but practice is even better. So that's why I chose Apache Kafka. Is one of the most powerful and mostly used streaming platform nowadays. So it's, as you'll see in the soon, that is a really good fit. And I'm going to start with the beginning, because let's see how we actually got here with to event-driven architectures. And the best place to start with is the monolith. And I think that everyone knows about monoliths, right? Everyone has worked on a monolith before. And it's a simple, but it's a really powerful pattern. So the idea is that we have a lot of code, a bunch of code, which is encapsulated into a single running process, a single application. Let's call it like that. And usually that application has a database attached to it. Depending on how big the business is, that application and that database can grow pretty immensely, right? Pretty massive. So we can get hundreds of tables into one single database. And yeah, monoliths are great. I mean, it's simple, it's effective, and it's a really, really powerful pattern. But there is a but to all of this. And monoliths, they don't really scale really well. So there's a problem with scalability. If we condense all the problems that a monolith may pose, we'll figure out that it's all about scalability. And I'm not just talking about application scalability. There is also team scalability. So application scalability, I think we all know about. It's the app must serve more and more requests, and to do so, we need to increase the number of instances that the application is running. And that's a pretty easy way to fix it, but it's not really effective, right? Because usually only part of that application needs to be scaled up and down. So because only part of the application is more frequently used, not all at once. And then we have the team scalability, right? Just try to think about 20 or 30 teams working on the same code repository. There is a lot of communication going on. It has to be going on to actually get to something stable. And all that communication actually just, it's a waste of time, because people need to synchronize so they don't overlap with their code, and everything is pretty tied together. So things can go pretty bad if there isn't that synchronization, and that synchronization isn't very efficient either. So so going back to that monolith, we have a bunch of code encapsulated into a single instance of the application with the database. But we started to seeing people started figuring out that, hey, this is not really a good, it's not really a scalable pattern. I mean, if we need to serve more data and we need to serve more requests, then we need to do something about it. And then another pattern occurred, a service-oriented architecture, or SOA for short. So right now, our code is not living into a single application. It's now spread across multiple applications. However, it's pretty difficult to, with SOA, it was pretty difficult to define the boundaries, right? Because the borders of each service was quite tricky to get it, because they may overlap or so. And then we had another level of segregation, and what we call today microservices. Microservices usually are domain driven. So we have that domain, the business domain, which is split into subdomains. Then we have bounded context, aggregates, and all that cool stuff. And it works pretty well. I mean, from a segregation perspective, microservices are really, really good. And what's really good about it is that each microservice has ownership over some kind of data. So we see things like users microservices, or authentication microservices, or orders microservices, and so on. And there are and each microservice owns some type of data. And another cool thing about microservices is that we don't really have to stick with one type of database. We can have relational databases, PostgreSQL, MySQL, and so on. But we can also have NoSQL databases, because now we have the power and flexibility to choose the more appropriate database style for our use case. So we can have document-based databases, key value stores, and so on. So we can have a lot of interesting stuff going on. But monoliths have the scalability problem. Microservices actually solve this problem. But there is a very important thing to remember here. In software engineering, we don't really have good or bad, right or wrong. We have trade-offs. And then and the trade-off for microservices is data access. Our data is really hard to access because right now it's not really encapsulated into a single place, but now it is distributed across a system of microservices. And each data domain is kind of embedded into a single microservices and into a single microservice or a single database. And let's take, if you don't really trust me, just let's take an example. And I think we've all seen this kind of behavior in a microservices architecture. For example, one customer tries to make one request, and that request usually goes to 10 other microservices, because to compile the full data that our customer really needs, it must go to every other domain to actually get it. So it really poses some changes from a data access. Data is not really it's not really easy to access it anymore. So we have to go to our other microservices and get it. And that poses some challenges. We now have to deal with dependency management, with distributed transaction, timeouts, coupling, data ownership. And these are really powerful challenges, because one timeout can actually change the entire behavior of your application. So we really need to be prepared for all of these challenges. And yeah, as you've probably guessed, actually this is where event-driven architectures come to our rescue. Because event-driven architectures, they change the way we treat data. So we have a change of paradigm from events, from data as I know records in a database, to events. And yeah, microservices are usually data driven. Each microservice encapsulates the data, right? We define our microservice based on the data that it owns. But with events and event-driven architectures, things are a bit different. We model our system based on events, and also event-driven architectures are promoting something called data liberation. And you'll figure out right in just a second what data liberation actually is. But first, let me actually give you the definition of event-driven architecture, because I've been talking for 10 minutes about 10 minutes now about event-driven architectures, and I haven't really told what event-driven architectures is. So if you go to Wikipedia, you'll find this. Event-driven architecture is a software architecture paradigm promoting production, consumption of, and reaction of events. And the key point to remember here is the events, because right now everything is based on events. Everything revolves around events, and we have production, consumption, and reaction. So 3 different actions that can happen. So how can we transform our event-driven, our microservices architecture into an event-driven one, or better said, our synchronous API microservices architecture to an event-driven one? So let me take just a couple of services, and then, well, let's say that the blue service is sending data to our gray service through a queue, and then the blue one is also communicating with the purple, and I think that's the pink one, through REST. So synchronous REST APIs. Now, if we take this flow of data and then transpose it into unidirectional flow, you would get something like this, right? Since there is a queue, there is only one direction with the gray service, but with the others, we also get a response back. Now, if we transpose it to event-driven, we introduce a new concept, and that concept is an event stream. So an event stream is kind of an intermediary between so-called producers and consumers. An event stream is only there to facilitate the transport of our events, right? And yeah, producers are the application that are creating events and send them to the event streams. And consumers, on the other hand, they usually retrieve the events from the event streams and process them. We can also have the third type, which is producer and consumer. That kind of is a special kind of application, and it's called a streaming application. Now, what exactly is an event stream, right? Because I've said that we introduced that concept of event stream, but what actually it is an event stream? Well, an event stream can be anything. It can be protocols or tools, basically anything that you can asynchronously subscribe to. And let me give you some examples. We can have event streams as queues, as WebSockets, reactive APIs, logs, or topics. And I'm pretty sure there are a lot more examples that out there. But there is a slight difference between these types of event streams. Let's take the first 3 ones, right? The queues, WebSockets, and reactive APIs. These are so-called reactive events. And these type of events, once they are consumed, they can never be brought back. So if a consumer consumes the events from a reactive stream, then it's gone. We can no longer have that event back. On the other hand, topics and logs, they usually those events are actually persisted. And if the consumer wants to consume the events once more, they can do it freely. So they can actually go back in time and then read that events from the event stream. And what's really cool about all this stuff is that Kafka is actually using topics with logs under the hood. Because an event-driven architecture with Apache Kafka would look something like this. We have Kafka brokers, which are the running applications that are storing our event streams. And our event streams are represented by topics. And of course, on the left side, we have the producer applications. And on the right side, we have the consumer ones. And yeah, In Kafka, event streams are called topics. There is a slight difference between a topic and an event stream, but I'll get to that in just a minute. But first, I want to go through 4 key observations. And the first one is inversion of control. If there are any Java developers with Spring, you know that inversion of control is actually something really good, because we use inversion of control to manipulate beans. So instead of creating beans of ourselves, we just delegate that to the inversion of control container, to the IOC container. And that's a really good thing. So, and this inversion of control principle also applies in here, because in a synchronous API, it's the job of the producer to actually push the data to the consumer. And in our case, in event-driven architectures, it's not the job of the producer anymore. It's the job of the consumer to actually retrieve the data. Then we have the fan-out behavior. One producer can consume from multiple streams, and also multiple consumers can read from the same event stream. And this one is really powerful, because right now it actually solves our data problem. All the data is now encapsulated into an event stream, and it's there for us to be taken. We just have to subscribe that consumer, and then we can get it, and then we can do whatever we want with it. We don't really have to make thousands of calls to actually get the full data. The next one is what I call a producer type per event stream. And this is the difference I was talking about earlier between an event stream and a topic. So an event stream is just a topic, because a topic in Kafka can persist anything. So it can persist any kind of data. And we can even have mixed data. So we can have strings, and we can have integers, we can have any, or even complex object. We can have anything in there. But the difference between an event stream and a topic is that an event stream also has a structure, a data structure. So that's why the recommended pattern, the recommended approach is to have only one producer type or only one data structure producing to the same topic, so that we can have an event stream defined. And finally, producers don't really know consumers. So from a producer's perspective, its only job is to produce to an event stream, to a Kafka topic. And that's it. I mean, the producer doesn't really know who is going to consume it, and it doesn't really care. My job is just to produce messages to that topic, and then I'm done. On the other hand, consumers, again, they don't really know who is producing that data. They only care that, well, I need to get that data, so I'm just going to subscribe to that topic, to that event stream, and get it from there. But from a high-level architecture perspective, these things are really are well known. But keep in mind when you design your applications that producers and consumers don't have to be really well known. And yeah, that's it. With event-driven architectures, they actually solve our data access problem. Instead of using databases, we use event streams, and then we can get data from there. But again, software engineering is all about trade-offs, and there's a trade-off for event-driven architectures as well. And that challenge, that trade-off, is consistency. With synchronous APIs, we're really used to that strong consistency. We know for sure that when we're calling that API, we're going to get the full data, the actual data. But with event-driven architectures, we don't really know that when we're going to get the full data. And actually, the key to building successful event-driven architectures is understanding and accepting eventual consistency. And this is one of the facts why not all cases, not all use cases can be made event-driven. Typically, a system is consisted of a mix between event-driven systems, event-driven architectures, and synchronous APIs. So keep that in mind, that not all the use cases, not all the flows are made to be event-driven. We'll talk about a bit later about why eventual consistency matters. But first, I want to actually talk about events and what events are. And to do that, I'm going to start with data, and to be more specific, with messages. Because a message a message is just some data transported from one service, let's call it service A, to service B. And that's it. That data must have a structure, of course, to be qualified as a message. But in essence, a message is just some data with a structure. Now, that message may have different forms. And the first form is the command. A command is something that happens in the future. So usually service A sends a command to service B to perform an action. And that action is not really happening right now, but sometime in the future, because it may take a while to do it. So even though we trigger the command right now, the command will be executed in sometime in the future. That's why this is the future form of a message. And of course, in terms of replies, that's optional. For in case of commands, we may or we may not get a response back. And that this is actually the difference between a synchronous API. So in a synchronous API, in a REST call, for example, you actually get back a response. But if you use a queue just to send the message, a command, then you're not going to get back a response. Then we have queries, and queries happen in the present. And we execute a query, and then we always get back a response. It's just think about interrogating a database, right? So you want to search the users, all the users, right? You do a find by all users or something, and then you get all the users back. And that action, it's always happening in the present, because you need the current state of the data. You don't need the past state of the data, or you don't need the future state of the data, if that makes sense. But you always need the present state of the data. And what's important to remember here, you're always going to get back a response. So it can either be empty or with some data in it, but you'll always get back a response. And finally, we have events. Events are some actions, or there are some actions that have happened in the past, or there is something that has been triggered in there. And as I said earlier, events are undirected compared to queries and commands, because we don't really know who is actually going to listen for that event. And service A sends some events to an event stream, and from there on, it can be one or even multiple services listening for those events. And also, events are undirected, so we'll never get back a response. No matter what we do, we'll never get back a response, because that's how event works. And just a second. I want to talk a bit about the types of events that we can get. We can find out in an event-driven architecture. And the first one is event notification. And an event notification is basically an action that has happened or has been triggered sometime in the past. It must be something meaningful. It must be a meaningful action to the business. So, for example, a customer logs into our mobile application. That's a meaningful event, because it actually makes sense for us and for our business. But if the customer, takes a photo or makes a phone call with his phone, it doesn't really make sense for us, because that's an event we don't really care about. And one of the best examples that I can give you with event notifications are suggestions, the suggestion carousel from e-commerce applications. There are actually a lot of platforms that have implemented this pattern. And what you usually see is that we have a web shop, right? That sells, a multitude of items, clothes, electronics, and so on. And usually at the bottom of the page, you usually see a carousel, right, with suggestions. Now, the trick is, how do you compile that list of suggestions? Of course, we can go for a more classical approach. So if a user has bought something in the past, it might be interesting to buy it again, or depending on the page view. So if the user has seen that has been browsing to a specific set of products, then we can also show them in there. But what would happen if you're the first time in there? If you're the first time on that website, And this is actually a bit of a mind trick, because when we're scanning the web page, when we're scanning the web shop, we move our eyes, right? And usually when we're interested into a specific item, we tend to hover over that item. So we move the cursor over that specific item. So what really happens when we hover over that item, over that product, an event is being sent to the backend system. And the backend system just compiles those hovered events, right? And by the time you scroll down all the way to the bottom of the page, and then it's time to show up that suggestions carousel, you probably hovered over a couple of products. And the backend system already knows that. So you might be interested in buying some shoes or some jackets or some mobile phones or something. And then the backend system knows about all of your preferences already, and then just compiles the suggestions for you. This is a really great example because it really imposes that unidirectional style of events, because we were not going to get back any response. And yeah, let's actually see some code. I hope that everyone understands a bit of Java. So when we define an event producer and an event consumer, we start with, we defined the topic, the event stream, right? And then we have to specify some properties, both for the consumer and for the producer. The properties are pretty generic stuff, like where I can find the broker, or what kind of data am I going to produce, string data, full objects, integers, or it really depends on your use case. And then we have to create a Kafka producer and a Kafka consumer. This is just the abstraction of of the producer and the consumer. And then we need to, on the producer side, we need to create a producer record. And by the way, a producer record or a record is the terminology in Kafka for an event. So you will probably hear different terms about it. You'll hear events, you'll hear records, you'll hear messages. Just think that all these terms are actually referring to the same thing, usually an event. On the other side, on the event consumer side, our consumer must subscribe to that topic, to that event stream. And as you can see in there is actually a singleton list. So we can actually get, a consumer can actually subscribe to multiple event streams at once, and hence that fan out behavior. And then from the producer side, the job is to actually send the record, and on the consumer side, to actually get it. So on the consumer side, it's really more interesting because we have that while true loop, and inside that we have a consumer.poll. So the way that works in Kafka is that the broker are not pushing the events to the consumer, but the consumer actually goes to the broker and asks, hey, do you have any new events for me? If yes, then please send them over. And it does that every 100 milliseconds. So it goes for, it makes a request to the broker, and if the broker has any events, any records, then it just sends them to the consumer. If not, the consumer will wait for 100 milliseconds, and then it will make the request again. So I started all of this into 4 terminals. On the left side, I have the producer running, and on the right side, I have not one, but actually 3 event consumers. All the consumers are pretty much identical, so they will just display the events that they're receiving. And the consumer will produce a new event every second, so it has to we have to wait a couple of seconds, and we can already see sending message 4, and then a UID. So a record, a message, is composed of 2 things. We have a key, which is, in this case, I chose just an incremented number, and then we have a value, which I went for a UID. And now let's start the consumers as well. So starting with consumer 1, consumer 2, and then consumer 3. And as you can see, almost all the consumers are receiving the events almost at the same time. Just try to think about how difficult it would be to implement this pattern using synchronous APIs, or how much code it would take to implement this thing using REST APIs. It would probably be a lot of code to just direct the data to every consumer, every application, so that it can be sent in there. All right, so the next type of events is event carried state transfer. I know this is probably pretty hard to remember, and it's actually pretty hard to pronounce it, but it actually makes a lot of sense, and it's actually very how can I call it? It actually makes a lot of sense. It's very similar to event notification, but it has a different nuance, because event notification, it's all about an action that has happened, right? In event carried state transfer is about a change in this state. So let's take, for example, address changed event, right? We have a web application, an e-commerce application, and our user has changed its address from his or her address from from Paris to London or something, and we need to capture that with our event-driven system. So what do we actually put into that into that event, into that message? Should we only pass the new address, or should we pass the old address as well? What about some user information? Does that information actually make sense into that event? So let's say that we only go for the only the new address. We send that event with a producer to the event stream, to the Kafka topic. Kafka persists those events. So, and then it sends a copy of that event to the consumers. And then we find out that the consumer, one of the consumers, let's say it's a tax service. And tax service usually also needs also the old event and the old address. So, and also about some user information, because what we have right now, it's only the address and possibly a user ID. So it doesn't really have a lot of information to deal with. So what the tax service has to do in this case, well, has to query back the producer application. Hey, you haven't sent me the old address. Please send that as well. And this is actually bad. When you're designing your events, when you're designing your state change events, please avoid querying back the source system. This is actually an anti-pattern because it introduces coupling again. So instead of decoupling things through event streams, we're reintroducing events into our architecture. Also, another way to think about events is that they should make sense even after 10 years in a data lake. If someone sees that use address change event in a data lake, they should know the details about the user. They should know the details of the old address and also the new address. And this is a bit out of the normal way we're thinking, because we got so used with microservices, with monoliths, and the way we persist data. We usually persist normalized data. Each data entity is usually stored in separate tables. So we usually have a users table, an address table, and a contact info table, for example. But events, they actually prefer denormalized data. So an event should contain all the details into itself, so that it makes sense on its own. The next problem I want to talk about, it's the distributed source of truth. Just as I said earlier, our data is not really embedded, encapsulated into a single place in a microservices architecture, but usually it's spread across multiple services, and each service owns a different kind of data. And we see, of course, in order to actually process the request, we need data from other microservices. And we often see some workarounds. Instead of just relying on synchronous APIs, we tend to rely on workarounds. And a pattern I've seen quite often is just copying databases from other services to our own service. But this also poses some challenges. I mean, how can we keep those databases in sync? How to make sure that we have the latest version of the data? And probably a lot of work would have to go into writing those database synchronizers to actually make sure that we have the correct data at the current time. So we are now dealing with distributed systems, and distributed systems need another approach. And that approach is called event sourcing. And event sourcing is one of the most powerful patterns in event-driven architectures, but it is also very demanding because it all comes down to an event log. And since Kafka stores messages in logs, then we're we're really on the right track. Okay, but what exactly is an event log? So the best way to describe an event log is as a ledger. So banks, hundreds or 200 years ago, they didn't have digital systems to persist those records, and they had those physical ledgers when they had to write up every amount that a person has transactioned. So let's say that when a person opens a bank account, they start with an initial amount of 0, then it adds $500 to that account, and then adds another 200, and finally, just subtract 300 from that account. And the good thing about ledgers and event logs is that we can always compile the current state. And all we have to do is replay the log. So we start from the beginning. So the current amount is 0. The person just opened the bank account. So of course, there is no money in that account. Then that person makes a transaction, adds $500 to that account. And we have the current amount of 500. Then that person adds another $200 to that account. And then we have a current amount of $700. And finally, we have that subtraction, and $300 are subtracted from that account. And then we have the current amount of $400. So with event sourcing, we can always build up the current state just by replaying the events from the event log. And we're actually using this pattern for quite some time now. Actually, Git is one of the most widely used event sourcing pattern, because in Git, each commit doesn't actually store a replica of the project. It only keeps the differences. So we have the initial commit. We just created the readme.md file, and then with the next commit we add some code, and on the next commit we add some other code, just like adding a transaction to that event log. So Git is actually an event sourcing system. And how that event sourcing would work in Kafka or in event-driven architectures? Well, it enables it actually solves our data problem, data access problem. So we have the event stream, and then we have 3 consumers, C1, C2, and C3. And typically, messages are being produced to the event stream, right? So it's the job of the consumers to actually retrieve it from that event stream. Each consumer has a database attached to it. And when they are consuming those events, they're actually building up a state. That state is called a materialized view. So they are building a materialized view in their own databases. Then a new event is being produced to the event stream, and then each consumer will consume it when they can. And this, as you've probably noticed, the events are not actually consumed at the same time. They are actually consumed one by one. And that's why we're saying that we have eventual consistency, because we don't know for sure that by the moment the the event has been produced to the event stream, we're actually having the up-to-date state in our consumers' databases. So that that state is going to be eventually consistent. We don't know when, we don't know how long it is going to take, but that consistency will be reached at some point in time. Then let's say that something goes wrong with the database of the consumer 2, or even the consumer 2 application just goes down and the data is irrecuperable. So we just lost all our data. The really cool thing about event sourcing and event-driven architectures is that if one application goes down, it's not going to impact the other. So if a new message is being produced to that event stream, C1 and C3 can actually consume them without any issue. And in the meantime, we figured out that, okay, we can't really get that data back for C2, but we can actually bring back an empty database, because that's pretty easy just to spawn up a new database. And that's the power of event sourcing. With event sourcing, we can actually replay all the logs, all the events from the stream, and then builds them up, builds up all the way to the current state. So if you're doing event sourcing right, you can discard all your data from your materialized view at any time, and then just build it up from the log, from the start, all the way to the current state. And yeah, that's pretty much it. I just want to say that I barely scratched the surface in here. There are actually a lot of things to learn about event-driven architectures. I haven't mentioned about a lot of other patterns like change data capture or streaming patterns. So, but I just wanted to give you like a brief introduction to what event-driven architectures, what problems event-driven architectures can solve, and how to get started with it. And yeah, thank you for joining this session. Feel free to get in contact with me. I'm available on Twitter or LinkedIn or whatever you want. I'm also open for any questions that we may have.
Hi, Bowden. We have 3 questions.
Hey,
Thanks for
yeah,
the nice session. Let me pull up the questions.
cool.
The first one, can Kafka be used with web sockets? I have to open and keep communication for many users with one backend. Messages like conversations in chat started by user should be answered by backend back to a user.
Okay, I'm guessing that the WebSocket here is going to be kind of a middleware between the I know, let's say a browser and then Kafka. Yeah, sure, it's totally possible. I mean, all the messages that are going through the WebSocket can be adapted to and sent through a Kafka producer, and then it goes to Kafka. We can persist them in there. They can be consumed also for sentiment analysis if you're doing something like a support chat. And then if there are any replies, we can use a Kafka producer to send them the reply back to through Kafka, and then also through the WebSocket. So yeah, it's totally possible. Just needs a bit of coding.
Thanks, Bogdan. Let me pull the next question.
Cool.
Okay. Best would be to keep track of such conversation. Is it possible with Kafka for such synchronous communication? I think it's a continuous to the previous question.
Yeah, it is possible. Just well, it's a bit. There are a lot of slides to. Let me go back to here, I guess. Yeah, as you can see, every message has a key and a value. So in this case, I chose the key as an incremented value, but as an incremented integer. But you can also use the key as your identifier for your conversation. So someone opens the support chat, for example, and then when that support chat is open, then a new conversation has started, and you give that conversation an ID, and all your messages can have that ID as a conversation. So it's just about how to model those events. This question actually relates to how to model those events, and then yeah, you can use the messages keys, the events keys as the conversation IDs, and then you should be good to go.
Okay, thanks. Now let me pull the next question. How to make sure the order of messages in Kafka?
That's another question related to keys, because Kafka actually guarantees the order on partitions. I haven't really mentioned this concept in here, but basically a topic can be split into multiple partitions. You can have only one partition, but you can have also more partitions. So the um, the number of partitions is strictly correlated to the number of consumers, the consumer instances. So if you have like five consumers, then you need a topic with with five partitions. And Kafka actually guarantees order of messages on a partition based. So if you go for if you keep that in mind, that messages are ordered per partition, then you should be good to go. And messages are spread into partitions according to their keys. And if you give the same key to the to a topic, to a message, to an event, then they will all go to the same partition. So you have that order that you want.
Um, Thanks, Boden. That's all we have from the Q&A. And
All right,
yes,
cool.
um, if you have any other questions, yes, you can contact Boden. He already mentioned
Yeah,
this.
just feel free to ping me on Twitter or LinkedIn. I'll be more than happy to just answer the questions or have a longer chat if you need like a virtual coffee or something. So feel free to do so. And yeah, I know that a new session is going to pop up, Introduction to Open Service Mesh by Robert Strand. So please do stay and watch the next session as well.
Thanks, Boden. Thanks for the nice session. And yes, we'll
Cool.
wait for the next session to start in under 10 minutes.
Cool. Thank you, everyone, and have a great day.
You too. Bye.
Bye-bye.
Sriram. Hi, Sriram. Yeah, how are you? Yeah, fine. So, shall we start or just you can require?
Okay, it's time for next session. I welcome Mr. Roberto Strand. He's a Microsoft Azure MVP. He's a cloud architect working primarily with Microsoft Azure, founder of the Norwegian Power Solutions Group. He's an active speaker and also an open source contributor. Yes, Robert, it's all yours.
Yes. Hello. So, first of all, usually I sit at home at a home office with real like a ring light and an extra fill-in light and everything like that. But this session happened to be recorded while I'm back in my childhood home above the Arctic Circle, more north than probably most of you have been. So I had to work with a laptop and bad lighting and everything like that. So sorry for the what I call the nose hair camera angle, but hopefully it's not that bad. So yes, thank you. As mentioned, we're going to take a look at Open Service Mesh and what that is. Just quickly rebrief on who I'm at. I'm not going to spend that much time on it, but like mentioned, my name is Robert Strand. I'm cloud architect at Crayon, and I'm based out of Norway, but I work globally. So if anyone has questions or wanna talk to me about the things that we do, then let me know. Probably can help you. Primarily work with Microsoft Azure, but also do a lot of multi-cloud stuff. I work with Terraform, infrastructure as code, all the DevOps thing, and also the cloud native thing. My two recent passions, at least. I sit on the GitOps working group for the CNCF, and also going to do a lot with a couple of other working groups and host some projects there as well. So doing a lot of things these days, which is fun, but kind of that's what makes it hard to plan. That's why I'm kind of sitting here in Tromsø. All right, so Service Mesh. I'm just gonna talk briefly about what Service Mesh is and kind of why you want to use it, but not really go into details. When I started to plan this session, the first time that I had it, I kind of looked at the all the providers of service meshes and see what they said, see if they could explain it better than what I could. And I found this quote at the website for Buoyant, which is the creators of Linkerd, which is the original service mesh. Kind of a good source there. And they said a service mesh is a tool for adding observability, security, and reliability features. Sorry, early in the morning for me, to application by inserting these features at the platform layer rather than the application layer. I thought that's that actually sums up service mesh pretty well. But same time, it's kind of it's kind of hard to even if you don't have the background from these things, it's kind of hard to understand. So kind of went on and found the Nginx said that. That service mesh is configurable low latency infrastructure layer designed to handle a high volume of network-based inter-process communication among application infrastructure services using application programming as APIs. They need to be so explicit. And I think actually that's kind of summarize it a bit better. So it is a network-related thing, and it's a way of setting up another layer of networking where you can more easily get get some of these features in. But I also saw that Solo.io have also a little tidbit here and said that that service mesh is an infrastructure-led abstract application networking from the business logic of your application service. A service mesh can provide a configurable network layer for communication between services using their APIs. Communication between the application services are facilitated through the sidecar proxies, forming the data plane that communicate, and that communication is managed through the service meshes control plane. And to be honest, it's a little bit longer than the other ones, but this one actually totally hits the spot. So this is exactly what I try to communicate at the service mesh is. It's really just a taking, we like to extract things, so it's basically just extracting the network layer from the application code, and then on that level, make everything interconnect in a seamless fashion. and we have this very high level design of what that kind of looks like. So in a Kubernetes cluster, you have pods for your different applications, which might be one or more container or several containers, all depending on what you need. And everything that runs inside a pod operates on, kind of like a local host type scenario. So everything kind of uses the same networking, et cetera, et cetera, et cetera. So what we mean by a sidecar is that on each pod, then a proxy sidecar will then get injected, like we see here, which then kind of steps in between the containers in a network setting. So when they try to communicate, they go through the proxy sidecar, and the proxy sidecar knows who to ask for, all the directions, which is the service mesh control plane. So in that way, it doesn't matter how you deal with your application code, because everything that's network related is going to go through the proxy sidecar and get handled in the same way. So it makes it easier. You don't always need service mesh, and the good old, when do you know when you need when should you set up service mesh? It's when you figure out that you need it, this kind of thing. You don't really need it for normal stuff, but if you need mutual TLS and secure traffic between pods, if you need to have service discovery, for instance, across different clusters, if you and those kind of things, or for instance, observability, if you need to do tracing in a more detailed fashion, that's where a service mesh comes in. So why open service mesh? These couple of boxes here are just pulled from the open source mesh website, because I wanna show what they are trying to get across. And what they say that they're trying to do is to create a simple to understand and a simple to contribute to service mesh. So the code base is pretty simple. All the decisions on how everything should be connected is pretty simple. And when you set it up and start working with it, it is pretty simple. So it's like simple throughout the process. So if you're using a service mesh, you shouldn't have any issues getting it up and running. And if you want to contribute to it, it should be pretty effortless to do. And next step is effortless to install, maintain, and operate. And that it is. I'm going to show that in a little bit. They want it to be painless troubleshoot, and open source mesh integrates into Jaeger, it integrates into Grafana and Prometheus and everything like that, just seamlessly. So you should just be able to install it. Something happens, it should be easy to find out why that happened. And they're also aiming to be easy to configure via service mesh interface, which is a standard, which I'll be talking about in a little bit. But summarized, it's just we in the cloud native community are trying to get some standards in, because we haven't had standards, which is why we have a lot of service meshes, for instance, which is why we have a lot of ways to have been handling the data plane, for instance. Observability have been a thing. So many of these things, and secrets, not forget secrets and storage. All these things are now being attempted to create a standard around so you have something which can be used between these different tools. So anything that's using the service mesh interface, you could more or less just change out the working part. So if you're setting up stuff with open source mesh, you could then remove open source mesh and set up a service mesh that uses also the SMI, and it should continue to work the same way. So, all right, the components again, handily is stolen from the open source mesh talks, because why reinvent the wheel? So as we can see here, we have, let's see if I can point. Yes, I can. So the basis of everything is the controller pod, which does all the hard work. Among one thing is that it checks or gets setups, talks to webhooks and also injects the Envoy proxy sidecar. Open Service Mesh uses Envoy, and that's not a bad thing. It just means that they aren't focusing on creating their own proxy, which, for instance, Linkerd did. They created their own proxy. If that's better or worse, well, Envoy is at least a big open source contributed project, so people are using that for a lot of things. So it's a good choice for when it comes to proxies. But the control pod then injects the proxy in there. It also deals with the endpoints providers, which we'll look at in the actual YAML files when we get there. It can also handle certificate management. So it can set up stuff when it comes to the mutual TLS. You could set up things towards HashiCorp Vault if you want to store your certificates or have your PKI there. If you're using Cert Manager, you can do that, and also many of the many others through the little setup in most cases. These are more integrated, but you could set up other internal Cert Manager tools through Tress or down. It also monitors the SMI specifications, and it also is the control plane which the proxy then talks to figure out what's going to happen. And also, like I said, Prometheus and Grafana pulls the information directly from Envoy. And you also have OpenTelemetry and Jaeger, which can then push from Envoy can push to, so you can have traceability. And everything just gets stored into Kubernetes API, normal type of controller / operator model, and it works pretty good. All right. So service mesh interface, like I said, it's a standard that have popped up relatively recently. It's starting to be relatively recently, and again, this is just because it's been hard to be using service meshes because everyone's trying to do their own thing, having their own resource definitions for everything that it does. That just kind of makes it hard. What SMI is trying to do is add several custom resources, which should that will work the same way no matter what uses it. How they implement stuff in the backend on the technical side doesn't matter, because this is declarative. So when we have declared something in a certain way, that's how it's supposed to be. And the resource or custom resource definitions that have come as of yet, and there's stuff moving. It's an iterative process. It's the things that are defined is the access control. Which service should be able to talk to which service. There's something called a split, so you can do traffic splitting, and then they have defined how a traffic spec should be defined. There's also a traffic metrics, which was very much beta and kind of working on. I'm not going to look into that as of right now. That might have changed since last time I look. But what we're going to look at today is the access control. And obviously spec is going to be in the background there, and we're doing some network splitting. All right, I'm just going to make sure that I'm not running out of time. Again, kind of hard when you don't have all your screens and stuff like that. So installing Open Service Mesh is really easy. You could either download and use the OSM CLI tool, which is really good. It helps you get a lot done a lot quicker. But if you do a OSM install, what you actually kind of do in the background is doing a Helm deployment. So obviously Helm is a tool that you can use there. If you're running things on Azure Kubernetes Service, there's also an Open Service Mesh add-on that is available there. I'm pretty sure. Haven't tried that one yet. I've just done it the manual way, but essentially it's the same process. All right, demonstration. Let's see if I can jump over. So hopefully this is big enough. I have a terminal and I have my cheat sheet basically. So excuse the messy part up here. So what I've done, if I do a K9s, which is a handy tool, really recommend that to everyone. Oops, maybe do it the right shortcut. Oh, there we go. So what I've done is I've set up a cluster. I've installed OSM. So in the OSM system, there's the controller and stuff related to Grafana and the injector, etc., etc., etc. So the things that actually make OSM work. And I also went and installed the pods that are needed for a demo, which the OSM people have actually created. So if you go to the documentation, you can run this demo yourself. It's really easy to set up, and makes my life a whole lot easier. All right, wait. All right, so we have those things. If I go over here, we can see that I have my I have a couple of things. I have a bookstore application, which, as you can see right now, have sold 4,130 books. This this has been going on for a little while because I set that up before starting because I didn't want to have technical issues, which I did have, so I'm glad I did. But this just continuously updates, and based on if a book buyer have bought a book, the counter goes up, and as you can see here, it's bought books from the bookstore version 1. We're gonna deploy the version 2 in a little bit, but we also have a book thief, which are still in the book. So we have two clients, a book buyer and a book thief, and we have our bookstore version 1, and we have our bookstore version 2 not installed as of yet. All right, so that's what's going on right now. As you can see, it obviously works, which means it is open, the network is flowing, and the reason for that is because I've installed it with something called permissive mode. So permissive mode means that you are allowed to do whatever you want, basically. It doesn't look at any rules. It doesn't look at those kind of things. So it's just open. So what I can do, right? That's why I had to do the dash one. Sorry, I forgot. Sometimes working with a lot of different shells makes stuff hard. All right, so if I now patch the OSM config to say that permissive mode is set to false and go over here again, now we're not getting any traffic. Everything stopped. No one's allowed to do anything. If I go and enable it again, we'll see that there you go, that everything's going to start up working again. So now the traffic is open. No rules are checked, but that's not for secure setup make. Do you need to use like the traffic access stuff? No, not really. If you're putting in open source mesh for other reasons like mutual TLS and everything like that, you don't need to do this. You can have it in permissive mode and be open, but securing stuff is better. So that makes sense. I'll go out of Bash right now because it will be easier to see. So what we're gonna run is, whenever it's downloaded, what we're gonna do is, now that everything's closed, it's closed, just making sure, we're gonna set up a traffic target, which we're gonna call bookstore. The next bookstore, and the destination for bookstore is going to be a service account called bookstore in the namespace of bookstore. It's kind of what you get in Kubernetes. Sometimes you get a lot of repetitive things, but it does make sense. The rules that we are going to define is an HTTP route group that is called bookstore service routes, which is matching certain HTTP routes, which we'll see down below. And now we have a destination, we have our rules, but we need sources. So we're setting up one source for now, which is the book buyer. And as we can see here, we have commented out a book thief as well. So first we're going to give access to the book buyer and then the book thief. The HTTP route is, as we can see here, the bot's book and buyer book. It's a path regex and get. So if you're trying to get on the API on the endpoint the book spot with a header that says it's a user agent and client app is a book buyer, that's allowed. So you can get a really explicit here, right? You can kind of define more or less everything that you want at this point. So all right, let's apply that. And what should happen is that the stuff gets created and bookstore will start selling books. The book thief does not have access, so nothing's happening there. And the book buyer is the one that actually does all the trafficking. Let's see, 50 minutes left. Just make sure. So what we also can do is then, I probably don't need to show this because it's kind of obvious. What we then can do is add update the traffic target to also allow the book thief. Again, just pointing this directly to the things that they have on the documentation makes it a whole lot easier for me to show. And there we go. Now both the book buyer and the book thief are allowed. And so that's basically traffic targeting. But then what we want to do is we want to get up a new version of the bookstore, which I just did. I need to restart the port forwarding. There we go. And then everything stopped working. But if we go through and refresh everything, we should also have this one. All right, so now we have our bookstore v1, which is the one that's getting all the traffic, and we have the bookstore v2, which is not getting any traffic, which is too bad because it's so much better version, I think. I don't see any difference, but I think it's better. So what we want to do is to test if everything, first of all, we defined a traffic split that's not that much of a split. It's 100% to the v1 service. Probably should have done that while doing the other one, but whatever works. So right now we have a split setup, but that split is not split into different bulks. It's 100% to the version 1 bookstore. What we then could do is I don't know why I showed the other one, but if we look at this again, I think everything is in the same. Yeah. So that for no good demo make. I had to recreate some of these before yesterday. So again, laptop. Yeah, so what we can do is say that we want 50% of our traffic to be going to the version 2, to check that everything's working. And again, we just update our traffic split, which already exists, which is the big bookstore split, and we'll update the backend on the service to not only go towards a bookstore, but also the bookstore v2 50% of the time. And I think this is just basically every other or something. I think you also can define a bit on how you want that to work. But as you can see, as soon as we update it to have 50% to the v2, we're starting to get traffic on v2 as well. From the user's perspective, there's not a lot going on here for them. It's basically just we have something to check if it's v2 or v1, but if it was a normal user accessing a normal endpoint, it wouldn't make a difference for them. I think this one also, this one is actually not allowed to go in there, so that's kind of fun. Anyway, and then what we can do is then update the split again, obviously to be 100% to v2. And at that point, bookstore V1 is not getting any traffic at all. And the bookstore V2 is getting all the traffic. And what I basically went through here is more or less everything you need to know on how to manage let's see if we do this. There we go. Manage traffic and manage access. Obviously, that's not all Open Service Mesh does, but having set up the by default, the Open Service Mesh is doing mutual TLS, so the services talk between each other with the with a certificate. At mine, you can define that yourself. And besides that, you can then obviously we can go on to look at Jaeger and Grafana and see what happens there. Let's actually just quickly look at that. Then I need to stop this. Just let's see if this opens up in the right window. All right, cool. We did. And this is just a standard Grafana. Yeah, okay. This is just a standard Grafana that got installed. You can obviously, have everything like this set up yourself. Again, everything just gets dropped into Prometheus, so everything here works the same way as you think it would. If you look at not this one, there we go. If you look at the dashboard here, we can see how many namespaces we are monitoring, because we don't need to monitor a namespace. That's a label and annotation. That's a label to make it monitor and a label to make sure that the proxy gets injected. We can see here how many pods we have. We can see how many pods are connected through proxy in a more a graph here, and things related to the memory footprint and CPU usage for OSM itself and its services. Just a lot of information. Obviously, there's some of these don't really work that well in this demo, mainly because we don't have these things set up. So some of these things don't work out the box. You have to do some tweaking, but in itself, it makes it easier if you have your Prometheus and everything set up. You can also set up that through that and have these dashboards there as well. So don't need a different Prometheus and Grafana. All right, I can't really see if there is any questions, but I at this time, I think since we started a little bit early as well, we could do some questions.
Hey, Robert, we don't have any questions so far.
All right. That's perfectly fine. What I can say is just to round up, if I can write, is that Open Service Mesh is pretty easy to get started with, and you can go to openservicemesh.io and see everything here that we have and see everything that we talked about and see what's going on. And it's a moving it's a project that is worked on. There's the releases almost every day, it seems, and a lot of things that are popping in, and everything that you need to know can be found in the documentation. And if you want to set that up, both for things like ingoing and outgoing traffic, every single small detail is here. So if you want to get started with it, after seeing how easy it actually is to set up, feel free to go into the Open Service Mesh docs, and you'll find everything that you need here.
Thanks, Robert. We have a comment from Santosh saying, learning something new. Thanks for the amazing session.
And obviously, if there's any questions after the fact that you don't want to bring up here, just feel free to contact me on everything, just like everyone else, Twitter and LinkedIn, and et cetera, et cetera. So feel free to connect with me there, and I'll then ship me a direct message, some shape or form, and I'll try my best to point you in the right direction at least.
Thanks, Robert. Thanks for the nice session.
All right. Thanks, all. Bye.
Bye. Okay, we have the next session. I welcome Mr. Subhasis. He's going to talk about leveraging Azure PostgreSQL hyperscale for 2x performance via Amazon Redshift. Um, Hi, Subhasis.
Yeah, am I audible?
Yes, you are.
Okay, perfect.
Yes, Subhasis. It's all yours.
Okay, so I'll share my screen
Yes,
and
please.
hopefully it's visible. Sorry, so how do you share? Correct.
You have in the bottom of the banner, there will be a fourth option. Says
Yes, agreed. I can see the entire screen and share.
Yes,
So
now yes, I can see now.
perfect.
Yes,
Yeah, so can you see the deck?
yes,
Okay. So can we begin, right?
yes. Go ahead, Subhasis.
Okay, fine. And
Stage
if
is
there are any
yours.
questions, please do take a note and we'll answer them during or post the session. No worries.
Sure, it will be there in the comment section. Yes, I'll also mention in the comments, and if there is anything, yes, we'll take it in the end of the session.
Fine. Thank you so much. Then let me begin quickly because we have exactly 30 minutes to go through. So first of all, hello everyone, and thanks for attending this session really, and I hope everyone's having a great time at the Azure conference. So a little about myself. So I'm Subhashish. I'm the Cloud Solution Architect, Data and Analytics at Microsoft. So I'm part of the Enterprise Commercial EC US Global Account Customer Success Unit team, and I work specifically with one of our large retail customers. So that includes basically focusing on solutioning and architecting and optimizing both SQL and NoSQL databases, and specifically I work a lot with Azure Cosmos DB and open source database include in Citus, which we're going to talk about. So quickly moving on, this basically talk or this session is based on a specific use case around, again, interactive analytics that we enabled at an e-commerce customer, and then also help them migrate their interactive analytics workload from one of our competitors to Azure database for PostgreSQL. So there's a specific SKU there called hyperscale. If you are aware of it, basically also referred to or known as the Citus extension. So we'll also take a look at how we kind of optimized JSON, documents. So Citus gives you some fantastic abilities to work with very complex JSON, and if your queries are supremely complex in nature, that's where really Citus kind of shines through. So that was also one of the cornerstones of that piece we will take a look at. Also, the reason why we are showcasing these use cases, this was one of the very first and very innovative work done around Redshift to Citus migration. And the key learnings were quite massive. So I'll share all of it here. If you're working on such use cases of your own, you can definitely take a look up there as well. So quickly moving on, let's understand the customer scenario first. So basically the customer was an e-commerce org, mainly working in the online furniture and appliance rental space. So since they had started with, Amazon Web Services, they're of course over the years grown organically with them. And Redshift was one of their central pieces, or rather you can say the data warehouse where they used to store, analyze the data. And the data is what kind of data I've been talking about? Basically, created from events like websites, sales, marketing, support. So they're all applications, and also the load was very near real time, let's say 20 to 30 minutes. And Redshift was the central piece. So in very short words, when we met the customer, they basically put 3 tasks to us. They said, you know what, we want to achieve 3 things from this project, which we want to undertake. First is we need to optimize TCO, of course. And the very connected point to the TCO optimization was that their current solution didn't enable them to kind of scale independently storage and compute. How do you enable us to do that? Secondly, we definitely want our queries to run faster. And that's the corner piece of this particular session, if I leave even everything, out. And third was also they were adding more workloads onto their interactive analytics at scale. So do we have a solution on Azure which kind of enables us to do all 3 of them together? So that was the, key challenges which were given to us. Now, quickly moving on, what was our solution approach? Now, if you look at their source, which was, that's Amazon Redshift, right? It's basically based on historical Postgres. Redshift was created as a proprietary fork of Postgres. And then, of course, they made a lot of modifications on top of it. So our customers' data size, again, very, very important to note. I'm not talking about petabytes. I'm not talking about, zettabytes of data. No, I'm talking about only 500 GB of data. It was extremely, extremely small. But there were a lot of challenges around it. That's what we're going to take a look at. So the first thing, because we looked at the size and we thought, wow, fantastic, is then let's test it out with a vanilla PostgreSQL on a single server. So as you're aware, Azure database for Postgre gives you a single server option. We tried that, but it didn't make a cut. The question comes up, why did it not make a cut? Because we had very complex queries, some of which we'll take a look at. They have been running pretty well in Redshift. Because it's a columnar store, but those SQL queries that we've been running in, let's say, single-digit seconds on Redshift took more than 40 seconds, 50 seconds. Some never ran to completion. So this is because though Postgre offers parallel query feature that I'm sure you're aware of, right? You can parallelize single query using multiple threads and so on, but it is highly restrictive in terms of what type of queries and what parts of the query plan can be parallelized. That's the key point to take away here. So if the data size is small, then do not ever make a corollary that it will work on a single, node. That was one of the big learnings for us. That's when we kind of got in touch with the amazing PostgreSQL engineering team at Microsoft. And they said, what, hang on, have you guys tested out or, taken a look at Citus, which is the hyperscale extension? So quickly, a few points to note here. So hyperscale Citus is built from Citus, which is an open source extension to Postgres. And on Azure, the hyperscale, what the Citus gives you the ability is basically transforms Postgre into a distributed database so that you can shard and partition your data across multiple nodes in a server group. We basically call it a cluster, distributed cluster. So the application still sees and interacts or speaks with the coordinator node, but you have a set of worker nodes underneath it, which is doing the bulk of the work. So the workers are where the actual data is stored, and where the actual processing happens. And the Citus API has built-in logic around this image, if you see, right? That kind of, takes the log, breaks down the single query into multiple subqueries, and then kind of runs them asynchronously. I mean, you can set it up like that in parallel across multiple partitions. So partitions are what we call these shards, right? For, better performance. And how are these shards made? Very simple question to ask if you like, how are these shards created? So shards are made technically by what we call, we incorporate a hashing technology where we pick a key with a good cardinality, and then across the largest tables at least, so that it divides the hash space kind of across the cluster. So that's basically like consistent hashing, right? So the one major advantage of Citus is that this does not just limit itself to the operations, but it extends to all the SQL constructs also, which is very important, like joins, subqueries, group by clauses, if you write complexities, windowing functions, and so on, right? So for folks on the call who are from the Hadoop world, you can close your eyes and think it's very similar to MapReduce, but just for the SQL world. Now, quickly coming to probably the most important slide of this session, that is, we made a few conscious architectural design decisions for this use case. That is the key takeaway. If you forget everything about this session, also fine. This is the main slide. Why? Because some of these key design choices enabled us to get the numbers which you will see in the corresponding slide. So first, most important, like when you are doing data modeling across any database, right? Cassandra, Synapse, Cosmos DB, the first and foremost is to decide on the data model. How do you decide that? Based on the use case. So for us, when we looked at the data sources, though I mentioned number of sources, the most important database, or rather the data coming or generating, was from the clickstream data. So that was prominent. That defined our data model. And then in Postgres, you have the capability to define in Citus what we call the distribution column. Now, there's a distribution column also, folks, called distribution key or a sharding key. But this is extremely important because why? First and foremost is that kind of defines the pattern that you're going to follow for your database for that application. So in Citus, we have two key patterns. So what are those patterns? You should know them. One is called a tenant-based, and the second is called entity-based. So tenant-based is basically where you are having low cardinality. Let's say you are building a SaaS application and you have a couple of tenants. That's good. You should go with the tenant-based sharding pattern then. But for us, we made a conscious choice. We picked the entity sharding pattern because the fundamental requirement was to process billions of rows, right, in analytics workload. So we made the choice of picking the user ID as it's a natural sharding key, because events are generated from whom? Users. And the dashboards we are making are for whom again? For analyzing and understanding the user behavior. Because the company was building, let's say, loyalty programs. You cannot build a loyalty program and target your top 10, top 20, top 1,000, top 10,000 customers unless you deeply understand the user buying patterns and behaviors. So that was very important, design decision. Again, a very important guideline to follow here is data is co-located based on the data type of the distribution column. Always remember, it's not on the name of the column. It's very important. Then the second very important point was query parallelism and indexes. Again, extremely important because, again, of the data prominence of clickstream. Why, there's a very important point to understand here, because in Citus, you get the flexibility of a Postgres single server, plus you get some added advantage. So for example, you can create an index and you can also create an index concurrently. So what it does is basically leads to very good, performance benefits. Concurrently, basically under the hood, avoids blocking of the writes during the index creation. Correct. So that kind of also speeds up, let's say, the speed of execution. We saw at least 5 to 10x performance improvement, as you saw. And for this particular use case, we build around 40 indexes, of different dimensions, specifically for this particular use case. Now, third very important point, which is probably the fundamental reason why, really Postgres makes an excellent choice if you're building real-time dashboards, real-time analytics, interactive analytics, is the prominence of a specific data type called JSON, which is easy to store, very complex to deal with. And Citus makes it very easy for you. So we had, let's say, if there were 50 tables, in 10 tables, there were around 50 plus columns, which had, let's say, around JSON characters in the range of 30 to 35, in some cases more than 40,000 JSON characters. And that's also, this third point is one of the reasons why, without taking the name, we could not go with a few other prominent SQL offerings out there. Because the moment we fired those queries, the databases simply died. I mean, they just died. So how do you manage this? It was the cornerstone of the complexity. Now, here, one very important thing to note also, again, if you go back to history, the customer was facing challenges with these type of queries on Redshift. Question is why? Because in Redshift, you basically were forced to store the large JSON documents as text columns in Redshift. So if somebody writes a 10,000 character, or a 50,000 character, comment for a tag in a, blog, how do you store it becomes the major challenge, right? So the problem was, if storing as a text column in Redshift was, then you need to pass through those JSON documents to use the JSON functions that Redshift provides. That makes it pretty slow. And if you're doing this over an iteration of billion rows, you're pretty, toast. So the use case was that, how do you store it and then also kind of do it, processing better? So the good news is that in hyperscale Citus, you have the native integration and support of something called a JSON and a JSON-B data type, where you can store and query JSON documents, and you can also use JSON-B to store the JSON document in a binary format. So typically, if you ask me what's the difference, and we of course went with the JSON-B and not with JSON, because typically there's a difference that JSON data type stores the data as strings, whereas JSON-B data type actually decomposes it down, without going into much details, it stores in the form of a dictionary for, let's say, Python, instead of just storing it just as strings. So as part of the migration process, we also kind of enable them to, migrate this to JSON-B and then use the robust set of functions around JSON-B, to also kind of get optimized. And here, one very important point was also the type of indexes that you build for the JSON-B data type plays also a very vital role in query parallelism and index formation, specifically for performance. So if I kind of share my screen, is my screen visible? Like, can we see the PG admin screen right now? Can someone confirm?
Yes, we can see.
The PG admin, right?
Let me I maximize and see.
Because I just put it over the screen, so I have no idea whether this is getting...
Yes, PG admin screen is in...
correct? So thank you so much. So I'll quickly explain the concept and where the optimization you need to do is. So as you see a DT I did, I have basically, 3 tables, and I created a table called reviews. So review basically has a column with JSON-B. So I'm, let's say, pumping JSON-B into this, right? This is standard till now. And then basically I tried uploading a file called customer reviews nested. So of course it gave me an error because I had forgotten to set the client encoding. So I set that and copied that. And it has what, like 600,000 approximate number of like JSON records. So if I do a select star and just limit to 1, as you see, this is one single JSON record. So it has customer ID, it has subcategories, it has the main category, it has the date, and this is the entire thing is stored as a review. Now the question or the point, very important point here is that, of course, I can create a index on it, just like this construct, but this creates a B-tree index for me, right? So when I can definitely then fire queries like this, but then I need to restrict to specific, columns and, let's say search criteria for going through it. So it is not reusable and not highly optimized. So if you are storing a JSON-B data type, then the by default is you should go with the general inverted index, the GIN. So GIN works extremely well with JSON because it gives you the ability, as you see, the core difference here is while I'm restricted to this search path, here I am not. I can search, I can traverse through, I can, do a lot of other combinations. I can reduce to 1 character. I can do a lot of, manipulations around it. And if you see the, details of this, as you see, the B tree has been stored and a GIN has been stored. Now there's one point to note here is that B tree, when you create, takes lesser time to get created, but it stores, let's say if the total data set is about X MB, B tree will be like 20% of that. But GIN is larger in size if you just do the GIN on the entire table. So for that, then the recommendation, another optimization that you should always remember is you should not do it on the entire table, but rather on the specific search path. So as you see, then I created another index, which is in GIN, but for the optimized path for the search where I'll do the most searches, right? And when it gets stored, right, as you see, it gets stored again as a GIN. But the very important point is this GIN would be larger in size than B tree and GIN, but this second GIN would be approximately in same size as B trees. That's also an important parameter to note. So when you're working on this, so a very important point to note here is if you are having data records like this, definitely store them as a JSON B. As I mentioned, under the hood, it gets stored as a dictionary, and it's much faster to work than JSON. And ensure that you don't use the simple B tree, rather go with GIN, and specifically also on the optimized paths. It's much faster to work than the generic GIN. So that's an important point to note. And now quickly going back to, again, this is mentioned the GIN type indexes. And also another very, very important point which came up during when we were working, and this we had of course not decided, we found this out while working, is that the JSON-B data type, in addition to a lot of other functionalities, right, it also gives you a massive boost in compression. So we saw around 6x to 7x compression because the point how we approached this was Redshift around the data size was 550 GB. For Redshift was around 500, sorry, and in Citus it was around 550 GB. But we had expected it to be much larger, correct? But it was not. It was only 50 GB larger. So the fundamental reason is because using the JSON-B, right, it inherently also compresses the JSON documents. So it basically uses something called Toast. For those interested, please go take a look at that. There is good documentation around how Toast kind of works with your storage and indexes to basically compress the documents. But the beautiful point to note here is that as the size of the JSON document grows, the compression rate also increases. That's also an important point to note. So a quick look at some of the real numbers. I've of course deducted a few of them for presentation so that we don't represent the real customer queries. But the queries were again a mix of very complex materialized views. These were the top 10 most complex queries which we had. At over 200 queries were there. And as you see on Redshift, we got all in seconds, and we 1 out of 7 out of 10. Our numbers are 1.2, 1.7, 1.3, 0.9. This we couldn't optimize. It was 1 second, even after a lot of optimizations. This was 2.1, 2.1. This was supremely complex. And then 4 to 4.1, we lost only in 1. So of course, the customer was very happy, and we gave them a good boost in terms of TCO as well as performance. So what was the quick outcome? We had 180 tables, which were migrated. 80 of them were distributed worker nodes. 80% of the queries were dropping with no modification. 18%, of course, it required some syntax changes because we had to move from text to JSON-B conversion. And 2% of the queries also were, hyperscale Citus related. They needed some basic updates, left joins, and that will basically understand in key learnings. There was another aspect to this POC. This POC, which we had done the pilot for the customer, had 2 aspects. One was the database optimization. The other one was Databricks optimization. We don't have time today to get into this, but this was a POC in its own. We moved the Databricks, all the clusters from running on EC2 to Azure Databricks, and saw massive performance boost. Again, because it's a PaaS and not an IaaS. Key learnings, about top 10 key learnings along with engineering. I've just represented the top 6 of them. So if you're working on use cases like these, please do take note of these. So small tables can be made reference, but we need to ensure that we don't have a reference table, which is a subquery to just reference tables to the left side. Because if it's the left side of the left join, it will basically give a query error out. If shard count for a table is low, then scaling the reads on reference tables can be done by kind of enabling the round robin replacement policy. We figured that out. Again, very important, JSON strings. It has great support, so definitely go instead of JSON with or text with JSON-B because it compresses the string for more efficient reads. Very, very, very important point is the 5th point, and this is something which I'll quickly show, is the output of the materialized views created on the distributed tables cannot be joined to other distributed tables, and the views will be on a coordinated node, right? In such a case, you need to basically build rollups. So rollups will then perform faster, and gives you, massive performance boost. And the recommended way again of distributing tables around ID columns But however, if the distribution is on other columns such as date, the specific shard for the distribution will be only used for equal to. In any case, the range queries for the distribution column, then all the shards will be called. So these were some of the subset of more number of learnings that we got, and of course it was shared with multiple teams internally and externally, and we were very fortunate to have a fantastic partner working with us on this implementation along with the engineering team. Now, quickly going to what the configuration looked like. It was a 2-worker node, and I'll quickly show this in the portal. And from the Azure portal, it's very easy to basically drag and drop your worker nodes. Azure has made it very simple to manage CITES, no cluster management on your site. You also have a shard rebalancer button, which you click post any optimizations that you make. So the customer architecture was very similar to this, with marketing data, sales data, and a lot of LOB apps data coming in. The prominent data was the clickstream data. So we had the CITES sitting in between. And then, of course, we had some of the invoice generation, and the producer notebooks were all Python notebooks in Azure Databricks. And the customer currently is in the process of moving to Power BI, but they were using also, again, a Postgre compatible, let's call it, queries built in a visualization tool called Metabase. So this also played a very vital role, because when we moved Redshift to CITES, many of the queries, there are over 800 queries, I think, which did not need much of a modification. So those were some of the very important design kind of architecture and principles. Now, quickly to go to a demo, I believe we have some time. Yes. So what I will do is I will quickly go to the portal. So can you see my portal? I believe, I hope. So basically, you see like in the Azure portal, you have a resource group, and I have an Azure database for PostgreSQL. It's called a server group. That's basically the name of the cluster. And within the cluster, as you can see, right, I have one coordinator node. That's what we speak to, and the application speaks to, but you have multiple worker nodes in it. So for the demo purpose, I have created 2 worker nodes, and Azure makes it very easy for you to scale up. So basically, you got a basic tier and a standard tier. You should use this for dev test, and mainly this for production standard. And if you want to scale it up, let's say 7 nodes, and you want to scale it up to 8 vCores, and let's say storage to 2 terabytes, and also do the same on the basically the coordinator node, let's say, and you want to scale this up. And all you need to do, let's say I want to scale this up to 8. All you need to do is basically click on this save button. It also gives you a full price summary, so that you don't get shocks and you are aware of what the cost implications are for your particular use case. And once you have done this, basically clicked on save. I'll not do that right now. All you need to go to is basically the shard rebalancer, and just click on this. It tells you that rebalancing is not recommended at this time if you have made no changes. If it does, it tells you just click on a button and kind of check on the different execution plans, and it kind of balances the data across the group of worker nodes, or what we call the data nodes. So this has made it very simple to work on. So for this particular use case, what we will do is we will quickly look at one of the very similar use cases. Here we will kind of ingest data coming from traffic data from a web analytics software. You can think of exactly the same clickstream data pattern that we saw for our specific use case. And then how do you kind of ingest it? How do you build a real-time dashboard, and how do you do modifications around it using the different parameters which are available to Postgres is the key question here. So what I have here is, as you can see, basically 3 tables. HTTP request. So this is basically, it consumes all the raw web traffic data. You have a 1 min table, which will hold out per minute aggregates. It could be like, if you want to store, you can store for 5 minutes, 10 minutes, but usually 1 minute is the most near real time, right? And then we have a latest rollup table that kind of maintains the position of our last rollup. So rollups give you the ability to kind of do things very similar to materialized views, but it has a lot of other functionality which it's really good at performance vis-a-vis. So let's quickly look at the structure of the table, so that we are clear on what the different columns are. So, and that's where the data choice and the decision of your distribution column will come in. So as you see, the site ID will play a vital role, because we want to do in this particular use case, web traffic analysis. But then the question comes up is across what IDs? So which specific stations do you want to do that across, right? So, and then you have ingest time, you have an URL which you can store as a text. But again, in real time, it's good if you store this as a JSON or a JSON-B, as I showed earlier. Then you have other fields like IP address and status node and so on. If I do one min, it's basically will have, again, site ID, which as you can see is common. It ingests times, and then, success count, request count, because it holds the permanent aggregates for me. And we have created also a B-tree index on top of it called, one min IDX. And post that, let's take a look at the latest roll up. So that basically has a timestamp with the time zone, because we will do the pull or the call of this roll up and associated with a function, so that we get just the latest update for the roll ups. So an important point to note here is if I do a DT, and though I have created these 4 tables, if I leave out right now reviews and I talk about these 3 tables, though I have created them on a citus coordinator node, so are these then distributed tables in nature? The answer to this question is no, they are not distributed tables, but they are single node tables as of yet. But as I mentioned, citus gives you the ability to kind of create distributed tables and then shard rows on different nodes. So how do you do that? So we basically run basically a function called create distributed table on one of the tables along with a distributed column. So select, and then you put the name of the table. And this is probably, again, the most important design choice. For your use case, you need to define for the specific calls that you will make, that what will make the best distribution column or the shard key, so that data is perfectly kind of balanced as well.
Hi, Subhasis. Sorry to
Yes,
interrupt.
please.
We have last 3 minutes.
Okay, yes, absolutely. So basically, you then create these distributed tables, and then just to kind of move on, so that in the interest of time, we can quickly finish this. So all you need to do then basically is create a function which kind of sends data to us. So what this function does is basically it sends data to us, and sends like approximately 8 records per second. So it inserts these records right into the specific table in the distribution column that we have mentioned. And then we basically do a query to kind of find out the web requests per minute. And then as you can see, so this query works perfectly fine, but as more data will come up, right, that is where it will then start, lagging. So that's where fundamentally the concept of, roll-ups come in, and you can create a roll-up using a function. So here what I have done is basically I've created the function, and all you need to then do is basically pull this, select and create this function. Post that, once you have created this, all you need to do basically is then, once the data all is in the aggregated form, we call that particular function. That is basically it triggers the roll up for me. So as you can see, so this is then the output of the roll up. And then of course I can put this on a cron and then can, run it for maybe 5 minutes or 1 minute or 30 minutes, intervals. So that's how, and then of course you can expire the old roll-ups and you can get a much better, real-time performance. And then if you put this on a cron job, you can wrap up these queries, in a function as well. So this is how you kind of use the, all the added functionalities of, JSON, JSON-B, and specifically roll-ups to do real-time aggregates on data, which is coming in with lots of functionality. So do check out, and this brings me kind of an end to our session as well. And, kind of, thank you to the title sponsors, and I'll hand it back to the moderator because I'm done here. So this is kind of the end to my session.
Thanks, Subhasis. Thanks for the session. It was nice and a very informative session. And
Yeah,
let's
thank you
wait
so
for
much.
one. Yeah, welcome.
Till then,
Let's wait for 1 more minute. Yeah, for any questions. So far, we don't have any questions. Let's wait
no
1 more minute.
worries. Absolutely. And I have given my email ID. If somebody does want to reach out or try out Cypress, please do. If you have real-time use cases, it will be worth, your effort as well.
Okay. Thanks, Subhasis.
Thank you so
I'll
much
move to
then.
the next. Yeah, welcome.
Absolutely, absolutely. Thank you so much. It was a pleasure. Bye.
Hi, welcome, Ms. Matthias. Coach for the next session is going to talk about developing and deploying a static Blazor web app with Azure Functions backend. Hi, hi, Matthias.
Hello, Rajesh. Hi.
Uh, it's all set. Stage is yours.
All right, thanks. Just one note for you. Please let me know if my mic goes crazy, then because it happened in the past a couple of times.
No,
Okay, let me share my
it,
screen.
it looks good now. If there is
Yeah.
anything, I'll interrupt.
Okay.
Yes, please share your screen.
Okay. Screen sharing incoming should be there.
Yes, I have put it in a presentation mode. Yes, you can. It's all yours.
Okay. All right, then let's start. As already said, I will today talk about, well, first, welcome everyone. I will today talk about developing and deploying a static Blazor web app with Azure Functions backend. That's the longest title I've ever submitted to a conference. It's basically all around my journey with static web apps in general. I will give the disclaimer here that until a few weeks ago, I haven't touched anything with Azure services at all. But I kind of got into Azure Functions for a new project that I've worked on. And then also kind of static web apps caught my eye, and I just digged into it. And in the end, I thought it might be interesting to actually create a talk from that. And this will be what you see now. All right. So first of all, if you haven't heard anything about static web apps, then you might ask, okay, what are these really, right? There are a couple of really cool things about it, but let's start with the most basic ones. First, as the name already suggests, we will be hosting static content. Yeah, everything like JavaScript files, images, HTML files, all the assets that we might need. And that is particularly great because it removes these restrictions from where it's hosted. It's hosted globally in a very distributed way, which makes it fast to be delivered. But also, and this could be a bit misleading at first, this is not just static. We also have an integrated API support in the form of Azure Functions, which can help to make the website more dynamic. Yeah, integrate services, provide dynamic content in the generally static web app. Also, the service on its own comes with GitHub and Azure DevOps integration. So usually you just commit something to a repository, it will be automatically picked up and then be deployed to your website. We have free SSL certificates. It's not something that I actually looked in, but I know it exists. We can also create custom domains, because usually the URLs that we get out of the box are not exactly user-friendly. We also have a seamless security model, which means that on both sides, the front end and the back end, we can make sure that a user is authenticated if we happen to have content that needs authentication and authorization. And that also comes with different authentication providers like GitHub. There are 5 in total. There's GitHub, Facebook, Google, Twitter, and Azure Active Directory. Yeah? So it's something that we don't need to take care anymore, having it integrated automatically through the service. And also very important, we can have staging versions, which means that once we want to make a change, we don't have to apply it to the production website, let's say, but we can first test it on a separate website, even with separate authorization rules and stuff like that. So this comes basically also as a unit, the front end and back end code being able to be deployed onto staging environments. One thing that I won't talk today, but something that you probably will see in other presentations about static web apps, is the GitHub and Azure DevOps integration. And it will be more clear why I actually exclude that, but I'm replacing it for the sake of having more flexibility and kind of get in sync with the great development experience that the front end and back end code can come with. Okay, so talking about front end choices, and there's just a lot. Yeah, until very recently, I haven't used a single one of those. But there is we can use Angular, we can use Vue, Svelte. I hope I pronounced that correctly. React or Blazor, what we're going to use today. But you can make use pretty much of any static framework or JavaScript framework that you could think of. Also, stuff like Hugo or Gatsby or Next.js. I'll be honest, I just extracted it from a list, so I have no idea how exactly those are used. But there's just an enormous amount of flexibility. We will stick with Blazor for today. And just to introduce Blazor also to you, for those who don't or who haven't looked into it yet, Blazor allows us to write our websites, our static content with C# and .NET. So we have the full power of .NET on WebAssembly. Yeah, which means we can make use of types like HTTP client, for instance. We could also, there's actually 2 sides of Blazor, which is first what we're going to talk about today, the Blazor on WebAssembly, but also the Blazor on with server side. So in that case, you actually still have to have a normal web app, which is hosted with server backend. But yeah, otherwise it runs on WebAssembly, which is built on an open web standard. It also allows us to interop with JavaScript if you happen to use something that is provided as JavaScript libraries. Also, not something that I will dive in today. And last but not least, it's a great development experience. Like I said, I haven't done anything web related before, but this is really, it's as a C# developer, you feel home immediately. You have your debugging tools. You can refactor and all of that, and that's something that I want to look at with you now. So I have prepared here my solution, static web apps demo, and here I have my project for the static web app. And so this is very similar to normal web apps, that you have a main entry point where you can configure a couple of services, like for instance the HTTP client, which later we will use to access the functions backend. And we also have a couple of files here, like, and I want to start with the list razor file, because this is very interesting. Way ago, when I had when I was implementing web stuff, which was enormously late in the past, but we can, this is going to be a to-do list. Yeah, we have an input. I will also show it to you later. We have an input here, where we can enter a new thing, which should then be added to a list. And this is really comfortable because we can just bind to an instance field here. This is the new item value string, which is bound from here. And then we can also attach or kind of subscribe to events like on key up, for instance. And then in the on key up, we can check, for instance, for the enter key being pressed. And then we just add to a list of strings. And that will automatically be re-rendered then. Whatever we've added, it will re-render this part here and then show the item. Even more interesting, from here, we can then also subscribe to the on-click event and actually remove the item again. And this is really, you see it, it's really just a Lambda function. And this is just a great experience as a .NET developer doing web development. Okay, now what I want to show you is let's just run this actually, and I will already debug this this Blazor app just to show you also the experience with the debugger. Okay, so this will take a moment probably, and I will say I need to check. I will probably jump a bit between browsers, but right now we should be using Chrome. Okay, there's Chrome loading our app. Still takes a moment. Screen sharing is hard on my machine. Okay, and now we can just go here. We have the to-do list, for instance, and first item, you see it. I can have the second item, and then by clicking on it, it will be removed. Now I also have the standard. If you've ever tried one of the templates, then you know about this counter. We can actually click that counter, and it will stop in the debugger to let us step through, for instance, and continue, of course. But I can also, if I have this fetch data, for instance, I can actually also see here we use the HTTP client to load a JSON file. I can actually inspect those forecasts that I retrieved and look into them and see what I actually received. So in terms of debugging, and again, refactorings, I won't do any refactorings, but this is great. You have all the power of your IDE basically ready at your fingertips. Also, and this is something that currently doesn't work yet, but we can also do .NET Watch Run, of course. This would also load the whole thing. And let's wait for a moment. If you've heard about the hot reload debacle that happened recently, so very great that we can actually keep that. And I hope that at some point we will also have this in Rider in particular, what I'm actually using. So let me minimize that for a moment here. Okay, real estate is really difficult when doing presentations. Okay, so I can, for instance, go to my to-do list, and let's just go back here, and I could, let's say, make a quick change, save it, and you see this will be re-triggering the compilation, and after a moment, I should actually also see, yeah, it's reloading, and I get to-do list here. Right. Okay, let's close this again. And this is not for you. This is, wait, now my presentation went away. Okay. Then, yeah, like I said, real estate is really difficult in these presentations. Okay, give it a moment. Okay, and also present again here. present. Okay, the second part I want to look at with you are the Azure functions, which will happen to be representing the backend. And the good thing about Azure functions is, first of all, serverless. So you don't have, you have less work to provide all the infrastructure. You can also flexibly scale those functions. So you don't, it's much less caring about that things actually scale out. Yeah, very basically said. But also, and yeah, I forgot, these also come in different flavors in terms of languages. So we will be using C# in this case, but I think there's also JavaScript and Python at least. But yeah, we will stick with C#. It also comes with a great programming model again. Like we have this model where we can have different triggers that will trigger our function. Those can be HTTP triggers, so whenever someone requests that endpoint, but we can also have timer triggers. We can have signal R triggers, which would update something on the running website. But beware, this is, as of now, I know that only HTTP triggers are supported with static web apps. But otherwise, again, we have this great development experience because, again, we are just in C#. We can debug our functions, even locally. And that's something I want to show you now. So the next part is about functions. Let's close this for a moment and also abort this here. So functions. So I have a second project in my solution, Static Web Apps API. And here I have a function. Or actually, let's start with the startup, because this is also for folks that haven't done any Azure functions before. What you should have, and just to give you a good idea where to start when you're dealing with services that are requiring API keys, for instance, because this is also something that you really want to put in your backend functions. You could put that in your front end, but that's not a good idea, right? But otherwise, you can load the config, which either happens to be locally, like in my case, these local settings. Here you can see I can provide an API key or a connection string. But in the portal, you can actually, of course, also provide configuration, then load these details here and also add services. Like in this case, I'm adding HTTP client, the factory actually, which would then create my function here and inject an HTTP client. Very important, if you haven't heard about that, HTTP client shouldn't be created just on demand with new HTTP client or something. Okay, but let's look at our function. So in this case, it's available through get and post. I have the request that I receive. I have the log. And all that I do here is connecting or trying to access an endpoint, quotes.rest, quotes of the day, checking the response if the status code is okay. I actually have to do this because this limits to, I think, 10 requests per hour. And then I can just, it's actually returning a JSON object as content. But since our backend API is just interesting in the particular quote, I just deserialize that, grab the quote, and return it as an OK object result. That's all. And now in Rider, this is actually really simple. I could go here and then say on the function, then say debug this function. Then it will first build the project, of course, and then use the, how's it called? Azure Functions Core Tools, I think. Sometimes I confuse the name, it should be right. Okay, then our our function gets loaded in a moment. Let's give it a moment. Okay, one more step is missing. Okay, now we can see the function is provided here under this endpoint. And of course, usually you could just click it here and see what it returns, right? But in Rider, you can actually use the integrated HTTP request or HTTP client, in the IDE, not the type in .NET. So here we can say trigger the get quote function. From here I can run it. And actually, let me just check if I have set the breakpoint here. Yes, I do. Oh, yes, I did. Now I can execute that. I can immediately step into my code here, debug that, and go through. Okay, this will take a moment when I have that here, but I could actually put a breakpoint there. Okay, and now we can also see here. Give it a moment. Quote is shown. It's ready, and now I can just continue. Okay. So let's also, no, we can leave the breakpoint, but also you should have seen the logging information here will be printed out there. And let's go back. This is something where we lost context actually, because if we wouldn't have been debugging, this would be the outcome of our HTTP request that we sent in our file here. So we can see here all the results. It's okay, content type, and the actual content of the response. We can actually also, that's very interesting, we can actually also compare different responses with each other, which can come in handy at times. Also, what I want to point out, this is something that I won't be using in my presentation, but Rider also comes with the Azure Toolkit plugin. So let's quickly check here. Azure Toolkit plugin, Azure Toolkit for Rider, and that brings some really great tools. Like for instance, this Explorer here, where we can, if I would click here, I would actually see all the services that I have created in my resource group or in my subscription, and also it comes with integration for Azure Write, which is a separate service. Let's say this one here that provides that serves as a storage emulator. So to have everything like queues and table storage, to have that locally and not having to set that up somewhere else. Yeah, you can also inspect queues and stuff like that. So that works very great. Also, I don't have a database currently linked, but you can also link your databases here, whatever you need in your functions. Like I currently use Azure SQL Database, of course, and then inspect tables, manipulate models, and stuff like that. So many things you can do there. Okay, but let's go back to the presentation here. What we want to do after, in the end, with these two things that I've just showed you, is combine them to a single static web app. Yeah, and the most important thing here, well, it's not a big deal actually, because we could just also host that separately and communicate with each other and stuff like that. But then we would miss one of the real benefits of that, and that is the authentication authorization part. So we really want to have good support to handle both of these. If you're interested in all the other images, visit http.cat, which is really a cool website. But talking more seriously about that, about authentication and authorization, we will start with the Blazor part, and that is in our Blazor app, we can just provide links to the /auth/login/provider endpoint. And this is actually handled from the service itself. So it's not something that we have to provide, but it's automatically provided. And here as the provider, we could just put in ADD for Azure Active Directory or GitHub, etc. I can actually, let's actually look into that. So I have here a page which says login providers, and you can see here I have a list of providers. Display name, this is the button ID, and endpoint here. Yeah, I guess it's clear. And then we just render a list of login buttons, basically. But let's go back. Something else we have to do to, in regards to the standard Blazor web app, is to add the Microsoft Azure Functions Authentication WebAssembly package, and also to add an extension for our builder with this, which is add static web apps authentication. So that looks that is here basically, and then we can use first of all that's more or less mandatory to make it work as a whole. We can use the cascading authentication state and authorization route view blocks in our app. So let's go here to our app. This is actually what I can actually show you the change that I did here. Show history out. So you should see down here. I surrounded that with the cascading authentication state block or component. And I also changed the basic route view to an authorized route view. So that is needed to make this work as a whole. But then we can also use the authorized view component with subcomponents authorized and not authorized as kind of blocks. Oh, sorry, that was not intended. So let's look at that. I constantly forget where this is, but it should be easy to find. So it's probably here. Yeah. So to decide whether we want to say hello to our user or to show the login button, we can just use this authorized view, but you can use it anywhere pretty much. And also we can use the authorized attribute for a whole page to say, to kind of have a top level decision whether this should be guarded through authorization or not. And we can actually also provide a role there. Okay, the other part is the authentication and authorization in Azure Functions. And for that, we have to parse the JWT, this token from the header, which automatically gets injected through the static web app service under the XMS client principal name. And from this information, we can actually create a claims principal instance, which we then can use to check whether the user is authenticated and whether they are in a certain role. And that is something that I also want to show you. So no, I don't want to move files. Let's go back to our get quote. So I actually before I removed that part for the authorization. So what I did here is to provide another binding for static web apps principal. And that is custom code, I have to say. So this is all in this binding here. I hope if you're interested, this is the suggested way, but I just tried to make it more nice. But I hope there at some point, since static web apps is still pretty much in early days, let's say, but I hope there will be something out of the box. But this attribute will make sure that the claims principal is correctly created. And also then let's revert this part here to the original. I can check if the principal is present or if it's not. Then also if it's authenticated. Can I actually merge that here? Whatever. Then return unauthorized result, or if the user is not in the admin role, then say it's forbidden for the user to request that API. Okay, so that's the part on the static on the API side, and then I also, of course, have the front end side. So here I have this quote razor page, which we haven't looked at yet, but we will do in a minute. And here, all you have to do is provide this attribute. Provide that attribute, say which role you're requesting, and if it's not in the role, it won't work. Okay, before we actually show that, I need to dive into something else, which is the static web app CLI. The static web CLI serves as a tool for local development, and it helps you to serve locally the static web app, the static content, but also the Azure Functions API, and more so to actually combine these into a single endpoint. Because usually Blazor is on port 5000, Azure Functions are on 7071. And also we need the authentication authorization part. So this .auth sub endpoint, which is emulated from the CLI here. And there's a whole bunch of more configuration. So I really recommend you to check out the website for this tool. But what we will do, what we will do is actually try just a basic example. And just to clarify that a bit more, I already mentioned it briefly. This CLI will make sure that all our requests from our browser are routed to the correct endpoint. So we are browsing with 4.2.80, and whenever we're requesting static content, it will be delivered to the Blazor front-end dev server, let's say. Auth requests will be routed to the emulator, and API requests will be routed to the Azure Functions core tools. More in detail for local development, I can really recommend you, because I initially had issues with that. I recommend you using Node in the version of in version 14. I had version 17 installed before, and it didn't work. The folks developing this or working on this said they will introduce that into their testing metrics. But yeah. As of now, I recommend version 14. Then you can just install that as an npm global tool. And what we need to execute to kind of make this work is SWA start. The first part is the Blazor endpoint. And the second part, through the API location parameter, is the Azure Functions endpoint. And afterwards, we can just open the browser, port 4280. And the reverse proxy that is basically represented from the Azure, from the static web app CLI, will route, as I already mentioned, auth requests to the emulator, API to the function, and everything else to the front-end dev server. Okay, this was too fast. This is something that I want to show you now. So what I have in Rider here is we've already used this run configuration for the static web apps API, but also for the static web apps app. Now what I have is a compound run configuration, which runs more run configurations in the background. So first, launching the front end part, launching the backend part, and also I have a configuration here which starts this exact static web apps static web apps CLI. Sorry. And just to briefly look into that, this is basically what I already mentioned in the slides. But let's go back to this compound run configuration. We can actually also debug that. And then you also see we have, for all of these three, we have debug tabs here, which will then run. And for our static web apps CLI, it should, let me see. I never know in which particular tab this will happen, but they are all loading up. Okay, let's check here. I guess it takes. Yeah, it's waiting for the functions API to be ready. I don't know what happened now. Let's give it a moment. Yeah, this is really, I mean, usually when I don't screen share and all that, then it's much faster. Also, my MacBook is quite old. But yeah, let's give it a moment. I think maybe Azure Functions. Okay, this is bad. So my notebook is too slow to actually. You see it couldn't connect to the to the functions API, because this is only ready by now. I will try to actually rerun this. Let's see if it works. I hope so. Because usually everything just works from clicking, and after 10 seconds it should be there. So yeah, but now it's there. We can see it's using both of these endpoints and combining them into one. This is something that is unfortunate for 280. This is something that unfortunately the run config doesn't do yet, but for 280. So let's navigate there. And you can also see here how the different requests are routed. And let's also just make sure that I still have the breakpoint here. Yes. Now I can serve my static web app fully emulated. So I also see now I'm not authorized. I can go here, have the counter, but now I can also actually log in. And of course, this is not talking to GitHub, but to the local emulation. So this is the side where I can just emulate how I'm logged in. So I can provide also the additional rules like the admin rule. I can log in. Now I'm redirected, and I'm authorized or logged in as Matt Koch. Now I can actually navigate to this quote API. And you can see, again, I can actually debug through this. So now I passed all the access checking. I could continue. And when I come back, hopefully, yeah, my quote actually appears. So this is secured on both sides, not just on the front end, because when we just check authorization on the front end, someone could still use the endpoint not using the website, but I'm also checking actually in the function. Okay, so let's close this again. I hope this is clear how this works. But let's stop it for now, and let's go back to the presentation here. So that I've shown you actually, and one small dive I want to do into unit testing. Just to have the full experience. Let's say what I said. This is very important to me to have good tooling around the daily development of that. So we will also look briefly into testing. So for the front end code, what I'm using is BUnit. So where is it? Let me see. BUnit is a test framework, particularly for Blazor components. And what I've done, I will only show you the derived type here. The test base I implemented myself, just to say I want to test the counter component, for instance. And then I can arrange stuff, like, for instance, I can say I want to add a test authorization. I can also say how I should be named. I can provide roles, of course. Then I do my act part of the test and say, for instance, click increment. And by the way, this is I just put some extension methods on top of that, just to have it more like BDD style, where there are not so many magic strings, but you can actually, extend just rendered component of counter to make this very accessible. And then we can click the increment button and check that the paragraph was increased to 1 actually. That we can execute just normally in our. Let's actually try this. I think it should still work, but you can just execute those tests from your IDE. Okay, and yeah, let's wait for a moment. I should usually also show you how it's failing, but in this instance, I will just stick with the passing. Like I said, just briefly. But also the Azure Functions part can be unit tested, and for that, I again have a base class test base here, which does some things like initializing an HTTP client, a static one, so that it can be reused. But we also have some helper methods to create requests, like from objects, which are then serialized, JSON serialized, and put into the body, but also to create requests with a query string and just passing a dictionary in this case. Now the actual test here, again, we have an arrange part where we can also create a principal, which is authenticated, but we can also, I think there's the empty principal who doesn't have any access rights. And in this case, I'm creating a query string. Then run, of course, the action and assert the result, which here I'm using Fluent assertions for. So I won't execute that right now. Okay, but back to the presentation. To the presentation here, the next part is, and that's the second part actually of the whole presentation, more or less, is the standard deployment. If you watch other talks about static web apps, although there are not so many talks yet because it's so newish, but if you look at the standard deployment of static web apps, then you will see something like this. Let me see where it is. Here. So you will start, usually you would start in your Azure portal and then create a static web app. You can provide the access, the resource group, of course, the name, free is always good, where it should be hosted. And you can choose to use GitHub for the integration and then also provide or sign in. And that will actually create a YAML workflow for you. Yeah, but you can also use other and it won't create anything. Now let's stick for a moment with the generated workflow. And I want to show you that in briefly. If you go the route of using GitHub here, then this file is created automatically, which is just boilerplate code, right? And what it will make sure is that on every commit to the main branch or to a pull request, this site gets built and deployed. It will also automatically provide this one secret here, which is, I don't know, kind of also generated the name and injected so that GitHub Actions actually can push to Azure, to the Azure services. But yeah, how that looks is like here. Like I took lots of inspiration from Frank. I hope I pronounced the name correctly. Bouger. I don't speak French. I'm sorry. But whenever you commit something, then the Azure Actions the Azure action will also create a comment and let you know where you can see this particular pull request in action. Okay. So, and yeah, now I need to go back to my presentation here. And after this has been deployed, for the environment and staging area, it looks like this. So main branch is our main site where we can navigate. But for the pull request, we have something like, and this is just from playing around with it, but we can have a title and a branch here as well, and then have a link to the actual website. Also, what we can do from the Azure portal is to add users. Like I did with the emulator, I can invite a user and then also give it, depending what we can provide the authentication provider, but then also say that it should only be valid for a staging environment, for instance. So you have that separate as well. And we can also define roles, as comma separated list. And usually this is the way that is suggested, but I'm here taking a different route using a tool called Nuke, which I'm actually the maintainer of. I've implemented, or I've been working on that in my, it's a pet project. I've been working on that for roughly 4 years already. And usually it has nothing to do with Azure or static web apps, but it's a general C# make tool where you can implement certain targets, just like steps in GitHub Actions, but in a C# way. Yeah. And it also comes because of that, because it's C# and because it's actually a console application, it also has a nice development experience. You can debug, you can refactor everything that you want. And it also comes with a powerful programming model. So that is, for instance, to load secrets automatically, to invoke CLI tools very conveniently, to kind of build dependencies between targets. And one more thing, I can have a single presentation actually from that. It's also very scalable. So usually when you copy YAML files around, for instance, and just change minor things, in Nuke, you can actually reuse that in a way that uses NuGet packages, or you can create a global tool from it to build all your different projects in the same way, in a consistent way, where every project uses the latest up-to-date version of the build. Okay, and that was too fast. And now I want to show you exactly that part of the deployment. So I want to start with the actual deployment, just to point out a couple of benefits here. So first, and let's not to distract you, but I have a target called deploy. This is actually a property. It looks a bit fancy, this part, but I can guarantee you after a while you don't really notice that. It's just to have a fluent API to kind of create this target. But we have a deploy target, which requires that either we have a API token provided, like here, which is also a parameter and a secret, or it's a local build. Yeah, and we also, depending on tests, which I will look at a bit later. But now with this information, we can actually call Docker run and set the image, for instance. This is actually also used by the GitHub Actions that I've shown you in the YAML file, just under the hood, basically. But here you have it more in a followable, in a way that you can follow. Because just looking at the action, let's do it actually. You don't really know what happens here. You know, it's using this particular action, but who knows what actually happens, right? Okay, but let's go back here. I'm also setting a volume, and I can then use this static sites client that is part of the Docker image to manipulate the invocation. So I can say I want to upload. I'm setting the API token to either the API token, which is provided, or I can get it through the Azure CLI. So in this case, I can do it like this. I'm calling the Azure CLI static web app secrets list, then the name of my static web app, and then parsing the output and just grabbing the API key. So you don't have to have this locally, but through this Azure CLI, you can also do the authentication, all that. So this works seamlessly. And a couple of other parameters. But then also, let's look here. This is the part that really interests me, you know, because I also can do testing as part of my pipeline, which then calls, this does nothing more than calling .NET test and putting the test results somewhere. Now you could say this is not difficult to add to the YAML file, right? But this is, again, in a scalable way. Because what it does, it grabs all the different test projects, you might have more, and invokes the .NET test method on that. Even more so, besides this test target, we could also have a different one, which generates content from some other source, let's say, which should be part of our deployment. Yeah. So this is about having flexibility and having C# at your fingertips. One more thing that I've added here is an invite target, and that is not something like test and deploy. Those are targets that we want to execute that we want to execute on our in our CI environment. And that's also a factor. We can use this pipeline actually also on other CI services like Azure, like AppWare or TeamCity or GitLab. Yeah. your choice. With the YAML, you can't, but with this, you can. And yeah, let's go back to this invite target. This is not for executing on the CI server, but for local development, because what I can do is using, again, Azure CLI to invite a user to my static web app. And this is the name of the static web app. I can choose the provider, set the roles, the user. I can get the domain, and I could, this domain reflects what I've shown earlier with having staging environments and the main environment. So you can also extend that to actually be respective of the, or be aware of the environment you're deploying to. And then this result is just parsed to the invitation link, and we actually will also copy that. I will show you in a moment how this works. Okay, and yeah, that's it pretty much. Okay, we can of course also create the static web app from here. So then we just need to provide a name, and it will create that using an ARM template from here, which I copied earlier. So you can see I have two parameters here, name and location. And yeah, this is how you can manage everything from a single point, from your IDE locally, without going to the Azure portal, without necessarily having to commit, because you could also just name your environments according to and say, this is my local environment, let's say. And then instead of let's go back here for a moment. If you look at that, what they had here, then you see this -7. This is just the pull request number, and instead of the pull request number, we could just say staging. And then you also don't have to navigate to the pull request or even create the pull request, but you can just execute it locally or on your CI server and then navigate to a page that you already know. Okay. Okay. So this works frictionless, let's say. You can also have a bunch of configuration here in a file called parameters.json, which has the name, which has the default provider, the resource group, etc. Okay. Now, I think we won't have time to actually wait for the build to run through, but I committed that before already, and I just want to shortly look with you on the log output here. So and one thing I forgot. Of course, in the end, we need a GitHub GitHub Actions YAML workflow. And this is pretty easy. You can just add an attribute here for GitHub Actions, and similar attributes also exist for other CI services. We can define where it should run, all in a very typed way. So there's no indentation issues, or that you write the image incorrectly with a typo. We can say when it should be triggered. In this case, it's just on push. And we can say which target should be invoked and what secrets should be imported. And this attribute here causes Nuke to actually generate the workflow file. So this is auto-generated, and this is all done for us. Yeah, it even includes some caching. This is actually something I also want to look into later, to maybe also cache the Docker images, let's say, to speed up things a little. But yeah, generally this is really helpful to get going, and this also allows you to easily switch to another CI service. But now let's go back to our log output here. You have to ignore a couple of those warnings. This is some parts of those I just discovered while doing this during this week, and I didn't have time to actually fix it. But we have the test target, which was executed and says here passed 1 in one assembly, and there should be another one passed 1 test in the other assembly. And I also have my deploy target here. So this takes the secret, of course, runs Docker, and this will actually then deploy to my website. Not sure. Yeah, it's actually also here, my website. So let's load it. Again, I can see, and this is this is currently the deployed version of that misses the attribute on the front end side. That is why I can actually navigate here, but you see the backend part does the authorization and authentication still for me. So that is why I receive an error, right? So if I would add the attribute, then of course I would see the not authorized part as locally before. But yeah, just to illustrate that also quickly. Now I can log in with GitHub, but before I do that, what I need is an invitation, right? And for the invitation, I can just like I said before, I can call invite. I can say my user handle. I can set the roles to say it's admin, and provider should be GitHub. Okay. Now my build runs locally, or one target at least of that of my deployment infrastructure, deployment and management infrastructure would be more correct, I guess. And the first part is just to get the domain, because this is not something we want to enter somewhere, because it's just it's pretty much how to say, boilerplate and obscure. But from there, it will automatically parse the invitation URL. So I have that in my clipboard already. I can now go here, pass it in here.
Hi, Mathis. Sorry to interrupt. Last 5 minutes.
Yeah, I know. 5 minutes. It's fine. Use my login here. Now I'm logged in again on my website, and now this quote should actually appear. It appeared, and that's the story of developing, deploying, and managing the static web app. To close this whole thing, just a couple of conclusions for me. At least the first part is for me. So I think static web apps in Azure are really cool servers that is easy to work with, that you can easily build management tools around also. So Azure CLI works great and all of that. It's fast and scalable. Fast because it's globally distributed. Scalable because Azure takes care, according to our parameters that we set, how this should scale out. Yeah, we won't have issues with that. Front end and back end are served as a unit. Yeah. Usually with Azure Functions, you would have to swap and stuff like that. Here, it happens atomically, more or less. We have integrated authentication providers that make it easy to put certain services behind authorization checking and authentication. We have integrated role management to provide access only to those who should access certain endpoints. And overall, it's a great development experience. I think also with Nuke, not having to go to the portal to just add a user or something, to have the link automatically copied, to when you create a new website that you can just call create and provide the name. Those are all great things, I think. And that's pretty much it. I think we have 2 minutes left. But if there are any questions, then please let me know. I'm very happy that you watched it. And
yeah, yes, Matthias. Thanks for the nice session, and it's very informative. And yes, obviously we'll go and try static web apps with Azure Functions as a backend. And we don't have a questions, but there is one comment saying, can we have this repo in the source with this source?
Yeah, I didn't manage to provide that in time, but I would suggest follow me on Twitter, and I will put it out in the coming days. Currently, initially I just had it as a private repo, but I can make it public, of course. That's also the idea. but yeah, please follow up or send me a mail or something. You will find something, I guess, and then I can share that.
Thanks, Matthias.
Okay, thank you too for the invitation. And everyone else have a good rest of the conference.
Okay, thank you. Bye.
Bye.
Okay, we have next session. It's the time for next session. Um, this is integrating Power Apps on Automate with Azure Functions Open API in one mouse click. As I welcome Justin you for this topic. Hi, Justin.
Hello, how are you?
Yeah, I'm good. How are you?
Yeah, I'm good. I'm good. Thanks for asking.
Yep. The stage is yours.
Sure. So, shall I start now?
Yes, please.
Okay. Right. So let's start. So, all right. The first of all, thanks to our sponsors. Right. So
Yes.
I'm ready to share my screen.
Yes, please.
Yeah. So could
Yeah.
you share my screen? Yeah.
Yes.
Yep. So yeah, first of all, thanks to sponsors for this amazing event. So without those sponsors, this event wouldn't be happening smoothly. So hello everyone. Today I'm going to show you how to integrate as a functions application with Power Platform through a custom connector. So it's really easy using the OpenAPI extension. So trust me, it's gonna be really easy. So I'm Justin from Microsoft as a senior cloud advocate. So here's my Twitter handle. So if you follow me on Twitter, and you will see a bunch of dead jokes, Azure related stuff, and so forth. So all right, so we have only 30 minutes. So throughout this time, I'm going to show you how to activate the OpenAPI capability on your existing Azure Functions application. Then I'm going to show you how to create a custom connector with this as a Functions app with just one mouse click. Yeah, actually, so let's see how this is really one mouse click or not. And the next time, I'm also going to show you how to make a Power App with custom connector to directly communicate with your backend API. And finally, I'm going to show you how to simplify the complex data handling workflow with the custom connector within the Power Automate workflow. So throughout this time, I will try to minimize the slides, but mostly show demos for you. So let's see how it's going. So, oops. Yep, the first things first. So let me show you how to activate the OpenAPI capability to your existing Azure Functions application. So in order to do so, you will need to see this extension. So visit this URL, aka.ms/azfunc-openapi. Or if you have a mobile device and just just take a photo on your QR code here, and you will be able to see the website. Actually, when you click that link or visit the QR code, then you will be redirected into this GitHub repository, so which is called Azure Functions OpenAPI extension. All right. So we are going to use this OpenAPI extension. And this is currently preview, and it's going to be released as a GA soon, after .NET 6 the release. So let me show you how to activate this OpenAPI feature on your Azure Functions application. So this is the Azure Functions application, and I created the Azure Functions application for you. And this is nothing fancy. I just created the function app, basic function app for you. Then if I run this application, and that will show you about one endpoint, which is the local host and function one, right? This is the main thing. So nothing fancy, right? And here, so I will stop it. I will stop the application. Then if I add a NuGet package called Microsoft Azure Azure Web Jobs and OpenAPI extension, and it doesn't show up because I didn't take the pre-release version, because it's currently preview. As I said, it's going to be released GA soon, and it's currently support both support .NET Core 3.1, .NET 5, and .NET 6. So based on whatever your preference is, you can use this extension within any version of .NET framework. So the latest version of this extension is not 0.0.0. So I just install it. And so once I install and see how it's going. So I just install it and finish it. Then I will build this application again. So build has finished here. Then run this application again. Then it will show some differences. See this the endpoint here. So I used to have only one endpoint, this one. But only after installing this extension, I have 4 more different endpoints. And one of them is calling the Swagger UI. So I'm going to call this Swagger UI on the web browser. So I will put this one. Then it will show you the Swagger UI. But as you can see, nothing here because we didn't do anything but installing this extension. So I am adding some more features here. So I will add a few lines of code into this function app. So I copy this one and put these lines of code. And then, so this is all about the OpenAPI decorators. So with these decorators, and you will be able to make this application appearing on the Swagger UI, right? So I will save it. Then rebuild this solution again. Then I'll run this application on my local machine. So run this app again. Then everything is fine. If I refresh this application, this web page, Swagger UI, then you will be able to see this one, right? And here, so I just simply try this out and put the name as dev. Then execute it, and it just returns the hello as conf dev, blah blah blah. So this as a functions working really fine, and with this Swagger UI OpenAPI capability. So if I click this swagger.json file, and it definitely shows the Swagger OpenAPI version 2, then as a default. But if I want to see a different version, so such as version 3 or something, then change it OpenAPI/version 3, then it will display the version 3 here. So the OpenAPI spec, the latest OpenAPI spec is 3.1.0, but this application, this extension, uses the 3.0.1 because it has a dependency to the OpenAPI.NET NuGet package. And if you really want to see different format like YAML, then you will be able to see that, right? So everything you want to use the OpenAPI from the Azure Functions application, you just simply install this extension and use it. So this is how you can enable or activate the OpenAPI capability into your existing Azure Functions application, right? So now we have got the function application with OpenAPI enabled. So next one, let's create a custom connector directly from the Azure Functions. So when you are going to create the custom connector, there are a bunch of options. You can create a custom connector directly from the scratch, or you can create a custom connector from API management, or sometimes you can create a custom connector from the OpenAPI file or URL. But we have already the OpenAPI file, or we have already OpenAPI URL. So that's that's really easy for us. So custom connector currently uses only OpenAPI version 2, which is known as Swagger. But I hope that the version 3 support will be coming up soon. But I can't say when it's available, but I'm sure it's gonna be coming soon. So there are two ways of using the OpenAPI to create a custom connector. So if you have only OpenAPI document or file, then go for it. But if you can access to the OpenAPI document through the URL, then I would go for this way because it's way easier. So you don't have to ask somebody to give you the OpenAPI file, right? So yeah, only you need is the OpenAPI URL. So this screen actually shows how to import OpenAPI document URL and generate a custom connector from it. All right. So let's build a custom connector directly from the Azure Functions application. So I have already deployed Azure Functions instance onto Azure, which offers this OpenAPI capability, right? So I have a browser. Then I have the Swagger UI here. I have a Swagger UI here, and it shows you about the logistics API. So the Power Platform offers the hundreds of connectors for you, but within your the business, within your organization or within your business, your business specific API, Microsoft doesn't provide it. So in that case, you have to create our own custom connector. Then this the OpenAPI document is basically that's for that. All right. So I have logistics API for for a certain business. Then if I have clicked the Swagger UI, it as a default it shows the OpenAPI version 3. Now I need to change it to version 2. So OpenAPI version 2. This is what I need. So I copy this URL. Then I have the Power Apps portal. So I open the Power Apps portal. Then I can create a custom connector. And there are a bunch of options here. And then I choose import on OpenAPI from URL. So let's see. So this is the logistics one. So logistics, the custom connector. Then paste the OpenAPI document URL and import it. That's it. And continue. So see how it's going. So it's just created. And everything is there. Everything is there. Everything is there. So I can just simply create a custom connector here. And the custom connector will be created for me. And what did I do? I just import the OpenAPI URL and create a custom connector. So how many the mouse clicks did I use? 2 or 3? Yeah. So 1, 2, or 3. That's it. So we just created the custom connector. It's really easy for you. So I need to now I need to test this custom connector, whether it is working or not. So I just go into the test one. And then there is no connection yet. So I'm going to create it. And it asks me to provide the API key. So I have an API key. It says this one. So I have an API key. Then create a connection. And it creates connection here, logistics one. So let's go back to the custom connector and test it again. Here, I created a custom connector here and go to edit button and click the test again. And I can see the connection now. So there is only one thing, the put the logistics queue. So I need to provide the JSON, the payload. So where is the JSON payload here? So there is a JSON payload, this one. So you can see some weird characters, which is Korean. So, but that doesn't really matter. So I just copy this one, and here I put here. Then it will. So if it returns 200 status code, then that should be working fine. Then yeah, it returns status code of 200, and it returns body with the message. So it creates a queue for the delivery. So the custom connector works really fine. And what did I do? I just import the OpenAPI document URL and create a custom connector. That's all about it. So we have now custom connector. So let's move on to the next one. So we have a custom connector. So what should we do with this custom connector? So we are using the Power Platform, and this demo is all about the Power Apps scenario. So I am directly communicating with the backend API through a custom connector within Power Apps. But make sure that the API call should be used only for the synchronous call, because if it takes time, it takes a longer time than you're expecting, then if you call that API, you have to wait. I mean, the Power Apps has to wait until that request is finished. But otherwise, you have to wait until that's finished. Regardless, it takes 1 minute or 2 minutes whatsoever. So if your API takes time to complete, it's not recommended to use the direct the custom connector call from the Power Apps. So in that case, I would recommend use the Power Automate Workflow, because Power Automate Workflow is really good for the asynchronous API call. So I will take care of this later. So what does that mean? So this is the Power Apps, the canvas here. So I just simply use face recognizer. So I'm going to use face detection API and use this custom connector called face recognizer to to detect my face, which is identified as myself or which is not identified as me, right? So let's use the face detection API for Power Apps. So hang on. So okay. So I have the Power Apps here. So I have Power Apps here. I don't have face recognition, the custom connector yet. So I'm going to choose the data and add data here. There are a bunch of connectors here that I already created the face recognizer custom connector for me for this the demo. So I just simply import that face recognizer into the Power Apps, and it's the edit here, right? Now, hang on. Now we have the face recognizer. Then I need to add button here, and this is the button. Then in this button, this is I choose on select here. Then what I should do is I put the command here, and the face I need to the call. I need to execute, invoke the face recognizer, the custom connector within this on select function. So I'm adding this formula to here. I'm adding this formula, then see how it's going. So I added this formula, and I will choose my camera here. So you are seeing my my face on the Power App as well. Now I'm going to click the button here, and then see how it's going. Then it says, so see, this is waiting. It takes time. It takes time. That's why I wouldn't say this is a recommended way. Then see how it's going. So I'm waiting until that's finished, and it says, okay, my face has been identified with the accuracy of 85%, right? So if I say something, the weird, the ugly face or something like that, then the face will not be identified anyway. So this is how it's going. How the face detection API is directly communicated with the with Power Apps, right? But as you said, as you were able to see, it took some time, and which is not recommended because it just the 5 second or 10 second. But if it takes time, like 1 minute or 2 minutes, and this kind of direct communication between Power Apps and the backend API wouldn't be the ideal. In that case, we need to use a different approach, right? So I finished the Power Apps demo using a custom connector to directly call a face detection API. Now, so calling an API through a custom connector is not just send and receive the data from one system to another, just like a previous example. It can be used for other purposes, such something like the data handling. So this is really good for the Power Automated scenarios. So what I'm trying to say is, with a Power Automated workflow scenarios, sometimes you need to manipulate or convert a data from one format to the other. In that case, sometimes you might need to add the more than one actions to get this done, right? But sometimes it's tedious. Sometimes it's really complicating. But if you introduce if you introduce custom connector, then you will be significantly reduce the number of actions, right? So I'm going to give a very interesting example. So this is the real world example. I am running event in South Korea, and we are using the Korean language, but we use the Microsoft Forms, and Forms doesn't know that language. The user input enter their name, but the form doesn't know this is written in English or this is written in Korean. So even if I am asking the participant register in the registration form, please use in Korean to enter your name. But sometimes we never know what are the user behaviors. So sometimes they use their put their name in Korean, but some people use the English name. Or if that event is an international event, then we have to consider both names in English, either in English or Korean. So in that case, we have to get the first name and surname, and we are expecting if that's an English name, then we are expecting the Justin space U, right? But if it is written in Korean, it should be U Justin without space. So this kind of the logic should be done. So if we handle this kind of data, usually on the left hand side we have to involve such kind of number of actions to get the result. But if we introduce the custom connector like this, then we only need one action, right? So this is what the really beneficial to use the custom connector for this kind of data manipulation. So I'm going to show you a quick demo here. Oops. I'm going to show you a quick demo here. So I have Power Automate workflow here. So if probably I need to, yeah. So I have 1, 2, 3, 4, 5, 6, and 7. Actually, 8 actions to get the name. So if I put a name here, say Ali Abdul from the Squid Game. So then it will return. It should be returning 6 seconds ago. So it should be returning Ali Abdul, right? But if I put another name, so I'm using in Korean now, Ali Abdul. So this is Korean. Then what should I expect? So it should be Abdul Ali without space. So see how it's going. Then again, so 8 seconds ago, it shows me, so Abdul Ali, right? So this is the way of working. But as I said, it's really long, and it's which is not maintainable, right? So in that case, how I can add something here? I put the another action called the another custom connector flow helper, and reorder first name and surname here, and then I just get the first name and surname, and that's it. And I will save it and see how it's going. Then I will just add another one. So another character from Squid Game. So Ki-hun Song. Then submit again. Then it will display the result. We are expecting, because it's Korean name, so it should be the displaying Song Ki-hun. So see how it's going. So it shows me Song Ki-hun, and also it shows me the Song Ki-hun. But the real difference between these two is I have reduced the number of actions into just one, because I'm using the custom connector, right? So this is a really benefit of using custom connector. So I just completed the how to make use of a custom connector to reduce the number of the actions through the within your Power Automate workflow. This is really the handy. So please make use of this kind of trick and for your Power Automate application development. So let's recap what I showed you today. So I activated OpenAPI capability into your existing Azure Functions application. Then I showed you to create a custom connector directly from Azure Functions using the OpenAPI capability with just a few mouse clicks. And then I showed you how to communicate the backend API directly through the OpenAPI enabled custom connector within the Power Apps application. And finally, I showed you how to manipulate the data through a custom connector within the Power Automate workflow. So that's it from me. So thanks for the event partners today. And also thanks to the supporting communities. So I think that's it from me. So is there any questions?
Yes, just if you have one question, let
Sure.
me put in the screen. Can we convert APIs built on Django Post REST framework as you just did it for the Azure function?
Yeah, that's a really good question. There's actually there's so many questions around this. So that the Azure Functions OpenAPI extension is currently only for .NET at the moment, but we are supporting the major other languages such as JavaScript, Java, Python, and so forth. So these are on our roadmap. So we will be supporting these kind of things soon.
Okay, thanks for the answer. And also,
Okay.
we have one more comment saying this is going to be useful. And he said,
Yeah.
thanks.
Yeah. Thanks, Bruce. Right. So yeah. So that's it from me. So thanks for listening. So I have showed you about how to activate the Azure Functions application, and I mean the OpenAPI capability into your Azure Functions application. And as I said before, this is going to be the GA soon, really soon. So I'm hoping you can make use of this extension within your application. Thank you.
Thanks, Justin. Thanks for the very good session. It's very informative, and definitely it's going to be very useful.
No problem.
Bye.
Bye-bye.
So now we are set for the next session. I welcome Kupura Sunagraj for talking about the best practices for building and designing Azure functions. Um, He's a Microsoft MVP, and he's a Microsoft certified trainer and community influencer. He's a regular speaker on our forums. Um, Hi, Kuproso.
Yeah. Hi, Rajesh. Thanks for your warm welcome. Hello, everyone. I am Kupras Nagaraj. I am currently working as a senior software engineer, Kowai.co, and I'm Microsoft MVP since 2016. Rajesh, can you share my screen?
Yes, please. I don't see your screen. Can you share it?
Yeah, yeah. Yeah. Can you able
Yes.
to see my
Go
screen,
ahead.
Rajesh? Yeah.
Yes.
Yeah. Thanks for
Okay.
information, Rajesh.
The stage is yours. Thanks, Kuproso. I'll leave now.
Yeah. So today I'm going to talk about this session for best practices for building and designing Azure functions. Okay, so this is my session agenda, Azure Functions overview. So I'm going to give you a small introduction about Azure Functions and why we need Azure Functions, where we are going to use the Azure Functions, and how to create Azure Functions in Portal. And also I'm going to give couple of best practices for building a Azure Functions. Okay, let's jump into the session. First, what is Azure Functions? So Azure Functions allow us to run a small pieces of code without worrying a application infrastructure. That means we are going to build a applications. Then we are going to deploy the application in the Azure platform without managing any infrastructure or provisioning any infrastructure. Just we are focusing our application, not the infrastructure. That is Azure function. Okay. And so why we need Azure functions? It's a lightweight and serverless. Serverless means we are not managing any servers. Just we are going to build the application. Azure, earlier I said it's a small pieces of code. That's why it's a lightweight. Also, a small team can manage the Azure functions because it's a small functions. Maybe one or two people can easily manage the Azure functions, and easier to write and deploy because it provide different languages to create the Azure functions. For example, C# and Java, and I will explain the next slide for supporting languages. So we can use our existing knowledge to build Azure functions. Okay, and within a within a couple of minutes, we can deploy our Azure functions. Okay, and we no need to any infrastructures, and we have a zero maintenance. Because, for example, so if our application need to scale up, it automatically scaling up. It's if you are not using so much our applications, it automatically scale down. It taking care by the Azure. Okay, we no need to scale up, we no need to write any scale up and scale down rule. Okay, it's automatically scaling. And pay per use, the concept, pay per use concept. So we are not going, for example, I'm going to create one Azure function today, but I am using my Azure functions 10 or 30 minutes only. I'm going to pay only for that runtime, my code. Okay, so not for entire day. That is a pay per use. That is a consumption plan, and we can build Azure functions in different way. One is Azure Portal, Visual Studio Code, and other code editor also. But we can easily build and test and deploy our application Azure Portal using the browser itself. That is a very simple way to create Azure functions. Okay, and here how to run our Azure function. So we have the triggers. So the trigger is invoke our Azure function. So we have number of triggers. Here I am giving some examples. The one is a HTTP trigger. So execute our code using the HTTP request. So when we create the Azure function using the HTTP trigger, we will get one HTTP endpoint. So whenever we request that endpoint, our Azure function will execute. Okay, and timer trigger. So timer trigger, if we want to run our Azure function a particular scheduled time, for example, every 1 hour or every day midnight 12 o'clock or weekly once. So based upon our requirement, so we can write the scheduled functions. For example, where when we use this as timer for trigger, so if we want to clean up our database, or we want to send email to particular time to all the subscriber, those scenario we can use the time trigger. And we have another trigger is Cosmos DB trigger. So if we have the Cosmos DB service in our subscription, then we want to do some operation whenever we added the new documents, or updating some document in the Cosmos DB, we can use this Cosmos DB trigger. And blob trigger, so this blob trigger, whenever we upload any files into the blob, it will automatically start at this Azure function. So for example, so whenever I upload any image to my blob storage account, then it automatically creating the thumbnail image. So I need to resize the image, so it will automatically, whenever I upload the new image to my blob storage, this function will execute and resize the image and store to some container. Okay. And queue trigger also. So the queue trigger, so whenever the new messages come to the queue, this function will execute automatically. So here we have a lot of triggers. Here I explained only couple of triggers. Okay. These are the languages supported in the C sharp, supported in the Azure functions. The one is C sharp programming, and EPSAR, JavaScript, Java, PowerShell, Python, and TypeScript. So if you are the JavaScript developer or Java developer, you can also build the Azure functions, and you can integrate your application. You can use this Azure function in wherever you want. Okay. And here I'm going to give you a small demo in the Azure portal. So how to create Azure function in the couple of minutes. Okay. So I have already logged in my account. So I'm going to create a new Azure functions. So whenever we want to create a new services in Azure portal, we are going to click just create a resource, and compute section, go to the compute section and function app. Otherwise, you can search also in the search box. You can directly search Azure functions. Okay. Either way, we can going to create Azure functions. So first we need to create Azure function app. Function app is a container. So inside the function app, we can create multiple functions. Okay. So first I'm going to select my subscription and resource group. Here I'm going to create new resource group. Is that config 2021, and is that config 2021 demo. Here we have the two way to publish our code, our Azure functions. One is code, another one is a Docker container. If you have your Azure function in Docker container, then you can choose this option. In this demo, I'm going to choose code, and you can select your run stack. So previously I explained Azure functions support different languages. You can see here .NET, Node.js, Python, Java, PowerShell core, and custom handler. Here I'm going to choose .NET and the version. So also Azure function will supporting the .NET 6 preview. So once the .NET 6 is published, then we can use the .NET 6 runtime. So here I'm going to use the .NET 3.1, and you can select your region where you want to deploy your Azure code. Okay, so I'm leave it in the central US section. And so next, the hosting is very important. So because whenever we are creating the new function app, it requires Azure function storage account. Sorry, Azure storage account. Okay, so we can use either new storage account or the existing storage account also. The best practices is when you can use separate storage account for each Azure functions, because if unfortunately we deleted if I am using same storage account for different Azure functions, unfortunately I deleted the storage account, then all our Azure functions will not run. Okay, so avoiding this situation, so possible whenever you are creating the new Azure function app, you can create new storage account also. This is one of the best practices. And also you can choose which operating system you are going to run your application. So I'm going to select Windows. And here the plan type, the first one is a pure serverless option. So that is a consumption plan. So another one is a function premium plan. Last one is a app service plan. So first one, consumption plan, that is a pure serverless application. So we are going to pay only for the usage time, okay, not the end of the full day. We are going to only pay for our code running time. That's all. Okay. So next, here we have some challenges. So when we using that function app, we have some timeout limitation. So I can see the hosting plan, time function timeout durations. You can get this information in the Azure documentation portal. So if you are using that consumption plan, the default timeout is 5 minutes, the max timeout is 10 minutes. So we need to execute, we need to complete our function logic within the 10 minutes. Okay. And if we are going to use the premium plan, then the timeout is unlimited. So based upon our requirement, we can choose the which plan, which hosting plan we need. Okay. So consumption plan, or it's a small Azure functions, we can use consumption plan, but it take more than 10 minutes. Then we can use either premium plan or app service plan. If we have the existing app service plan in our subscription, we can use that same resource infrastructure to the our Azure functions also. Okay. So the 3 hosting plan is available. So here I'm going to use consumption plan for this demo. Okay. So next, networking. So I leave it as it is. And monitoring. So another best practices. So whenever we create Azure function app, we should enable that application insights. The application insight is a application performance management. We can get the success count and failure count, all the informations. Okay. So once we enable these services, it is additional services to managing that performance. Okay. Our performance of our applications. Okay. So here I am enable this application and click next, and just I'm going to review and create. Once the validation is completed, then it will take 1 minute, maybe it take 1 minute to create the function app. Here what we done now, so just we are creating the function app. It's like a container, still we are not creating the functions. Okay. So once the function app created, then we are going to create the functions. So it take only few minutes. Okay. Still its deployment progress is going on. So once the deployment is completed, we will get the notification. Then we are ready to create the functions. Yeah, almost deployment is going to complete. Yeah, deployment is completed. Just I click go to resource. So this is our function app name, AZConfig 2021 demo. And in the left side pane, we have the functions option. Just click the functions. So this is a new function app. So we don't have any function now. And you can click create button. And here which environment. Here I'm going to create my function app in the portal itself. So I select here. You can see here we have the different options. Earlier I said we have the different option to create Azure functions, Visual Studio, VS Code, and other editor also. So I'm selecting the default one, develop in portal. And also you can see here the couple of triggers is available. So here I'm going to choose HTTP trigger, and you can mention your function app name. Is it conf 2021? And also you can see the authorization level. So the authorization level is security purpose. Who can access this Azure functions? See here we have the three options. One is the function. So if we select the function, we will get the function key. With only we can access our function with the key. Otherwise we can't access. Next one is anonymous. So anonymous means anyone can access our Azure function. So here I'm going to select anonymous. Also we have the admin level authorization. Okay, so here I'm going to choose anonymous and click create. So now we will get the Hello World kind of application in portal. We can quickly test this Azure function in our portal itself. Okay. So once the function is created, then we will get that Hello World kind of applications. There's a small application here. Okay, just I'm going to run this application, the portal itself. So I'm going to click the test and run button, and here I'm going to choose welcome to ZConf 2021. Just I'm going to click run. See here. So hello, welcome to AZ 2021. The HTTP trigger function is executed successfully. So we can run our we can write the application and testing, applying everything in the portal itself. Here you will you can see here get Azure function URL. This is the endpoint for our Azure function. Okay, just you copy this endpoint and open its another tab. Okay, this is our Azure function endpoint, but the HTTP trigger function is executed successfully, but it asking to pass the query parameter. Okay, just I'm going to add the name property in the query parameter. See, hello Kuppu. This is HTTP trigger executed successfully. This is a simple way to create Azure function in the portal. Okay, I'm coming back to the presentation. So I hope you understand how to build a small Azure function in the Azure portal. And now I'm going to talk about best practices. Okay. So first, we should avoid the long running functions. Okay. So always we need to avoid large dependencies whenever possible, because each function should have a single responsibility over the single part of the Azure functions provided by the softwares. Okay, so always we keep one functionality for one function, one particular operation for one function. We know we should avoid the combine multiple operations in one single functions, because if we select the consumption plan, we always remember we have the timeout, max timeout. So, okay, so if our function take more than 10 minutes, automatically the function will stopped. Okay, so we should avoid the these kind of dependencies. Always if we have the large dependencies function, we should refactor and convert into the small pieces of code. Okay, so always we keep in a small functions. Okay, the first best practice is avoiding the long running functions. Second one is avoid the cross functions communication. For example, my function to one function to communicate to other functions directly, it's not it's not possible. Okay, because the Azure function is not built for the managing communication between one function to one functions. If we want to communicate one function to another function, we have the durable function option. Okay, so let me quickly show in the portal. So I'm going to create another function. We have the option durable functions. The durable functions support stateful. Okay, we can communicate one function to another function. For example, one first functions executed and give some output to the second function. Then second function once get the input from the first one and it executed and uh, given to the third function. That is a chaining method. So if you want to do this kind of um, operation in our Azure functions, we can use durable functions. Okay, you can see here durable functions. So we can use this durable function for stateful. So durable function is a stateful. Normal typical function is a stateless. We can't communicate one function to another function. Even we have the options. Um, even we have the option to communicate one function to another function using the storage queue or service bus queue. So the first function executed and give that output to into the queue storage. We can store that output in the queue. Then the second function will get the input from the queue. So we can use the this kind of mechanism to communicate one function to another functions. Okay, so next, perform input validation. So we whenever possible we need to validate our inputs, because the injection flaws attacks is one of the most common risk in the applications. Okay, so we should follow uh, this option, this perform input validation to avoid the security attacks. Okay, and also you can give the permission to you can use the role based access control to assign the permission to the user and groups and applications. For example, sometimes we are going to give some permission to some users to access our Azure functions, and all some groups, all other Azure services also access our Azure function. So that time we are going to give the required permissions. Sometimes we are going to give the reader permissions. They can access only the Azure function. They can't do it anything. How we can assign that user permissions in portal? I can show quickly. You can go to the access control options. Okay, in the same Azure function app, I clicked access control, and you can click add role assignment, or you can add the role co-administrator also. So here I'm going to click add role assignments. So you can see number of built-in roles available. So you can select reader or contributors. Okay, which permissions you want to assign to the user or groups or um, other applications, you can select here. So here, if you want to assign only the monitoring data to particular users, just you can select here. That user can access only the read all the monitoring data. Okay, so they can't do anything in this function app. Okay, so if you want to give only the reader, they can only view all resources but does not allow to you make any changes. So this is one kind of best practices to secure our Azure function. So next, we were be aware of third-party packages. It's very important to aware the security risk, especially when it is come to the dependency chain. So if we are going to use third-party package in our Azure functions, we should aware the security risk also. Okay, and I'm going to give on some additional security options here. So we can also configure um, authentication. So who can access? Okay, here we can add identity providers. So here we have the different Microsoft and Facebook or Google signing options and Twitter and OpenID. So if you are selecting this Microsoft AD, then we can select that. We need to create the app registration, then select which options we are going to use here, and just if we are enable this identity provider, only the particular we can use Azure AD for our authentications. Okay, so now the authentication is enabled. Or if we are not required this authentication, just we are going to delete this. So it support that authentication mechanism also, and you can scroll down and you can see the networking section, and also we can set the inbound traffic also. So I'm going to restrict the access. Okay, so here I'm going to enable this. Default it's off. Here I'm going to add the rule. Okay, here I'm going to mention that IP address for which machine I can access this Azure function. Otherwise I can whitelist couple of IP ranges. Okay, so only we can access that Azure function within the IP range. Okay, so these are the Azure security best practices to secure our Azure functions. Okay, here I am going to maybe I can show the demo how to secure access this Azure function in particular machines. So here I'm going to get my IP address. You can quickly get this IP address because I'm using the Wi-Fi modem. This is my IP address. So I can quickly go to the portal. Here I'm going to give the priority 100 and IP version 4. And here and the action is allow. So only I can access this IP address. So if you are someone trying to this Azure function, the different IP machines, they can't access. Okay, so that is one security. So if I'm going to add this rule, I can only access this Azure function. So no one can access this Azure function their machines because I set the network rule. Okay.
Hi Kuparasu,
Yeah.
sorry to interrupt. Last 4 minutes.
Yeah. So almost I explained all the best practices uh, uh, for using the building the Azure functions. Here I want to thank the learning partners and all the community supporting this Azure conference. So any QA, Rajesh? Any questions?
So far we don't have any questions. Let's wait for 1 more minute and see is there any questions.
Yeah.
Let's wait for a minute so that everyone is having.
Thanks, Kuparasu. It's a nice session and learned a lot about the best practice of Azure
Yeah.
functions, and we will try to implement the best practices.
Yeah, thank you, Rajesh, and I would like to thank to the entire organizing committee to giving this wonderful opportunity to present. I am very happy to part of this conference, Rajesh. Yeah, thank you.
Welcome. Thank you. Bye.
Thanks for the link. Thanks.
you very much, Farah and Wayne. It was a wonderful presentation, and we are grateful for the time. Well, for it. What is that?
I guess yeah, it's almost the other time.
Hi, it's time for next session. Hi, I would like to invite Mr. Xavier. He's going to talk about performance features in SQL Server and Azure SQL. And Xavier is a Microsoft MVP data platform, Microsoft Azure Data Advisory Board member, is a SQL Argentina group leader, and also a technical speaker. Hi, Xavier.
Hi, Rashesh. Good day to you. How are you?
Yeah, I'm good. How are you?
I'm doing good, doing good. Thank you. Thank you so much for again having the possibility of presenting in this great conference. It's a pleasure for me to be here today one more time.
Thanks for having you also in the session. Stage is yours, Xavier.
Thanks, thanks. So you tell me when we are ready to roll. Shall we go ahead?
Yes, please.
Okay. All right. Very good. So go to slide. You see my screen, right?
Yes, yes, we can see your screen.
Very good. Okay. So thank you everyone for attending to the conference and to my session today. One more time, it's an honor for me to be here presenting my session with all of you. Thank you so much to all the partners. Without them, this kind of events are not going to be possible. So definitely, thank you for being with us today. So my name is Javier Villegas. I am from Buenos Aires, Argentina. I work as IT director in databases and BI services at Mediterranean Shipping Company. I am working with SQL Server. I've been working with SQL Server for over 25 years. I am MVP in the data platform category, Microsoft certified trainer, and also a member of the board of advisors of the Azure Data Tech community. You also have here my contact information at the top of the screen, my email address, Twitter, LinkedIn. So feel free to reach me if you have any questions regarding to this presentation. So the idea today is to talk about performance features in SQL Server and Azure SQL, right? So we will try to cover some of these features and well, see how we can implement them in our environment, right? It's important to emphasize that this is not only SQL Server, it's for the whole Azure SQL umbrella of products and services. So I always like to start my presentation trying to understand a little bit what Azure SQL is, right? This is a fairly new concept in where, you know, Microsoft is aligning all the SQL strategy under Azure SQL. Today, there are mainly 4 components. 3 of them were part of the Azure SQL stack since a while, and there is one that is fairly new, which is Azure SQL Edge, right? Which allow us to give us the possibility of running SQL Server, a SQL Server like on ARM device, like BlackBerry Pi, for example, right? We won't be focusing on Azure SQL Edge today. We're going to be focusing on the other three components of the Azure SQL family. We're going to know them in a few seconds. We will also be covering performance features in SQL Server, right? We know that there are multiple versions of SQL servers, but the ones that we will be focusing today are, present in what Microsoft called the modern version of SQL servers, which are 2016, 17, and 19, right? So this feature set is going to be present in the modern versions of SQL Server. So the three main components of Azure SQL are the first one is under the bucket that Microsoft called infrastructure as a service, is Azure SQL virtual machines. What is this Azure SQL virtual machines? Well, basically is the very same SQL Server bits that you are using on-prem, but running on an Azure virtual machine. What is the benefit of this? Well, first of all, when you deploy one of these Azure SQL virtual machines, you do it very easily from the Azure portal, right? And when the virtual machine gets created, it comes with a certain set of best practices already pre-configured, right? So everything that is related to, for example, the storage on where to put the data files, the log files, the TempDB files, they go directly to the proper disk. So that part gets kind of pre-configured. Right? It's also interesting to emphasize that we can have SQL servers running on a specific operating system. You know that since SQL Server 2017, we can run SQL Server on the major Linux distribution like SUSE, Red Hat, or Ubuntu, right? So you can have any combination of operating system and SQL Server version and edition, right, directly pre-configured from the portal. And it's interesting because you can go back to Windows Server 2008 R2 running SQL Server 2008 R2. So you can start from there. Hopefully, nobody's running their production workload on 2008 R2 because, it's not longer supported, same as 2012 and 2014, right? But you can eventually. And of course, you can choose a state-of-the-art virtual machine running Windows Server 2019 with SQL Server 2019. That is what Microsoft called infrastructure as a service. As I said, this is, at the end of the day, a virtual machine. So you have to take care of everything that is supporting your SQL Server installation. Like, for example, the operating system, the networking, the security, high availability and disaster recovery, and all those things that today we take care of, right? So if you have to, let's say, apply patches, you have to do it through the OS and, of course, through SQL Server. If you want to set up high availability disaster recovery, well, you have to create more than one of these virtual machines, create the proper clustering, availability group, etc. So all the things that we are taking care today, we're going to keep taking care of it even if we use this Azure virtual machine. That is why Microsoft call it infrastructure as a service, right? Then Microsoft have another concept, which is platform as a service. And under this bucket of platform as a service, there are two main components. One of these in the middle of the screen is Azure SQL Managed Instance, which is a SQL Server-like endpoint in Azure. What does it mean? You will connect to your SQL Server, to your Azure SQL Managed Instance from your application, Management Studio, Azure Data Studio, Visual Studio, whatever you use, right? And you will be connecting only to the managed instance. You don't know what is behind the scene, right? Because Microsoft is providing it to you as a service. So everything that is related to the points that we mentioned before, like patching, like high availability, like backups, all those kind of things are already covered. You don't have to worry about that because it's coming as part of the service. And this is a service that is almost 100% compatible with SQL Server on-prem, right? So you can have your SQL Server databases, do a simple backup, restore it into a managed instance, and you can have your application up and running there. Also, under the bucket platform as a service, there is this other service called Azure SQL Database, right? Which is targeted to modern databases. You can ask me why there are these two flavors under platform as a service. Well, managed instance is quite similar to what SQL Server is, with database mail, with SQL Server Agent, Service Broker, SQL replication. I mean, all the features that we know since forever, right? Azure SQL Database is a little bit different because everything has to be, let's say, living within the same user database. So if you have in your code a store procedure, which today is doing a select and a showing between tables that are located in different user databases, well, you will have to modify your code because, as I said, everything has to live within the same user database, right? Again, remember what I said at the beginning. This is targeted more to modern applications, right? And, you know, just as a piece of history, this Azure SQL Database was part of the first set of services that were released when Azure was announced many years ago, right? Of course, it has evolved a lot since then. So these are the three main components of Azure SQL. Now we're going to start talking a little bit more and focusing a little bit more in the performance features. And what I like to emphasize is that all the things that we will be covering in regards to performance works for any of these offerings. So also we can say that today SQL Server runs everywhere. We can run SQL Server on a bare metal server running Windows 2019 and SQL Server 2019. The same applies also for Linux, as we said, since SQL Server 2017. We also have the possibility of running SQL Server in containers. If we need to achieve better high availability and orchestrate the containers, we can use SQL on Kubernetes. As we said recently, we also have the possibility of running SQL servers under virtual machines, managed instance, Azure SQL databases, and SQL Edge, right? Again, as I said at the beginning, the possibility of running a SQL Server stack on an ARM device. Okay, a couple of important points to mention also about the whole Azure SQL thing is that it provides us with a great set of features and specifications that we can use and take advantage of. For example, everything that is related to business continuity, high availability, it is part of the service, right? There are different SLAs coming for each of the offerings that we have, and all of them can be improved just doing, certain geo-replication settings. Everything that is related to backups, it's also covered as part of the service. We can rely on the automated backups, so everything that is related to taking backup and storage the backups with a long-term retention, and also storing those backups in different locations, right, is covered by the service. One of the parts that I love the most is the possibility of doing scale, right, in a matter of few clicks. Consider that today, if you have your SQL Server machine in your data center and you need to add more memory, more CPU, better disk, or anything, right? It's a process that could take some time because you have to reach the hardware vendor. You had to find out if the memory that, if the type of processor works for that specific machine, if the disk fits, etc., then you have to buy those components, then coordinate the downtime, and do the whole thing. Right? This is a process that takes some time, so it's not going to be right away. Well, in Azure SQL, you have the possibility of, in a matter of few clicks, just scale up your virtual machines and your Azure SQL managed instance and Azure SQL database. You can assign more compute power in terms of virtual core, memory, and disk in a matter of few clicks. Right? So if you need to scale up your SQL Server environment, it's a matter of few clicks, as I said. And eventually, if you would like to scale down, right, because you are not using those resources or for any reason, you can do it with absolutely no problem. Then in the Azure SQL, let's say, platform as a service offering, there is this concept of versionless, which is quite interesting. Right? You know that historically for SQL Server, you have versions, right? 2008, 2012, 2017, 2019, etc. Every time there is a new version, major version, and you need to upgrade or migrate to it, well, you have to set up like a whole project, right? Because you have to validate that your workloads work well in the new version with the new features. You have to identify if there are no regressions, etc., etc. In managed instance and Azure SQL database, Microsoft call it versionless. What that means? There are no versions, right? So it's going to be always Azure SQL, right? So in the future, it's not going to be a version 2, 3, or 4. No, it's going to be always Azure SQL, and that's going to give us this benefit of making sure that the code is quite stable because we don't have to make those changes and prepare for a migration. Does it mean that if there are no new versions or there are no version numbers, this is a static product and there are not going to be any fixes or improvement on the engine or something like that? Answer is absolutely not, right? The other way around, actually. Microsoft is deploying the new features and the fixes first in managed instance and Azure SQL database, and then moving them with a cumulative update or in a major SQL Server version to the on-premise product, to the SQL product, right? So this is quite interesting. And then all the monitoring tools that SQL Server and Azure SQL provides, well, we have them available for us. with all the integration that we can see in the Azure infrastructure, because there are many other tools, like for example logs analytics, that we can take advantage of, SQL Insight, right, in where we can see from the Azure portal, the monitoring of our SQL services. And then, right, what we're going to be focusing from now on is the built-in intelligence for the performance, right? So let's start digging a little bit on the performance features, right? And it's important to mention that for performance, let's say at global scale, not much has changed. There are three main pillars that we have to take care of constantly, right? Just to make sure that our SQL Server works well. And those are memory, CPU, and IOPS, or storage, right? Those are the things that we really need to focus on to, understand if there is a problem in our environment, what is happening in one of these three components, right? If we have a bottleneck or something like that, and then take the necessary actions. We can also, improve performance with proper indexing, with in-memory OLTP, right? This is a feature that allows us to put some of our tables up in memory, right? Partitioning, right? And the thing what is intelligent performance. We're going to be talking in a second. In terms of the performance-related task that we need to, do for our environment, again, this hasn't changed much. We need to do the proper setup of the MDB. We have to maintain the statistic, the fragmentation, etc., right? So how do we do monitoring and troubleshooting in Azure SQL? Well, there are a certain set of features, right, that will help us to accomplish that thing, right? What is interesting to mention is that from the modern SQL Server versions, Microsoft is focusing or relying on this new concept of intelligent performance, which basically is for those cases in where, I bet you have seen all this situation in where you have a workload that constantly runs with certain runtime in terms of duration, CPU usage, etc. And one day, for any reason, the very same code start taking way more, right? Because that could be multiple reasons. The most common one is a regression in the plan, right, in the execution plan. Well, Microsoft will focus with this intelligent performance concept of constantly monitoring, right, the plan cache, the runtime statistics, and if there is something that moves from the standard performance, it will apply certain correction actions in order to set it back to the previous performance. So this way, doesn't matter if the server is, or if the instance is heavily loaded or is quite idle, we can set, let's say, a predictable and stable performance set, right? So, in SQL Server, in Azure SQL, Managed Instance, Azure SQL Database, we always have what is called the dynamic management views. These are a set of read-only objects in where the SQL Server engine is providing to us all the feedback of what's happening underneath, right? This read-only object, you go and can check, for example, everything that is related to the active transaction, to the missing index, to the health, for the memory, for the availability group, everything, right? So these are the dynamic management views and functions. It's important also to mention that there are, most of them are common for all the Azure SQL stack, but there are certain that are specific for Managed Instance and for Azure SQL Database, basically to address that situation in where we have the the platform as a service offering, right? So these are the performance features that we are going to be focusing from now on, right? Again, considering that, as I said, these are targeted to Azure SQL and SQL Server starting from 2016. We're going to be covering query store, automatic query tuning, adaptive query processing, intelligent query processing. We will also see something related to the new features in 2019 related to 10dB metadata. So again, this new performance concept that is what Microsoft called intelligent performance, intelligent database, constantly checking what's going on and doing the necessary actions to fix, the execution. And with that, we're gonna start with Query Store. Query Store is a feature that is available in Azure SQL and SQL Server since 2016. And basically, it's allow you, when you have it enabled on your user database, right, it will capture all the runtime statistics, right, and the execution plans history for every single query running on your system, right? So for every query running in your database, right, you're going to have, this black box, right, which is a process that under the hood is capturing, you have your procedure. That procedure took, this amount of minutes. It took, it made this amount of read, write, etc. And then the plan for that specific query ID was this one. We will see it in action in a minute. So it's like this performance repository for a user database that we can use. We're going to see what can we do with this repository, right? First of all, we can do the monitoring. We can find out which are the processes that are taking the most. We can, take some actions, etc. But there are some other things that we can do with that. How Query Store works. In a nutshell, when you run a store procedure for the very first time, the SQL Server engine will compile an execution plan for it, right? And will store it into the plan cache. And also, it will store that plan into the Query Store engine, right? When it gets compiled, it will execute that procedure based on that plan that was generated. And after it gets executed, right, it will store all the runtime statistics on Query Store as well, right? How do we enable Query Store? Well, consider this. In SQL Server, as the product, right, when you create a brand new database, Query Store is disabled by default. So you have to go do this and enable it. In managed instance or Azure SQL database, when you create a brand new database, Query Store is enabled by default, right? This is something to consider. So in SQL Server, you go to your database properties, you go to the option Query Store, and then you just need to enable the Query Store mode here. Once it is enabled, we can go to the proper database and check the Query Store report. Here we will see it in a minute. And the important thing is that you can also force a plan, right? So let's say that one of the execution that you have has a regression, right? Because the plan changed for any reason, and now the new runtimes values are not good, right? Taking longer than usual. Well, you can manually force for a specific query ID to use a specific plan, right? So here I'm also putting some best practices for Query Store, right? Which is important to consider, especially if you are running Query Store on a highly load environment. Well, At the top of Query Store, starting SQL Server 2017, Microsoft has created this feature, automatic query tuning, which works, as I said, at the top of Query Store. When you enable Query Store on the database and then you enable automatic query tuning, right? If the SQL Server engine detects that a specific query ID has a regression, so the new plan is worse than the previous one, right? So it's taking way longer than before. What it will do automatically, right, will be to set the plan to the last known good one, right? So this way, without any user intervention, right, if detect a regression in the plan, it will automatically correct it on the fly. So the upcoming executions will be same as the previous one, right? So this is a feature basically that we have in SQL Server and Azure SQL, as I said. And how does it work? Well, it is constantly checking this query store repository, making the fixes, right? Adjusting, right? And verifying if the new runtimes are better than the previous one, and then confirming it. And when this is confirmed, right, it keeps moving on. So that means that this is not a one-time only mechanism, right? It's constantly checking and trying to identify these regressions to then apply the proper correction action. And what is a plan regression, right? As I said, we are running with a constant execution time or constant resource usage, and suddenly, boom, it goes to the moon, right, in terms of execution time, right? So again, automatically it's applied the plan correction, right? In Azure SQL Database, there is also another feature, right, which is unique for Azure SQL Database, which is automatic index management, right? What is this? If Azure SQL detects that for your user database, it will be useful to have a new index, right, and you have this feature enabled, right, it will automatically create that specific index, right? And eventually, if it's not longer needed, it will drop it, right? So again, it will use this query store mechanism to find out, okay, this particular query is going to run much better if we create the index, right? It's not only telling you, it's also creating it for you, right, on the fly, right? Of course, you have to be aware of that when the index get created and also dropped, it can cause some specific, performance things. So it will try to get the best time to create the index and eventually to drop it. That's query store and automatic query tuning. Then in SQL Server 2017, Microsoft also added this new concept of adaptive query processing, right? Historically, when SQL Server engine come up with a plan, right, for a specific store procedure, for example, right, that plan is going to be static, kind of, until it gets a new one for any other reason, right? But, the plan could not be, the best or ideal, right? Well, now, starting with 2017, Microsoft allows with this feature, right, to, after executing the store procedure, for example, with that particular plan that is compiled, to come up with certain feedback to the engine, so then on the fly, for the upcoming execution, it will be adjusting some parameters. So the plans are not longer 100% static, right? It could be adjusted on the fly. And this one gives us a lot of benefits, right? For example, right? Remember, this is 2017. There is one which is really good, and we will see it in action in a minute, which is memory grant feedback. And this is the one that I like the most, because, when the plan get compiled, let's say that the SQL Server engine grant 10 megabytes of memory for a specific plan, right? So when you continue executing the store procedure, let's say that for some reason it's not taking the 10 megabytes, it's only taking 1 megabyte, right, for the execution. So you are wasting 9 megabytes. You can tell me, oh, 9 megabytes is not a big deal with the servers that we have today, right? Well, but what about if that particular store procedure is being executed concurrently multiple times per minute, right? You're going to be wasting a lot of memory. And, that could impact on the overall instance performance. And the other way around, let's say that, the SQL Server engine granted 10 megabytes for that specific plan, but for some reason in the upcoming execution, it will require 20 megabytes, right? It will use the TempDB to spill, right? And, come up with the execution with a lot of performance regression, right? You know that when SQL Server uses TempDB to spill to disk, normally, execution times are not the best. And there are, other possibilities for this feedback, like, for example, adaptive join that, depending on, if you have a join, SQL will come up with a new operator, which is adaptive join, which is depending on the amount of rows returning from, one of the joins, one of the tables, and the join operation, right? It will use one type of join or the other, right? So depending on, the number of rows returned by the operation. That is quite interesting. In SQL Server 2019, Microsoft added a new set of, a new component to this feature initially called adaptive query processing. It was rebranded to intelligent query processing with, other possibilities, always in this matter that we mentioned earlier. You have the plan, and after getting executed, it will provide feedback to the engine, so it will adjust the plan on the fly, right? So the ones that you see in bold, here in bold fonts, are coming in, are from 2019, and the one in regular fonts are the ones from the original adaptive query processing in 2017, right? The one that I like the most here is the one at the top right, which is scalar UDF inlining. You know that historically SQL Server was not doing very well with scalar functions, right? Let's say that you have a scalar function with a huge logic underneath, right, on the definition, and then you use that function within the select, or even on the predicate or something like that. Well, SQL Server was considering that whatever is on the scalar UDF has no weight or very low weight, right? So it was kind of saying, oh, this one is not going to affect on the total weight of the execution, right? And that was not always the case. We have seen a lot of performance problem with that. Well, in 2019, with intelligent query processing, if you have a scalar UDF inlining, right, SQL Server will compile the code of the scalar UDF and then will put it into the main plan. So this way, it's going to be way, way more accurate. Right? How do we enable all this? Well, it's quite simple. We just have the database, right? And we can use the compatibility mode. Right? If we set the database compatibility mode 140, which is SQL Server 2017, right, we will see the features adaptive query processing. If we enable it with compatibility level 150, it's going to be 2019, so we can have all the set of features. Then eventually we can disable this feature with another component, which is called database scope configuration, right? That will allow us to, let's say, enable or disable some of this or all of them in our database. Another one that we'll be focusing, and now we're going to jump to the demo, is lightweight query profiling. Right? Imagine that you have one report that normally runs in a few minutes, and one day is taking forever, and you don't know what's going on. Right? You don't know at which part of the execution you are at. For example, if it is at 10% of the execution, if it is at 50, or if it is at 90% of the execution, right? Knowing that that percentage of the execution, you will be able to take better decisions, right? With SQL Server 2019, we have lightweight query profiling. So for every single query running on the instance, right, by default in 2019, you will be able to see the estimated query progress, right? So you will see if it is at 10%, if it is at 90%, etc. This is an estimated progress, right? Knowing this information, again, will allow you to take better decisions. It is interesting also to mention that Microsoft has ported back this feature, lightweight query profiling, to 2016 Service Pack 1 and 2017. So enabling a trace flag, you can also do it in 16 and 17 as well, right? And then finally, we have 10dB metadata, right? That basically, with this feature at the instance level, for certain situations on the 10dB, and to avoid contention, you can use 10dB metadata. This is using the in-memory technology, right, for certain type of metadata for system for temporary tables, right? That means that when you have a workload that is dropping and creating a lot of, let's say, 10 tables in 10dB, right, the metadata of these tables will go to memory, right? And with that, you will solve a lot of problems related to latch on the 10dB for the contention, right? We will see it in a minute. So let's jump to the demo. Here I have my virtual machine in Azure, right? I am connected here to a virtual machine running SQL Server 2019, an Azure SQL database, and a managed instance, right? Some of the demos will be targeted to SQL Server and others to a managed instance. So let's start with lightweight query profiling, right? Remember to see the estimated query progress of all our queries in our database. So here I have one query. I have enabled include live query statistics, right? When I run it, see down here, I have the progress of the execution, right? But also up here, I have the estimated query progress. I also have the same thing at the bottom, right? So this procedure is being executed, right? In a 32% at this point, right? So again, knowing this, we can definitely take better decision. I have another query here. So when I run it, right, I see here how it's progressing, right? 20%, 25%. So we see the whole progress, and we can see this for every single statement in our database, right? It's really, really nice because you can measure, everything. And you can tell me, hey, but my workload is not running in Management Studio. I have an application server, a web server, or something. Well, from the activity monitor, you can go and see all the active sessions select the one you are looking at, do right click and see the live query plan, and you also have the estimated query progress for each of them. So it's extremely easy, right? So that is lightweight query profiling. Then we're going to switch to a demo related to Query Store, right? And for that one, see down here, I'm using the managed instance, right? What I did here beforehand, just to speed up the times, is I create a brand new database called Query Store Demo, right? Since we are using managed instance, remember I said that Query Store get enabled by default when you create a new database. For the purpose of the demo, initially I disable Query Store, right? And that is basically just to remove some of the noise or the garbage that it could collect in the meantime. So then what I did is I create a table here with 3 columns, a store procedure, which is basically doing a select from that table using a parameter. And then I added a lot of, let's say, random data to my table, right? When I go and I do a select, right, you see that here I have my data in the table. So what's next? Well, basically, next step will be to enable Query Store, and we will enable Query Store for this user database. So from this point onward, every single execution on my database will be stored into the Query Store repository. So what I'm going to do is I will execute the store procedure that was created earlier 20 times, right? So it just remember doing a select on based on a parameter that we enter. Something important to mention, right, is that the table that was created as a heap table with no indexing, right? So now I will go, let me refresh this one here. I go to Query Store, right? And we can go to top resource consumer. So here I have my store procedure execution, right? Here the plan that it came. Here I see the plan, and if I go up here, I can see, that the store procedure was executed 20 times with a minimum duration of 7, a max of 8, and an average of 7, right? So next, I will create a non-cluster index on the underlying table, and then we'll execute my store procedure another 20 times, right? When I go back to Query Store, right, see that now it came up with another plan, right? Plan ID number 2. And if I jump from one to the other, right, we see that the shape is quite different right now, and that is because I have the new index. If I go to check the runtime statistics, see that the plan ID number 2 is way, way faster than the other one, right, because of that index. Eventually, I can come back here and I can create another index with the covering index and execute it 30 times. Right? When I go here to check, I see that now there is a third plan, right? And we see that this one is even faster than the previous, right? Eventually, if we would like to say, hey, for my query ID number 1, I would like to always use the plan number 2, I can come here and say force plan, right? So this way, it will always use the plan number 2, and see that now there is like a tick here. So is telling us that is fixed, right? So it will always, it is forced, right? So this is query store. At the top of query store, as I mentioned, we have automatic query tuning. And for that, I will do a demo that I have here to show you. So remember, automatic query tuning is detecting automatically the regressions and fix them on the fly, right? So what I will do here is I will run, let's say, a random code on one of my user databases. When I go to perform a monitor here, right, you will, I'm here measuring the batch requests per second, and I have an average of 80 plus, right? This is running my database without automatic query tuning. So what I will do next is I will generate a regression, right? So the regression will, show up here, right? Now you see that the batch request per second has decreased to 15, 20, right? And this is because, the plan has a regression. So what do we need to do here at this point? Well, basically go to query store, identify the query ID that has the regression, and fix the plan to use the previous one, right? Okay, so let's cancel this. Batch request per second will go back to 0 because there are no more activity, right? I will prepare my database once again. And now what I'm going to do here is for my user database, I will enable automatic query tuning, right? With alter database, set automatic tuning, force last good plan equal on, right? So I will do that. I will rerun my random workload. Let's clear here. And again, I am back to the 80 plus average batch requests per second. And now I will enter the regression again. Remember, now automatic query tuning is enabled. So there's going to be a regression here. Let's run it again. There is the regression down here as you see it, but automatically without me doing anything, right? The batch request per second or the execution went back to normal, right? And this is because, automatic query tuning detect the regression and fix it on the fly, right? Quite impressive from my point of view. So let's close this one. So now if we go to intelligent query processing, right, we can go and check, for example, let me close this one. I would like to show you the automatic query, the intelligent query processing, right, for memory grant feedback, right? So here I have my user database. I will enable it by, setting the compatibility level to 150, clearing the cache, and then I will create a store procedure that you have to pass a parameter, right? The store procedure will do certain joins, nothing too fancy. So create the store procedure. And what I'm going to do now is execute the procedure, right, with one parameter, in this case, 8. When I run it for the first time, see here that it hasn't returned anything. I did enable the include the plan cache option, and now we go to the execution plan. When we go to the execution plan, we see that here there is a warning, right? And when we go to check what this warning is, it's saying that down here, right? The query memory granted detect excessive grant, right? So it granted a lot of memory and it ended up using not a lot, right? Now the plan is stored in the cache, right? And I will run the same store procedure, right? Again, but with a different parameter, the number 9, right? So when we run it this time, it will return something, right? It return 231,000 rows, right? When we go check the execution plan, now we see there is plenty of this warning sign, right? We have here one saying that the grant, here saying that the sort has to use the TempDB, and here also on the showing also had to spill to the TempDB, right? So the execution took 4 seconds, right? And you saw all these warnings. Now let's execute the store procedure one more time, right, with the same parameter, and let's see what happened, right? This time, instead of course, it returned the same amount of rows because we haven't changed any code, any data. This time, instead of taking 4 seconds, it took 1 second, right? And when we go to the execution plan, now we see that there are no warnings anymore, right? And that is because it used the memory grant feedback to adjust the plan, right? You saw the very first execution, came up with a lot of warnings, and then, the upcoming execution were much faster, right? And with the plan without any warning, right? Quite interesting, right? Here we have another one for the adaptive join. Let's do the same. Let's change the compatibility level, clean the procedure cache, and when we do the join, here I have the include actual execution plan enabled, right? It's going to do this. When I execute this, see that here, now we have this new operator called adaptive join, right? So depending on of the amount of rows returning by the join operation, it will use one type of join or the other, right? Also here, right, under the other possibility, which is scalar UDF inlining, right? Here I will do the same that I was doing before, changing the compatibility level and cleaning the procedure cache. Here I'm creating a store procedure, a function that based on the customer key, it will return the category, if it is regular, gold, or platinum, right? So we create the function, we double check the function, and we see, right, we confirm that this is an inline function here from the system catalog. And what I'm going to do now is I will change for a minute the compatibility level to 130, which is SQL Server 2016. Right? So I'll do it here, and I will run this select top 100, and here I am referring to the function that we create recently, right? So when I run it and we go check the execution plan, we see that the plan is doing this compute scalar, right? And as usual, is considering that it has no weight at all. If we
Hi, Javier. Sorry to interrupt. We have 3 more minutes.
Okay, thank you. Yeah, I think it's enough. So here I'm going to change the compatibility level to 150, 2019, and I will run the same select statement. You see that this is quite important. We are not changing any code here to get the performance, right? So when we execute it, and now we go check the execution plan, see that now the plan has all the shape of the scalar function definition as well as the main query that call it, right? So quite interesting. And well, I think that's it. Yeah. Finish with the demo. Let's switch back to the slide. Okay. So finally, if you would like to keep learning, and this QR code, this link will send you directly to the documentation, to the learning page from Microsoft to see all the features, not only related to performance, but everything that is new in SQL Server 2019. The same for Azure SQL Fundamentals, right? If you would like to learn more about Azure SQL, right, you can go to this link. And with this, we reach the top of the hour. Rajesh, if we have any questions, right, again, consider that you can reach me to my Twitter, to my LinkedIn, or my email if you have further questions.
Thanks, Javier. It was a nice session, a lot of information, and we learned a lot of things in the Azure SQL and SQL Server. So far, we don't have any questions. If there anything as you mentioned, they can contact you in the social media platforms.
Okay, very good. Thank you so much. Keep enjoying the conference.
Thank you.
Right? Have a good day.
You too. Thank you.
Bye.
Bye.
So maybe where they are able to log
Um,
machine learning model works and what can they able to automate because right now it's everything is going on automation. Hope this
We are all set for the final session of the day. We have Facundo La Roca is waiting to present the live final session of the day. He's going to talk about Azure WebSocket Revolution. And welcome Facundo Roca, and he's head of web development, and also he's a .NET and Azure architect. He's good in microservices, blockchain, and Solidity. Hi.
Hello. Can you hear me?
Yes, I can hear you.
Hello. Nice to be here. Yes. My name is Facundo from Buenos Aires, Argentina. So thank you very much. It has been a great event so far.
Thanks, Facu. The stage is yours.
Awesome. So I can start, right?
Yes, you can.
There we go. So here we are, closing the day today at the Azure Community Conference. So let's see. My name is Facundo La Roca from Buenos Aires, Argentina. I am an Azure and .NET architect. That's what I love doing. And today we are going to present Azure Web Sub service and why I believe this is going to be a WebSocket revolution and how we think about WebSockets. Of course, just if you don't want to, or just to be very, very direct, we are going to be talking about WebSockets and how we can create real-time applications way easier thanks to this Azure service. Okay, so this is going to be all about WebSockets and real-time applications. We will see some theory, we will see the Azure portal, and finally we will see Visual Studio and how to run a real solution. This is going to be the best part at the end. But before digging into the specifics of the service, I want to do a kind of quick recap at how we ended up using WebSockets. So once upon a time, too many years ago, we used to have long polling. So at some point, we realized that we wanted to have some real-time notifications to the clients, right? And back in those days, probably 15 years ago, there weren't too many tools to use. So the first one was polling or long polling, which is just simple doing requests frequently. We're usually setting up an interval and requesting for your notifications from the client to the server, correct? And eventually we got into this called long polling, which is the same. It's just that you're going to try to keep the connection open as long as possible. And when the timeout occurs, and you reopen the connection. This had very good things about that. It was very simple. Okay, the code was easy to read, easy to understand. When you see your client, you probably will see an interval set up there doing some Ajax code. That's all what you needed. There were no extra dependencies required, which is awesome. That means it's fully supported by the browser. You don't need to install anything else. And because of that, it was 100% compatible with any client you may have, right? That's very important. You didn't need to install anything new, and you needed to worry about compatibility, because you know it will work. On the other hand, it was a request response model, which you know is a kind of chatty. Well, all the time you are doing a request and then waiting for a response back. And it's still half duplex. When it comes to communication, there are actually two ways, which is half duplex and full duplex. Half duplex means that you send a message and then you need to wait back for a response, but you can do it both at the same time, simultaneously. You always need to wait this, either or the other. And of course, it was very resource intensive in terms of consumption. It was very expensive, not only for your clients, but also for your server. But it was still simple, scalable, evolvable, right? However, as we evolved and we realized that we were doing great things, we tried doing something better. And then we came up with these server-sent events. Okay, this was something new. It was still simple, no dependencies required, no libraries also. You didn't need to include anything else. It was supported by the browser. We will see that in a minute. And it was more efficient than long polling, right? At least you don't need to keep a connection open, or not in the same way. It was very efficient compared against long polling, right? On the bad side, it was still unidirectional. That means it's only the server sending events to the client, but the client couldn't send any event or notification to the server without opening a new connection, right? So you still could do Azure requests or Azure calls, but you need to open a new connection. Again, it's half duplex. Is only one way of communication. It's only the server to the client, and this is something that was not that good. It was not supported in all browsers. For instance, Internet Explorer was one of those servers that didn't support server-sent events. The problem with this is that now we started adding complexity, checking whether the browser supported long polling or server-sent events. We know that long polling was supported by default, but then we need to create some logic to detect, okay, does this client support server-sent events? If not, we need to fall back to long polling. So we started adding a lot of complexity there. So, but again, we kept evolving powerful machines, powerful clients also. We started getting mobile devices, and then notifications were something that we needed, and we needed very intensively. Okay, it was very important, not only for chat or for chat applications, but we wanted to have for payment system, for any kind of notifications, and it was even worse with the boom that mobile devices had. So we came up with WebSockets, right? So what are WebSockets? So it's a communication channel that you open between the client and your server. This is a separate channel, so it's not the same channel. It does still run over TCP, that's correct, but it's not the same channel that you use for doing HTTP requests. And one of the key features here, it is really bidirectional and full duplex. That means that over the same connection, the client and the server can send and receive simultaneously. Okay, this is very important. without opening extra connections. It was designed for high frequency updates because it is efficient. You have let's say, acceptable overhead creating the connection, but then keeping the connection open is almost insignificant. Okay, that's very, very important. And that enabled us to start creating real time updates on our application. Very, very important. We still had some bad things there, is that now we are dealing with way more complexity, not only in the code, but also in the architecture. We'll see in a minute how a WebSocket architecture look like. And again, this was not supported in all clients, okay? So now we still have this issue where I need to check, I need to be sure that my client supports WebSockets. If not, I need to somehow use another mechanism, either service send events or long point. Okay. Now, this is how an architecture look like at the very beginning, or if you are writing something small and just with a few users, you may be thinking, okay, I can just use my same backend server to put my WebSocket server, and that's fine. The issue that you have there is that it's difficult to scale. So we realized that we needed to separate the component. When we were designing our architecture, we had to separate the component in something isolated, because you need to keep track of your clients. You need to keep track of the either connections, for instance, that you may want to remove. You need to add more connections. So you need a state. You need a state. And then we know that when we are adding a state, things get a little bit more complicated, because scaling is different, right? So you start dealing with consistency, with synchronization with your database. Then your database may become a single point of failure or a bottleneck. So it's really complex. And that's why it's usually a good idea just to separate the web server for WebSockets. So what are the challenges that we have? So because now we think that, okay, WebSockets are great. They enable real-time applications, high-frequency update. That's awesome. But then we have a lot of challenges. One of them is just keeping track of your connections, active connections. Every time that you add a new connection or remove, you need to be able to clean up those records. You need to detect connections that are idle or dead. And something very important, you may have users using their devices, their mobile devices, but also their browsers. So now it's not only sending messages to a connection, but rather when you send a message, you likely want to send a message to the user and then broadcast that message to all different devices that the user may be using, okay? So we need to have some way of saving or storing all the possible connections that a user is using or are open for a specific users. And eventually, then we realized that we also wanted to deliver messages, not only to individual connections, but also to groups. It's very common, for instance, that you may want to target only mobile devices when you are sending notifications and not all different connections. That was challenging. So that's not supported by default when you are using WebSockets. That's something that you need to implement. You may also want to target users based on geography. For instance, you may want to send a notification only to users in India and not in Argentina, for instance. Okay, so that's challenging. We also need to talk about scalability, because as we said, we need to keep track of all those connections, and we need a database. So we need to have the ability to do some sort of balancing. We need to be able to add or remove instances. we need to keep track of the state. So we need to ensure that our persistence storage is good, is healthy, and it's usable by every single instance that you are running. And of course, when it comes to availability, we need to start thinking in more complex scenarios like sharding, for instance. Or what if one instance goes down? How do I fall back to another instance if I'm running a load balancer? What if I have sessions that are kind of sticky to a specific server? So all those concerns were there in our WebSocket implementation. That's why it was a very good idea just to separate the web server and manage it isolatedly from your backend server. Now, at some point, we got to SignAlert. SignAlert is a great library, it's a great solution that aims to solve many of these challenges that we have seen. So it provides support for active connections, so you don't need to worry about that. SignAlert already keeps track of active either connections, adding or removing connections as client connects. It also supports message delivery based on groups and targets individual connections. You can broadcast messages to all your connections, set of devices, set of users. So it's very flexible. It's amazing. It already solves the challenge of state management. You don't need to worry about that. It also adds something that is amazing. Is this transport fallback mechanism that automatically detects what your client supports and tries using the best of available options. For instance, if the best option is always use WebSockets, but then if your client doesn't support WebSockets, then SignAlert is smart enough to switch to server-side server-sent events if that's available. And if not, then it always falls back to long polling or polling, right? That's amazing. However, we still need to deal with scalability and availability, because remember, at this time, this was just a library or a custom server that you were building. You install some packages and then you have your server running. So scalability and availability was made easier, okay, but we still need to tackle all those issues. And these are in my opinion, the worst problems that we had. Is now we had to learn a whole new things or a whole new set of things, or how to do things in a new way. You may be thinking, okay, SignAlert is not a framework, it's rather a library, and that's true. But at the end of the day, we had to learn how to implement SignAlert on the client, how to implement SignAlert on the server, and eventually a set of rules and errors that we may get, and a lot of small things that in conjunction are like kind of mini framework. So we had to learn a lot. On the other hand, on the client side, now we need external dependencies. Not only SignAlert dependencies, but SignAlert per se uses another dependencies. In some cases, there are a lot of dependencies. What's the problem with that is that without realizing, now we start having what's called fat clients. Is that your clients now needs libraries that may not be even working that device. Your client may start getting really heavy because of all these dependencies. And of course, I am not taking into account potential security breach that you may be opening because, you don't know, some library or something that is deprecated that was not updated, all that stuff. But at the end of the day, your client was kind of fat, and this was an issue. Now, we got this offering from Azure that's SignAlert as a service. This is amazing. This is amazing because we got all the solutions or the good things that we got with SignAlert, plus scalability and availability, which is awesome. Because when you are using SignAlert, Azure SignAlert, you don't care about anything. You just configure everything and consume the service, and you pay as you go. The more you consume, the more you pay. But you need to take care of scalability, availability, which is huge. Okay, it's not something that that you really want to underlook if you are running at scale, or if you not necessarily millions of users, but at scale. However, we'll still need to deal with this new way of doing things and these external dependencies that your client needs, right? So we are missing something here. There is a piece that we are missing, because we have Signaler as a service, right? Where we don't care about anything. We just create a service and that's all. Or we had to create our own WebSocket server and take care of everything. And this is part of an issue, because if I already have my solution running on WebSockets and I just need to scale, I need something more sophisticated, I probably don't want to implement or re-implement everything. So I just need to be able to scale the WebSocket server without incurring into a whole refactoring and learning new things, and eventually being exposed to some errors or something that can go wrong. Okay, so we were missing a piece, and this is what this service that I am talking today comes to solve. Because Azure Web App Sub is probably the first offering that we're going to have where we have WebSockets as a service. Okay, this is literally amazing, because this means that we don't need to refactor the whole solution and the client and the server. Remember that when we are talking with real-time apps, we always have two different sides. We have the server and we have the front end. So we don't need to refactor all our clients just because we want to scale. This is amazing. We will see that in the demos. So Azure Web App Sub is a service designed for real-time applications. It was the intention of the team that was creating this service is, okay, we want to go with real-time applications at scale. And this must be simple in order to consume and in order to implement. It's a service that is highly available, so if you can even use it for games, okay, so you are safe. It supports native integration, because at the end of the day, you are just using WebSockets, so you don't need to install anything else. Nowadays, almost every single device will support WebSockets, so we are fine. Even IoT devices support WebSockets, so we are fine. And it's 100% managed, which is awesome. That means I'm just going to create my instance, I'm going to just configure a couple of things, and I'm going to use it. I don't need to worry about databases, replicas, shards, anything. I just go ahead and use the service. What are the main features, right? So as I said, no additional dependencies. So I'm emphasizing this point because it's very important. When you're using mobile devices today, they are very powerful. So you may not care about adding more dependencies. But what about IoT devices? Okay, even though they may be powerful enough, but the space, the storage that they have is very limited. And in some cases, your devices will support WebSockets by definition, so you don't care about any other mechanism. That's why including or having the ability to implement this natively is very important. You don't need to depend on any extra library nor dependency. Then it does support message delivery in groups. You can broadcast messages to all your connections or individual connections per user ID or per ID. It does support pushing messages via the REST API or the server SDK or Azure Functions. That we will see an example of that. It's a very, very serverless approach. In the server, remember that the SDK is only for the server, because as we will see, the client is just WebSockets. You don't need anything else, literally anything else. And then the SDKs that today are available are JavaScript, C#, Java, and Python. I'm pretty sure there are more to come as we move forward with this service. Very important, this service is still in preview. And then it does support a different sub-protocols that you can leverage if you want something more sophisticated, like PubSub on the client side and cloud events on the server side. That's very, very important. Okay. If we want to compare Azure, because sometimes it's difficult to understand why would I use this service against Signaler, right? So this is very important to understand. And something that I want to emphasize is not that I'm against Signaler. I just feel that in some situations or some scenarios, Signaler may be overkilling, maybe too much for what we need. So I created this comparison table. When we are talking about Azure Web App Sub, it's only WebSockets, purely WebSockets, anything else. However, when we talk about Signaler, it's just more than just WebSockets, which in some scenarios, that's awesome. Remember that we have this fallback transport mechanism that allows to detect if the client support WebSockets, if not, then it fallbacks to server send events, and if not, it fallbacks automatically to long polling or polling. No additional dependencies. Remember that your client probably supports WebSockets by default, so you don't need to install anything else. However, when you are using Signaler, you do need to install some extra libraries that comes with another dependencies. And of course, since we are not installing anything else, the code will be pretty simple. It's already there. It's pretty simple to understand and to implement. When we are using Signaler, it's a little bit more complex. We need to learn a couple of semantics and heuristic about how the service works. And of course, if you are already using WebSockets, you don't need to do any refactoring. Just go ahead, change your client URL, and you are fine. However, if you want to move to Signaler and you are coming from WebSockets, you have to refactor your clients, okay? Including extra work. Again, this I am assuming that we were using WebSockets. If we are starting from scratch, then we can choose. Then, very important, is to have a notion of how prices are. And as I created this is from the official documentation. As you can see, it's not expensive. You have two different tiers, the free and the standard one. The free, of course, is for development, eventually for something that is very, very small. It's not recommended for something that will go to production. Something remarkable is that you can't scale or you can't go from free to standard. Eventually, you will have to create a new service as a standard. And it's very important to understand how the services built. We are always going to be built by unit, where every single unit in the standard tier will support all this list that we have on the right. 1,000 concurrent connections per unit. Unlimited messages. The first million of messages is for free, and then we pay for additional messages as the last row described. You pay $1 per million of messages. As you can think, it's very, very cheap. The max amount of units that the service can scale is 100. This is on the standard tier. That means that if we do the math, we have eventually 100K concurrent connections, okay, which is a lot. It's really a lot. And just keep that in mind, you pay per unit per day. That means if I am running a standard tier and let's say I'm using 2 units, I'm gonna pay $161 per day per unit. Okay, this is how it's built. So it's about probably $45 per month per unit, which is I believe is very acceptable. Now, the good part is coming. So we will go to the live demo today and now, and we will create a service and review how the portal look like, so we get familiar with the service. And then we will see a very simple and basic server and client solution. We will see how a serverless approach will look like using Azure Functions. This is important because that means that I don't need to handle either my own server. And then we will see how, because it's something curious, the way I'm going to start working with it is getting connections from the Azure portal. And of course, this is not something that you can do in production. That there must be a way just to handle this connection automatically. We will see that in a minute. And a very there is a disclaimer I want to say is the best thing of this service is simplicity, and you will see that in the code. What you will see actually is very simple code, easy to understand, and that's why I believe this is a revolution in how we implement WebSockets. Because when you see the code, it's very simple. Okay, so now let's go to the Azure portal. I am here just in Azure. I do have created my already an instance just in order to just to avoid, because it can take up to 10 or 15 minutes just to get the service running. So I'm gonna go to create resource. Let's give it a minute. Okay, and let's look for web app sub service. There we go. Let's create the service. You have a few documentations. Just take a look, and remember the service is still in preview, which means that it's not fully recommended going to production with services that are in preview. It's not because it's not secure, it's just that you have to expect some changes, so be careful. Keep that in mind. So let's go with create. Of course, that you have to select your subscription. Resource group, this is pretty common. Eventually, you will get to this resource name. As you can see, this must be unique across this subdomain. Okay, so you can do whatever you want. You need to select a region. Remember that this service is meant to be a scale, so you don't worry about different replications because the service is meant to be highly available, so there are many things that you don't need to consider. And then you must select, as you can see, the subdomain is already taken already. So let's start demo 1. And then you need to select the tier that you are using. Only 2 available, free and standard. If I go with the free tier, I can select the unit count. It's only 1. But if you go with the standard, then I can go up to 100. Remember that you pay per unit per day. Keep that in mind. And remember that you can escape from the free tier to the standard tier. So keep that in mind. Then it's just about reviewing and creating, and that's all. So as I said, I have my service already created. So let's take a look at how it looks like. There we go. So as you can see, it's very, very, very simple. Okay, it's not that much, and in reality, you don't need too many things. And the reason is because it's a WebSocket as a service. The important part that we need to keep in mind here is this section, is keys, because this is what we need when we want to connect. This is pretty common. Almost every Azure service supports these keys and connections things. This is what we need to implement. And then we will see in a minute, we will have this client URL generator. Okay, then you have some options like settings that you can set up, handlers for hubs, etc. This is for more advanced scenarios. So let's go to see the code. This is not too much what we need here, so pretty simple. Now let's move to Visual Studio. I'm gonna start with a very basic example using a publisher or a producer and then a consumer. So let's go with the publisher. Remember that as I told you, we have available an API. So eventually, if there is no SDK for the language that you are using, you can always publish messages via the REST API. But if you are running JavaScript, Java, C# or Python, there is this Azure Messaging Web Apps library that works as a framework. It's pretty simple to implement. You just need to instantiate your web app service client, providing a connection string and a hub. Remember that we are always using hubs that represent groups of users that we are going to send notifications. A client will connect to a specific hub within the same service. And then this is as simple as send to all message. So let's take a look. What options we have? We have this send to all, and as we've seen, we can also send messages to groups or to users. Okay, this is also pretty simple. We just need to indicate the group and the user ID. So this is a code, and as you can see, I'm gonna need a string connection and a hub name. We will go in a minute with that. And then I have a consumer. Let's start with, this is a very simple console app. As you can see, I don't need any external dependencies. I'm just using the WebSocket library. You can use whatever you want, but it's very important. I'm not installing anything specific for the service. Okay? And again, pretty simple. I just need to create my WebSocket client, providing a client access URL, and eventually just subscribe to messages. Okay? And here I have just a plain HTML example, just to give you an idea how simple this service is. And again, I'm not installing any external libraries. I don't need to include any other packages. This is fully supported by the browser. It's just about creating a WebSocket, providing a client access URL. That's all. And then subscribing to new messages. Of course, you still have all the things that you want, like open connection, close connection, etc., as you will have when you are working with WebSockets. Nothing else. So now let's come back to the Azure portal and let's configure our server. So I'm gonna grab this connection string. I'm gonna replace here connection string. There we go. I'm gonna give it a hub name. Okay, let's say AC community, and let's save it. Now, let's come back to the Azure portal, and I'm gonna use this helper in order to create a client URL. Remember that we need to use the same hub, AC community. Okay. Eventually, I can check the send to group, join to groups if I want a specific client to use a set of groups. And I'm gonna copy this URL. And as you can see, it looks like a regular WebSocket string, connection string, nothing fancy. So from the client side, it's pretty transparent. It's pretty straightforward. So let's go to the client and let's include the client URL. There we go. Let's save it. And let's do the same for this plain HTML client. For it, there we go. So the only thing I did is just configuring my client access URL in both the HTML client and the console app client. And then in the server, the same. I added my connection string, including a hub name, and that's all. So let's run them both together. Set a startup project, multiple startup. I'm gonna go consumer and publisher. Apply. There we go. They are running. Okay, this is the producer. I'm gonna use it for sending messages, and here is the consumer. There we go. On the other hand, let's open this HTML client. Open containing folder, and let's go and use Chrome. There we go. Let's bring together the client. There we go. Now, let's push some messages. There we go. I'm missing something. Oh, sorry, I closed the connection. Let's go one more time. Let's stop it. Let's double check the hub name. There we go. Double check. That's correct. And let's ensure that I am using the correct. There we go. Let's start one more time. There we go. And let's refresh. There we go. There we go, demo message. And as you can see, pretty simple. One more time. That's all what I needed. And I have a pure HTML client running and a console app running without including any dependency. Pretty simple. Okay, one more message. For testing demo, there we go. Awesome. And remember, so what we are showcasing here is how simple it is to implement WebSockets via Azure PubSub service. I'm not including any external dependencies, pretty simple code, so that's awesome. Now, let's review the serverless approach that we said. So let's go back to Visual Studio. Now, this producer forces me just to have my instance running. So that's awesome, but I prefer something more serverless, probably Azure Functions. So we said that this service supports natively Azure Functions, not only for producing events, but also for consuming events. So let's see how an example will look like. So in this case, so I do have an HTTP trigger, which is almost like an API that I'm using in order to get the request. And the only thing I'm going to do is just to push messages that I'm getting from the API. In order to make it work, we need to install only one package, which is microsoft.azure.webshops.extensions.webpubsub. And now we have available this output binding, which is the webpubsub. The only thing that we need here, again, is connection string and hub. We need to use this webpubsub operation since I want to have my code running asynchronously. Azure Functions provide you this async collector. It's pretty simple. But at the end of the day, what we are doing is just creating this object, which is send to all. We need to write as binary data the message and then a data type, and that's all what we need. Eventually, as we've seen, we can still send messages by groups or to individuals, right? So let's configure the Azure function and let's see how it goes. So we're gonna grab the same connection string. Let's go to the publisher. So let's go to the local settings. We have this setting. I'm gonna grab this connection string setting. This is how it works. This is from Azure Functions. You always indicate the name of the of the configuration that you want to use, and that's what you configure as your setting name. And then we need to configure the hub. We said AC community. There we go. I will have an HTTP trigger that will expose a get endpoint at serverless publish that I can use from the browser. And I'm just reading a query string parameter message, and that's what we are going to push as a message. So let's run it. This time, let's set up not the publisher, but rather the serverless publisher. I'm going to keep my consumers running so I can see the messages going through. There we go. Let's run the solution. Here we go. This is the consumer. This is the Azure function. And let's refresh the client. Let's use this endpoint. And let's add some message. There we go. Send it, doing something, message sent. So we got our logs in the Azure function. I think I didn't refresh. One more time. Let's see. Let's start one more time. I think I didn't refresh the client. Let's double check. It's keep in mind that the hub must be correct. So if you miss this, you won't receive messages on the client. So this is the Azure function. There we go. This is connected. There we go. Let's go with the client and let's push the message sent. There we go. Did I miss something? I guess I'm missing something. There we go. Well, I'm not getting messages in the consumer. So I guess one more time. There we go. Well, for some reason, so let's give it one more time. Let's double check I'm writing correctly. Connection string. There we go. There was a typo here. Do you see? Let's fix it. Azure Community. Now there is a typo here. That's why it wasn't working. Let's create a new connection. Let's copy this one and let's fix the consumers program. This is real life demos. Let's run it one more time. There we go. We have the consumer. We have the Azure function running. And let's refresh the connection and let's push the message. There we go. Now we have messages pushed and the Azure function running. Pretty simple. Again, just keep an eye on the hub. So I had a typo here and that's why it was failing. This is very important. But as you can see, just by using the output binding, the only thing that you need to do is just pushing new messages. If you want to send to all, this is the way to go. Eventually, you can use send to groups or send to individuals. Now, one more detail that we need to keep an eye on. So far, whenever I needed just a client connection, I was coming here and using this client URL generator. Of course, that this is not something that you do in production. In production, your client must be able to call something. Let's say I'm going to show you in a minute what that something looks like, and request a URL, a valid URL, so that the client can connect. So how do we do that? This is a last example. So this is the recommended approach. There may be others, but I am creating just a very basic web application. In this case, it's an API. This API will include this negotiate controller. You will authenticate and authorize this API as usually in exactly the same way that you may be handling authorization and authentication for the whole API or your app. But I'm going to include a new endpoint, in this case, API negotiate, okay, where I'm going to use the same Webpack sub-service client to generate a client access URI, okay, and that's all what you need. So let's see how this looks like. Let's set up a startup project. Again, I'm using the dependency injection, this helper, which is add Azure clients, and then Webpack sub-service. Again, I need to include the connection string and the hub. So let's grab both hub and connection string. There we go. And that's all. I had to install again Azure Messaging Webpack Sub, which is the same we use for the console application publisher. Nothing too fancy, and that's all what you need. So we are adding an extra controller that you will authorize as usual, and then you will use the client to generate a client URL. So let's run it and let's see how it looks like. There we go. And let's give it a try. There we go. And now we got our connection that we can use. So let's grab that connection. Last part of the demo. I'm gonna update. There we go. And let's run them again, just to be sure that it does work. Let's remove the serverless. Let's start the publisher. Okay. And let's run. I'm not gonna fix the typo here because I created the URL using the same mechanism. So let's run them both. This is the producer. I think I close it one more time. Let's make it smaller. There we go. And that's how you get authorized and authenticated connections from your clients to use the service. So again, let's recap. we started creating a very basic, let's close everything, a very basic console app that works as a producer. The only thing that we did is installing Azure Messaging Web Apps Hub, and by using the services where we need to provide a connection string and a hub, the only thing that we are going to do is send to all, send to group, or send to individual users. And then from the client side, nothing fancy, just pure WebSocket implementation. Same for the pure HTML implementation. As you can see, no extra dependencies. Very simple. Then, if we want to go with the serverless approach, we created an Azure function. In this case, this is an HTTP trigger, but it can be also a message queue trigger depending on your needs. And we're using this output binding, which is Web Apps Hub. Again, we had to install this extension.webappshub package. And the only thing that we are doing is using this async collector of Web Apps Hub operation in order to push messages. This is the way to go. The same happens if you want to have your serverless consumer, but instead of using this Web Apps Hub, you will need to use the proper input binding attribute. And finally, what we've seen is how can I get authenticated URLs in production without using the Azure helper that we saw. And one of the proposals is just creating an API with an endpoint. In this case, I decided to name it API Negotiate. And again, by using the same client that we use in the console application, we are just requesting a client access URI that will return back to our users. Then, since this is a regular API, we will handle authentication and authorization as usual, nothing too fancy. Now, let's go back to the presentation. I think we are on time. And let's recap on the main features. Remember, designed for real-time applications is meant to be very scalable service, highly available, native integration, and 100% managed. You don't care about scalability, replication, redundancy, etc. It does support a message delivery per groups, individual or all. You can push messages via the REST API, different service SDKs, as you can see. I showcase C# example, and you can also use Azure Functions for a serverless approach. There are SDKs for JavaScript, C#, Python, and Java. There are some sub-protocols that you can leverage depending on your scenario. And pricing, remember that you are paying per unit per day, and the standard is the recommended for production. Then we had a live demo, and that's all. So thank you very much. I hope you guys enjoyed the session. Remember that just the service is still in preview, so keep an eye on if you are running on production, and just you shouldn't expect breaking changes at this point, but there may be changes in the service. And that's all. Let's recap on our partners and Q&A if there are any.
Hi, Faku. We have one question. Let me pull that into the screen. Is it compatible with standard WS NPM module?
Yes, absolutely. I didn't showcase that, but since this is a plain HTML code, right? So purely JavaScript client. If you were using React, Vue.js, or Angular, and there is a module for that, you can use it totally for free. So remember that at the end of the day, it's just purely WebSocket. Whatever that supports WebSocket will work.
Okay. And let's wait for 2 more minutes for any other questions.
Awesome. Yes, this is why I believe this this service is really amazing because when you look at the code, you don't see complexity here. It's pretty simple, pretty straightforward, and at scale. And I believe it's still cheaper than Signaler. This is a client. Again, I'm not using any external dependencies, just regular WebSocket libraries.
Sorry to interrupt you.
Thanks, Feku. I think we don't have any other questions. Thanks for your time, and it's a very nice session and very informative with the demo.
Awesome.
Thanks a lot for that.
Thank you very much. It was a pleasure, and congratulations, guys. Great event.
Thank you.
Thank you. Bye-bye.
Bye.